Okay. Hi, boss.
Yeah.
Yes.
Okay, so I'll just grab your full name, IC, and email address. This one to prepare attendance and certificate.
Okay. So what should
Full name according to IC, IC number, and email address.
full name, IC number, and
Email address. Email address you personal. So only at the end of the training, hard copy I will provide to you. Digital copy I will email.
okay. All right. Thank you.
Okay. My name is Lucas Waller. I'm the manager.
Oh, what's the name?
Your case, your case.
Lucas.
Your case, yeah.
No cash.
Your case.
Oh, your cash. Okay.
So yes, Mr. Vivian is your trainer.
Okay.
Okay, so I'll just give a quick introduction and I'll proceed with him.
Okay.
Okay, sure. So yeah, we have two company names, AS Automation Services, which was established in 2012 by my boss, Mr. Sunil. So he's now retired. He's only they used to call him Mr. Tisun. He worked in China for almost 3.5 years plus.
Okay.
So his background, he was an ex-army technician under QDM in Malaysia. Then after he completed his studies in Royal Australian Air Force under instrumentation, and then he was serving under the army. After he completed his service, he came here. He's from Kedah. And then he came here. At that time, he's now 75. He's now 75 years old. Consider he's retired because of his health condition. So he took over his place. Then he came here, he looked for a job in Singapore, and he did his industrial automation diploma in Nanyang Poly.
Okay.
Since then until now, the first PLC he touched was the old model. Later, Divya will show it to you. The old model S5 PLC. Okay. So the one you're learning one is a newer model one. So he became passionate. He started and he completed his industrial automation diploma in Nanyang Poly. Then, like I said, first he focused on services and projects. Then in 2014 we registered ourselves as a training provider under HRDCorp. So since then until now, 3,000 plus participants.
Okay.
Then not only for Siemens, like I said, for other PLC brands also we used to train, and all don't know how they find us. They come here and learn from us.
Or even the foreigner coming for trading.
Matsali also.
Yeah.
They come here.
Good sisters here.
So okay, then in 2015, Tivian joined us. He's from Johor Poly, graduate, and he did his studies in UTM as well. And he's working for us full time already now. And then he is completely trained also. So he took over his place now. So he got out of the training. And so I, as a marketer, whatever project services I bring in, I toss that job on him. He gained that experience. We share it to our clients. So our training is like, we touch a little bit of theory, and we straight away jump on hands-on all the way.
That's good.
Okay, so the bottle is right over the manual is right over there. You need a soft copy manual, you can, I think it should be in the laptop. Yeah, it should be in the laptop, you can grab it as well. Yeah, training manual, switch are right over there. If you need to grab coffee or anything, drink one coffee, hot water, like that, you can grab the glass DIY. You can bring it over here, just make sure you don't accidentally spill it or what.
Okay.
So I just pass it to him when he starts training first. Yeah, bro.
Alright. Thank you, Yogesh.
Okay.
Okay.
Chan.
Yes.
Okay. So as we discussed earlier, your mainly do commissioning, right?
Yes, mainly do commissioning. Yes. So these are, but it is still interested to cover the whole scope here. That's why I go with
Okay. So your projects mainly you use what PLC?
Siemens. All the time I still
Using Siemens, right?
sometimes I Sim and Bradley, but not frequent. Most of the time still Siemens. Yeah.
Siemens, okay.
Yeah.
Because Siemens Malaysia very common.
Yeah.
Siemens, Rally, Mitsubishi, Omron. These four are very common in Malaysia. According for our training request also same. Like last month, I think straight 4 weeks straight I do Siemens.
Everyone
4 weeks
uses
straight.
Siemens,
Every Monday to Friday Siemens. Monday to Friday Siemens.
I want to ask, I know that now we are using 1200, right?
Yeah.
If I learn 1200, it will be easily transferable to commissioning 1500.
Yes,
Same thing, right?
Same thing. I have also.
Oh, it's just that their spec and the IO is different.
Yeah, because it's just a smaller one. Bigger one, there's a difference.
Because always I see 1500. Yeah.
Okay. That one you can like we can tell like maximum can go to 1000 of IOs. Okay. Yeah. So all PLC are same. They have a smaller model, bigger models.
But both also like support how you say the redundancy.
No, that one only support redundancy.
The redundancy is like two PLC,
Yes,
right?
two
And then you
PLC
bring-
run only control one system, right?
Yes.
Only support in 1005.
Oh,
Mm.
1005. Okay,
Yes.
got it.
1200 won't support the redundancy. Same for the previous models also lah. Same thing. Okay.
Okay.
Never mind. So where you stay?
I don't know what is the place. Yeah, it's from here it goes straight to there, and then there is like a small Indian town.
Yeah. That area lah.
Yeah.
Oh, okay. So this area called Kampoi.
But here, I think it's called Dampoy.
Yeah.
Okay. I thought it's not SCADA. SCADA is part of Dampoy. Oh, by the way, I have to pay the car park, is it?
Yeah, of course.
Oh, okay.
You can grab the card there. Can you see on the card? Yes.
I can put it down, right?
Yeah. When you come up, you can use the card. Hmm? No, you left this phone in the car.
Oh.
Hmm? Yeah, tell him. If the
You got me through. So, like, how I should choose a daily or hourly?
MB, no, cannot use MB already. Another one, MBJB.
Not in here. Oh, so this is the wrong apps.
Need to download the new app. MB, you download MBJB Spot.
MBJB.
Yeah.
This one.
Yes.
Damn it.
Because this area is under MBJB. If you go to
It's
town area, yes, it's MBIP. If you have to use Wi-Fi, the Wi-Fi is the IP address.
Oh, okay.
Because sometimes this area, the line is very slow.
how to, so I should choose hourly or weekly?
Hourly.
Hourly,
No,
okay.
no. Okay, if you look for daily, can let's go to
Daily.
the day.
Okay, thank you.
Because
Got
tomorrow
it.
only.
Tomorrow, today is a Friday, tomorrow don't have, right?
Tomorrow, yes.
Or still have to pay that. Okay, okay.
Only Sunday only.
Thank you. Okay. Good to go.
Yes. Now, you can right click here. I mean, you can create a folder in the desktop. Okay, you can put your name. So whatever project we do, you can save here. So later, on the last day, you can copy the files.
Okay.
Right.
Okay.
Then you go to the Siemens training. Okay. So this is the training manual. The manual.
This
Yes,
one.
the soft copy here. So this one is like later you can copy. Okay, you can open this one. Yes. Okay, let's make it bigger. Okay. You can open a slide. Okay. So this training will be Siemens training. Siemens training using TI portal. So can use for the 1200 and also
V18 or I think I see that this is a V20, right?
yeah, V20.
But
Yes.
doesn't matter, right?
Doesn't matter.
Okay.
We start from they started with V10 version 10 because they released the TI portal in 2010. So before this is called SIMATIC Manager. Have you
Yeah.
you know, right?
I know. Long time ago they
Last time, yeah, SIMATIC Manager. Since 2010 they use TI portal. So now the latest one is version 20. So this one is I'm using version 18. Because whenever they release a new hardware, I mean new version, the hardware is still the same. So for the hardware they will release new firmware. Like iOS, right? They will add a new firmware. So when they release new firmware, so it can support new features, new functions. But the old function all is still there. I mean the new features mainly is like have you heard about OPC?
I know what is it. The
Ah,
networking OPC.
Yeah, networking data transfer lah. So they upgrade on that system.
Oh, you mean the newer version is
New version,
OPC?
so the older version also can use, but the new version is already built in. For older version, you have to use like additional software to do the data transfer or all that.
You mean the OPC within the device,
Yes,
right? The
yes.
PLC has an OPC.
Yes, the PLC already built in the OPC.
Okay, got it. So
Okay.
there's a difference. Okay.
Yeah, that's the
The
main
new
small
software
difference.
support the OPC.
And another difference is the security.
Also stronger.
Yes, security also stronger. So the newer firmware, all they have what? There's a security certificate built in the PLC.
You say the OPC is the only the firmware side. It's not the hardware difference, right?
No hardware difference. Hardware is still the same.
Only updated the firmware.
The
You can
firmware.
support the OPC
Yes,
already.
yes.
Oh, okay. Got
Okay.
it. Got it. Yeah.
Next. So this one you know like what is PLC, right? Because
Yeah.
you're working on this, okay? PLC very simple. You want to automate anything? For industry, we use PLC lah.
Do you familiar with the EMS?
BMS, I know BMS, but
Much simpler.
what is it? Because BMS they have their own controller also.
Yeah.
But I'm no Schneider, they're famous for that. But other brands I'm not sure.
That they can easily compatible to like work with that Siemens PLC, right?
Yeah, any PLC you can use BMS.
Okay.
Okay, what is the difference in BMS? Okay, building management system, right? So building management system normally you control what? AHU, HVAC system,
Right.
fire alarm, okay, all that, okay. So BMS controller, because I know, because one of my friends is working in one company, they do BMS in Penang. They call what macro integration. Okay, they mainly focus on BMS systems. So they have a Schneider BMS controller. So the controller is they already building blocks inside for HVAC system, AHU system, temperature, pressure controls.
Everything is very modular.
They already
Yeah.
modular. So they just so whenever the hardware is ready in the program, they just need to drag and drop. Okay, connect all the IOs. So
Very
the
graphical.
programming is very less when you want to do programming. At the same time, they also use Siemens PLC because sometimes the client requests to use PLC. Some of the company they say they don't care what system, what hardware you use. Some company they request for PLC. So PLC also can control, but PLC is empty. So you need to create all the programs.
Okay. So let's say your friend, he is integrating both BMS and PLC, both are present, both are working together.
No.
Only PLC.
Only PLC. No. It's okay. BMS is a system, right?
Ah.
Okay. So you can control BMS using PLC also can. BMS controller also can.
Yeah.
Yeah,
Last time
controller.
actually I use my last project all was using PLC.
Oh,
No
PLC.
no shit there.
No, the special controller
No
lah.
special controller. But I'm wondering in other project do they integrate both together? Like
Can also.
Can also.
Can
Like
also.
one Schneider BMS controller, maybe multiple.
Yes,
And then they are PLC as well, and then they are talking to each
Yes,
other.
yes, you can drag.
Like
Take the
internet,
data.
yeah.
From the BMS controller, make sure it support. So you need to know what is the communication protocol the BMS can support. Like even we can use OPC, we can use Modbus. So because PLC can support Modbus, can support OPC. Even Siemens they have their own communication called Profinet, Profibus, right? So we must know very simple. If you want to take data from any controller, any system, you need to know what your PLC can read, what are the communication
protocol you can
protocols
use, yeah.
can use. What are so for the device you need to know what are the protocol the device can use.
Got it.
So then you can see, let's say the device only can use Modbus. So you see your PLC can support Modbus, can take data.
I think there's a part I really focus that I want to ask you a lot of questions. It's
Yeah,
on the
sure.
overall architecture and configuration and troubleshooting.
Sure.
Yeah. Okay. Yeah. Understand. Thank you.
Okay. Alright. So this one you know lah. Go to next. Okay. So this is about the Siemens history lah. Okay. Siemens started with they call SIMATIC controller. Okay, SIMATIC controller, but it's not a programmable controller. It's already like configured, but very old system. I think it's around 50s. Okay, because like 50s machine are always similar systems. Like you press this on, you press this off, timer, counter, a simple one, right? Okay, so they come up with the SIMATIC controller. After that, they come with the S3 controller. Okay, it's still not programmable. Okay, it's like a controller. It's already fixed. Like BMS example. It's already fixed. Just connect all the cables. Just need to know which one to use. Started with S5 only is a programmable. Means you can program the PLC. Okay, so this is S5. Have you seen this one?
Never. This one is really
Very old. Late 70s PLC.
70s.
Yeah, 70s.
And this is a U electrical.
Yeah.
Okay.
So this is the CPU. They have some incredible. You see digital incredible.
Very nice. Who is from?
Then from the machine we convert the system
Oh, okay.
from the S5 to the S7.
Cool.
So we see it still can use because this one the system some of the I/O is already spoiled. So So very hard to get spare parts. So they convert this into the newer one. So this one they want to scrap it, so we just bring it.
Oh, then, okay.
Because still comes, still some company are using this.
Your opportunity lah, ask them to upgrade.
Yeah, because I do a lot of that kind of projects because you don't need to do the programming because his programming is ready. Because programming, one of the time consuming part is the programming.
Very long time.
Very long time because other than that, the hardware is already everything. Because when they do when they decide to do a project, right? Okay, so they come up with all the process, what the process, I/O, everything, right?
But you cannot migrate directly, right? How you say? The program is inside. You have to go in and learn the program and you can direct migrate.
Yes.
Oh.
Siemens to Siemens, yes, can.
Can
Can.
from like S5 to S7.
Yes.
Oh, okay.
They have the function in this version, this software.
Oh,
In the SIMATIC Manager software, they have a function from this to this convert. If I say you want to convert from this to 1002, you need to convert to SIMATIC Manager first, then only can convert to TI model.
Oh,
But
okay.
when you convert to SIMATIC Manager, you need to do the flow because very big.
Mm.
You can study the flow. But what you can study, okay, what are the inputs they use, how many inputs you use, what are the memory they use, everything you do. Then you check with the other brand, so how to use that particular IOs, everything. And they use timers different. So if you want to do that, you must know both the programming. Then only you can convert. So we do a lot of that projects.
Do a lot of that, convert from one brand to another.
Yeah, one brand to one brand. The older
client
model
want to
to
do
the
that.
new model. What's that?
The client want to do that. Like he's using.
Some company what happen is okay. They have some newer machines or that. Let's say all Siemens. One whole machine is using Mitsubishi. So I done one for the company. So they have their company. They have Siemens, Omron, and Mitsubishi. So what happened? Most of the machine are Siemens. So one of the engineer he come for training lah. So he come and learn Siemens. They have one machine Mitsubishi, one is Omron. So they say the Omron is okay because very simple. The Mitsubishi one, what happened? Always give problem. CPU. So they want me to change the PLC new. They asked me to change the whole set lah. Okay, then I said this one is already old. I can source for you the old model, can, because it's not in production already obsolete, right? Then I tell them, but in the future another 10 years is parts already. So better to change a new one. Then I suggest them change the new Mitsubishi. Then they say no, can you change to Siemens? Because my other model of Siemens, my engineer also know how to troubleshoot Siemens. And I say yes, can. Then I back up everything. Luckily, but the first thing is make sure the machine is in run condition. Machine can run, only the CPU sometimes got error. So the program is okay. So I back up the program, I study the program, I redo in Siemens. Then I took like 1 week. I go there like 4 days, 3 days plus I do the wiring everything. Take out then another 2 days because I already ready with the program. So I just go download, then do the commission.
What kind of machine or production line is that?
That one they produce cables.
Produce cable.
Yes.
Or like a whole production line for the cable.
So what happened is like the multi-core cable.
Ah.
It's very thick. I forget already. I think it's around how big? I think 0. The core it's a single core. I think it's 0.7. Very big. So they have a 7 core. They must coil together, twist, and go into a drum.
Okay.
And the system they don't have HMI also. They just have a button. They have there's one company, 2 companies, cable company. They star machines running on that. One aluminium company still using that. Okay.
I see you here, right? 1200 and 1500, right? Other than these 2 models, what are the other?
Okay, in PLC. Second generation is S7.
Okay.
Okay. The second generation generation is S7-1200. 200 is this one. At the back, at the back. Here.
Oh, okay.
Ah.
Oh, also never said.
Never seen that?
No.
This is 200.
Okay.
Mostly you can see the machines you buy from China, you can see this model.
Only they configure with S7 is what? SIMATIC.
No, it's using microwave software.
Oh, even older.
Yeah. Microwave software. I mean, give you. Okay. So second generation is 200, 300 and 400. Okay.
Okay.
So this is 300, you know, right?
No,
Ever seen before?
never said
Ah,
before.
okay.
But I always, this one sometimes see very.
S7 300, 315. This is 300 and this is 400.
Okay, okay.
Okay. So
Oh, this is because the color faded, is it?
actually
Originally it's the same
no,
color.
no, 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 no. Must be this color.
Must be this color.
When I don't have, it's a bit faded. Must be.
Yeah, this one I think I see more common. Second.
Yeah.
Yeah.
All is old one. The new one I have in my house. Okay, some similar to this color like you buy.
Yeah.
Okay. So what happened? 300, 400 and ET. This is ET 200.
This is this is IOM.
You can use as a IOM also can. You mean remote IO, right?
Yeah.
Can use as a can or can use as a CPU. CPU also can.
What is that?
Can use as a CPU also can.
This one can use as a CPU? Oh. Okay.
Okay. So these three models is using SIMATIC manager.
Okay.
So in this model, only this one can do redundancy.
Okay.
This one cannot do redundancy. Okay. So even though this one is very, can control very big system. Okay. Sometimes they use this one because very expensive this one. This one because they want to do redundancy.
Got it.
Then what happened? The CPU they use this. The IOs they use this remote IO. Can you see ET200MR? It's an interface module.
Okay.
So the CPU they use that. The IOs they use this or this one. Also can. But not very common like this one. They use this one. But this one are very less IOD. Maximum this one can go only 8 inputs.
Okay.
This one card can go up to 32 lines. 22 IOs.
Okay. Got it.
Okay. Then, so that is the second generation, the 200, 300, 400, 200. Then later on, they released S7-1200 Smart. This one from Siemens, China. They released this one. Okay. When they released this one, they released a new software called Microwave Smart. Okay. Actually, it's the same thing. Only this one is this newer software. The graphic is colorful. This one is an older one. Okay, that's the main difference. Second difference is the 200 don't have Ethernet port. This one.
Okay.
200. So when they come with the new model, the S7-1200 Smart come with the Ethernet port.
Okay.
Okay, because 300, 400 all because this one you can see. They have Ethernet also.
Okay.
They have Ethernet and serial port lah.
This is a Profinet, right?
Profibus.
Profibus. Oh.
Yes. If you see this color, Profibus.
Okay.
This port is called Profinet.
Okay.
Ethernet we call Profinet.
Okay.
The 9 pin they call Profibus.
So under here it's a 9-pin also.
Yeah.
Profibus is always using 9-pin and only by Siemens.
Yes. Siemens. Because it's a Siemens protocol.
Okay. So this is only between the Siemens module to module lah.
Siemens module to module. Even this one can go to the other brand of VFDs.
Some of the VFDs support the Profibus.
Yes. Like ABB and for.
But how you do it? Because like one module you only have one Profibus, right?
Yeah, because it's jump anyway.
Also you can have multiple like on top of each other?
No, no, no. Okay. So let's say for example, this is the system.
Mm.
So I'm using a Profibus. Okay, this one is a Reno IO.
Okay.
Let's say I have a VFD. So from here, because this one can go in and out. In and out.
So you have two people here.
Yes. So this one is in, then another one go to the VFD.
Oh, this kind is called what? Daisy chain. Or there's no such thing. Just this is how they do it. One in, one out, one in, one out.
Yeah.
So it's in a series.
Yes, a series, or you can loop it also again.
Loop also
One
can.
cycle also can.
So loop it, you have the what you call that? Don't have this single point failure lah. You can have both sides.
Yes, both sides, but I'm not sure. I forget again the term they use.
Oh, never mind. Just understand. Okay, so this is how they do. One
Yes.
in, one out
Yes.
to ring everything together.
Yes, you can use in a ring version also can, or just straight also.
Okay, got
Or
it.
like a closed loop also you can.
Okay, thank you.
Okay, but this one is Profibus, this color.
Okay.
So any other brand also can. But make sure the particular brand must support Profibus.
Okay.
If they don't have Profibus, then I can use this.
Got it.
Maybe I can use analog to control the speed, or I must use another protocol like Modbus.
Okay, got it. Yeah. Okay.
Then, so in 2010, they come up with TIA portal.
Okay.
So TIA portal, they release new software. I mean new two hardware lah. That is 1002, 1005. Actually, there's another one. I forget to put it here. 1002, 1005. Another one is the ET200, similar to this.
Also, you say this is can act as a CPU as well?
Yes, similar to this but that color.
Oh.
I don't have the model.
Okay.
Okay.
Got it.
So, actually 1002 is replaced for 300 actually. The 1005 is like considered replaced of both of these lah. Example, because 1002 is because 300 they have a small spec and also high spec. Smaller one is it's the same size, but it's like a small spec only, less I/O, less memory. So
okay,
for
okay.
that they convert to 1002.
Okay.
So what happened? They don't have 200 ready. So like if you any system using this the 300 smaller version or the 200 smaller version, you can go for want to convert can go to 1002. If you have any version that is using this one but more I/O and the 400, you can go for 1500.
Okay, got it.
Okay.
Yeah.
And at the same time, the 300, 400 and the ET200, you can program in TIA portal.
Got it.
Yes.
Okay.
Because why? It's just like upgrade. The SIMATIC manager is just upgrade only. Because the software inside is the same thing. It's the same software. But of course the graphic all different already. So what happened is that this. Okay. So earlier they have a SIMATIC manager. So this one is for the S7-1500, 400, ET200. Okay. The software inside actually they call step 7 lah. They call step 7. But they have a professional, basics, all that. They have two type lah. Professional or basics. Okay, the software inside here. Okay. And for touch panel they use WinCC flexible. Okay. This touch panel that touch panel HMI they use WinCC flexible. This one for the SIMATIC HMI. Okay. Then for SCADA, right? They use WinCC Explorer. Okay, so they have three different softwares for PLC, one software, SIMATIC Manager, for HMI, it's WinCC Flexible, for SCADA is this one, right? They combine all these three together, they come up with TIA portal.
WinCC flexible is for that small
The HMI, yes.
Oh, okay.
Ah,
Mine all three into the TIA.
yes. So all these three, you go to TIA portal. But TIA portal, they have different license lah. Okay. For the PLC, they have step 7 basic or pro. It's still the same thing, right? PLC. For PLC program, if you buy the software, TIA portal only for PLC. You can buy the license step 7 basics or professional. But the basics means only can do program for 1002 and some of the basic HMI. If you buy professional, you can do programming for all this model and also some HMIs. Okay. So then they have WinCC Advanced. This one is because this one is already at some basic HMI. This one some comfort HMI, some advanced HMI, all that. Then they have another version called WinCC Professional. This one, if you buy the license, this one is for the SCADA.
Oh, only the Pro is for the SCADA?
Yes, only the Pro.
The first whatever is not for the SCADA?
Advanced don't have SCADA. They have a runtime. They have a runtime. It's like they call you can call it mini SCADA lah. But they don't have all the features you have in here.
What is the difference between you say
The mini.
yeah, you say the mini and the Pro?
Mini and Pro, okay. Mini is like basic protocols only they have. Like OPC, of course, still have OPC. Some of the models can support all that. Okay. This one because OPC they have OPC UA, Universal. I forget.
That one go to the IT.
Yes, IT everything. That one only can support in WinCC Professional.
Oh.
For this one, they have a basic OPC only. Still you can use.
As a historian, everything is still all the same.
Historian is you must use professional.
Okay, so actually most of the people will use a Pro lah.
Yeah, of course you must buy. If you want to use SCADA already, then you must buy the license. So you just buy Step 7 Professional, then WinCC Pro. Because WinCC Pro is already combined with Advanced already.
Okay. Okay, got it.
So you just buy full version means these two lah. If you don't want the SCADA, don't want to use SCADA because you are to okay. Who need to buy these two, right? The company need to buy. The end user need to buy this.
End user. The runtime is together with this.
Yeah, one runtime because WinCC Professional is that. So because they only going to use the WinCC.
Okay.
But the machine maker, right? Machine maker of course they want to do project. Programmer of course they need to use this one lah. Of course. Let's say the programmer they just do PLC and HMI only. Yeah, this company are not using SCADA. They just need to buy these two.
If they are not the one build the SCADA.
Yes.
Okay. Okay, got it.
Okay.
Yeah.
So like TIA portal they have step 7 basic, right? So that's why what happened, they release S7-1200, 1005 and 8200. They call 8200 SP. I don't have the model. So when TIA portal they release new lah. At the same time it can support S7-300, 400, 8200.
Okay.
That's why they use TIA portal nowadays. Even because some of the project you see, sometimes they still use 300. You know what? I can tell you this one is compared to this one is one more robust. The durability very high. This one compared to this, even this one 1500.
The old model actually perform better.
Perform better. You can see because the S5 still company using. So you can know how durable one. Because some of the even if you ask, because I in the Facebook, right? right? They have a lot of groups, right? So I have joined a few Siemens group. They always discuss about this, the programmers, or sometimes someone asks which one better. Always they say 300. But now the latest model, I can tell you, like a few years back they will tell 300 is still okay. But nowadays, okay, like 1,000, 2,000, all meters. Okay, that's one. Okay, so this is about how they come up with, because their model is, but the name is that totally integrated automation.
Oh, the full name is totally
Integrated automation. Yeah.
Okay.
Because now all the brand they become like this. Previously it's like 3 different softwares, 2 softwares. Now they combine together in one system. Right? See, like elementary is the same. Elementary last time for PLC they call RS Logic 5000 the software. For the HMI they use factory talk. Now they combine both together, they call Studio 5000.
Says I mean not you lah, for anyone like now let's say me familiar with Siemens already. The concept is exactly the same as to the Alan Bradley.
Yes,
right? Just the technique how to do this is
Yes,
different.
the way we want to use the software is a bit different. But mostly the software also is a example similar to the difference between iOS and Android.
Okay.
Everything is same, but the way we want to use is different. Like when you want to go back, this one don't have go back, is the button. But in Android you have a go back button. So that's the simple difference. And the I/O, the input output, mainly the addressing, they call addressing.
Okay.
For example, I just put it here. Like normally open, this is called normally open, right?
Yeah.
We open one output. In Siemens they use I0. Output is Q0. In Mitsubishi they use X for input, Y for output.
Okay.
In Omron they use 0.0 for input, 100 for output. For LMLE they don't have this address. They use name only. One tag here, one tag here. And later on this tag you need to link to the input. Manually link to the input one by one.
Okay.
That's the difference. So, but the main thing is you want to learn one PLC, you try to understand the concept of this PLC. You can do any PLC.
So most of the people still use the ladder. This is
Yes, a ladder you cannot run out from the ladder.
Okay.
Even though you can use some other formats like SCL, structured control language, statement list, okay, function block diagram, okay, all that. And latest one, new one, all they have new type cause and effect matrix. Also they have
Who use the cause and effect matrix?
Siemens.
Oh,
That's
okay.
what they have.
Okay.
But I haven't tried it.
Okay.
So, but the other program all you can use, of course, some of the company I see when I go troubleshoot. Some of the part they use other language, some of the part they use ladder. Okay. If you want to do like a process, control something on and off something, better to use ladder.
Okay.
The other language I use for like data transfer, data share with OPC or something, calculation, alarm, all that you can use the other language, which is easier to do. If you want to do a process, control something, ladder is number one.
Okay. Okay. Got it.
One is easy to do, another one is easy to troubleshoot.
Okay. So the basic must know the ladder first.
Yeah,
But you
of course.
learn all these different type, right?
Yeah, of course.
Or the SCL. Yeah.
Okay?
Okay.
Good. Okay. So this is about the software, okay?
Right.
Okay. So the PLC is combined of CPU, input and output. All this together we call it as a programmable logic controller. Okay? So the inputs we have, okay. Excuse me. Before that, your background is what?
My background is chemical. Yeah.
Oh, chemical. Okay. But you so means you want to process or that lah. this of course you know. So they have two types of inputs. One is digital, one is analog. Digital like sensors, push button, all that. Very simple. Digital means any signal that is just on and off. Okay. Analog is any signal that is a value. They have a range. We call it as an analog. Okay. So both of the inputs you connect to the CPU. I mean the PLC. You do the program. So your output will respond according to your program. So output also you have a digital as well analog. Okay. Like a digital like a lamp, contactor, relay, motors, valve, all that. Analog output is mostly the inverter.
Okay.
Why inverter? Because anything that is motorized like a pump, motor, valve, damper, all these are like a motor.
Like 4 to 20 outlet.
4 to 20 or 0 to 10.
Yeah.
So of course like just now we discussed what hardware you use, you must use the correct software.
Okay.
And the most important part is the communication. Now the latest one is okay.
When we say the word upload and download, what exactly does it mean here? Upload and download.
Transfer the program to the PLC and you back up from the PLC.
If I transfer in from my computer to the PLC, this is called upload.
Download.
Download.
Yes.
Okay. So how you say this one? I mean like how to communicate to the programmer lah. The programmer will say I'm going to download the program.
Yeah,
to
download
the PLC.
the program for the PLC.
For the PLC, and then upload is he's doing backup. I'm uploading
upload the program from the PLC.
from the PLC.
Yes. This one always people will confuse, I know. Because we used to do upload and download in the internet, right?
I don't know actually. But I thought it's always they go to the PLC, they connect an Ethernet cable, and they do the work. Yeah.
Yeah.
Okay.
So we must connect the Ethernet cable first. Then only you can. You want to upload or download is up to you. Which one you want.
Okay.
Okay, don't worry.
Okay.
5 days, then you will be familiar with the software. Okay. The main thing, number one, is that you must be familiar with the software.
Okay.
Because when you're familiar with the software and how you know the main thing here, normally I will focus on you must able to use the software. You know how to do a backup, upload, download, a simple programming, the addressing, because the addressing, because the logic is different. Logic you need to practice. I mean the programming logic, you need to practice. The main thing is you need to know how to upload, download, use the software, do the configuration, read the configuration. Okay, the I/O input output,
Yes.
the addressing,
Yes.
which input, which output, the addressing, digital, analog, everything. And also the data types, because digital they use different data type, analog they use different data types. Okay, then the communication and troubleshooting.
Okay.
This is the main thing I will focus.
Yes. Okay.
Okay. Other than that, once you know understand everything, anything additional you want to learn, anything is you can contact me, no problem. I can show you where you can learn, because the YouTube, the website, everything. There's a lot of videos, everything.
I think you exactly get the point. Actually, like all these, I have sort of quite a foundation of the control system already.
Yeah.
So all this I know roughly, but to be honest,
You never go and install.
I never hands on the thing. That's the main problem.
Yeah.
I never hands on the thing. I don't know exactly pull this cable can or not. This kind of
Yeah. I pull the cable, what happened?
Right.
The cable, what happened?
Right.
You suddenly disconnect the I/O, what happened? All this, right? On the
Yeah,
hardware
and
side.
how to configure, and people tell me, like the programmer say, oh, this one cannot work, one cannot work, whatever, bullshit, for example,
Okay.
then I can tell, what he says is correct or not, makes sense or not.
Yeah, of course. All these will be there, no problem. Okay. Then after the training, we give consultation also.
Okay.
It's a free consultation. You can contact me through WhatsApp. If you want me to come, then only we charge only. If you through phone or through WhatsApp, you face the issue, you ask me how to solve the issue. Always it's free.
Okay. Thank you.
Because why I do that? One is I make sure my participants come and learn. They are still in this field, because sometimes they come and learn, then after that they forget, they don't use because PLC, if you don't touch after these 5 days, you don't touch for 6 months
how
you
to
forget.
program.
Anything you learn lah, same. So I make sure my participant they always keep in touch. Another thing also, I also can learn.
Okay,
Because
okay.
you face an issue, okay? So myself, I never faced before maybe. So you face the issue, you tell me, okay, you take picture and send me this is the issue, okay. Then if I know, okay, I will tell you. If I don't know, okay, I go check in the hardware, manual, everything, what is the meaning of this one, everything. Okay, I will tell you, okay, this is how you need to solve everything. Once you solve already, okay, then I know, okay, next time if any company, anyone call me, then I know how to solve the issue. So I also can learn.
Okay, then don't worry. I will make sure I call you a lot.
No problem. Every week, at least one participant will message me, will ask question about the software. Sometimes they ask for the parts, where to buy the parts. They use the software, suddenly got error. Sometimes they do troubleshooting, they message me. Every week I have.
Okay, nice to hear that. Okay.
Okay, next. Okay, so this one is a computer numbering. Okay, computer numbering is like this one, like decimal, hexadecimal, binary. I think all these we learned before. Right, okay, all these we learned before, just to refresh on it. Okay, then octal. Octal, I think we never learned in our school, our university or college stuff. Okay, normally we learn decimal, hexadecimal, binary. But mostly, electrical side, electrical or mechatronics, they learn this. Because myself, I am not electrical guy. I'm a mechanical.
Okay, you're mechanical also.
Yeah, mechanical. Before
Okay.
I come here, I don't know what is PLC also.
Okay, okay.
After I come here, I then only know PLC. Because I like to use computer, that is the main thing. So when you use computer, then when I come with PLC, then the PLC can run according to your program, right? So
Right.
you will get excited.
Right.
Then only slowly start to learn. Then only now.
I definitely see a lot of multiple programming all come from mechanical also have, from chemical also have, from electrical also have.
Yeah. Because PLC you need to PLC. If you ask me PLC is like mathematics.
Like tools, everyone want to use a tool.
Yes.
Yeah.
So PLC is like a mathematics. So mathematics you cannot memorize. You must understand the concept. Once you understand the concept, if I throw at you any question, you can solve the issue. Same thing PLC.
Got it.
You understand the concept, you can do any program, any PLC you can do.
There's an analogy. It's a mathematics for engineering.
Yes. It's something like that.
Yeah.
Okay. Alright, next. Okay. So decimal, very simple. Decimal is the number we use every day. Okay. So 0 to 9, 10 to 19 means all numbers. Okay. So these are the numbers usually we see in our SCADA, in our touch panel, HMI. Right? You see some values, right? Okay, what is the time? What is the weight? The level, everything. We see some values, right? Usually they use decimal. Okay. Hexadecimal, they have 16 numbers. Mostly used in computers, computer, PLC, and digital devices. They have 0 to 9, then continue with A to F. Okay. Then after F, then only it become 10 to 19, 1A to 1F. Okay. Mostly this one where they use mostly like when we do advanced programming.
Advanced
Yes.
programming.
So basic is like basic. I put our code everything. The basic digital. When you go to advanced, advanced means you control analog, you control VFD, all that. Okay. So when you go to analog, so of course the 4 to 20 come to your PLC. But inside the PLC, when you open the value, it's not 4 to 20. They have some values, right? The value, if you want to know the value, you must open the manual, the hardware manual. Inside the manual, only they will tell you, okay, 4 to 20 means what is the value inside the PLC. Sometimes the value inside that, it will be in hexadecimal.
there, right? A lot of value is keep on, what I call it, refreshing and
Yeah,
checking, right?
yeah.
That value actually is a hexadecimal.
That value, when you refer into the manual, they will write in hexadecimal.
Okay.
So you can use that hexadecimal value, or you can change to decimal also. You can use that value.
Oh, okay.
So it means for example, okay, you get 4 to 20 million. Example 20 million you go here. So when in the software, in the program, it will show 27,000 in decimal. In hexadecimal is like 6C00.
Okay, okay.
So the 6C00 where I get from the manual. The 27,000 where I get, I convert.
Okay.
As a programmer, for me, decimal is easier to understand.
Right. You mean it's a date, but I can always change the display
Yes, of
format.
course. You
Oh,
can
okay,
change
okay,
it.
okay. But actually inside the PLC,
Is in hexadecimal.
the default is hexadecimal.
Hexadecimal. Actually, inside the PLC, you go to next, it's actually in binary.
Actually, it's binary.
Ah.
Because there's a computer language.
Because it's a computer, right?
Yeah.
101010.
Yes.
Actually, it's running in binary. But when they do manual, what they do, they will put in decimal and also hexadecimal.
Okay.
Because if they put in binary, you don't understand
Okay.
the values. Okay, they do put in these two lah. So programmers normally they will use decimal because easy to understand. Okay, because why hexadecimal? Hexadecimal, the digit, the number of digit we use, right, is very less compared to decimal. Because if you go for 60,000 in decimal, so it's 5 digits, right?
Yeah.
But in hexadecimal, it's only 4 digits only.
Okay.
If you convert lah. Okay,
Okay.
later I show you how to convert. Okay.
Okay.
And binary we know.
Yeah.
Binary, PLC of course is using binary.
Okay.
101010. Okay. Only for us only to do the programming everything we see the value in decimal and hexadecimal. Another one is the octal. The other three decimal, hexadecimal and binary. These three we use as a value. Okay, we see them as a value. Okay, but octal we don't use as a value. Octal normally they use for address. The Siemens address. They use octal because octal they have only 8 numbers.
Oh, okay. You mean the address always is an octal?
Octal. Siemens is octal.
Why?
Because
Okay.
I will tell you why later.
Okay.
Why it is octal. Okay.
So the number will be like, let's say I randomly 1.1, 1.2 until it 1.7.
Yes.
It will become 1.10, something like that.
No, not 1.10, become 2.0.
Oh, 2.0.
Yes.
Oh, okay, got it. Yeah.
Okay. So there's no number 8 and number 9.
Okay.
Okay. So octal, who use octal? Like Siemens they use octal, Mitsubishi, Kia, Delta they use octals.
Okay.
Okay. Next. Okay, so this is the difference you can see lah. Okay.
Yeah.
So in hexadecimal is 16 number, right? So 0 to 9, then we have total 16 numbers. Octal is 8 numbers only. 8,
Okay.
then 8.
Okay.
Okay. Then this is in binary lah. Okay.
Okay.
This is normal decimal numbers. Okay. Actually, you can use your computer calculator to convert these numbers.
Or the calculator function has a.
Yeah. You press escape.
That's just this one.
Yeah.
Oh, I have changed the calculator format.
Yeah. Because normally it's in standard, right?
Programmer.
Change to programmer. Then from any value to any value you can convert.
Yeah. Okay. Got it.
Another thing, because this one I tell especially for you, because you are not going to do like programming. It's already program is already done.
Right.
So
Right. Actually,
mostly,
that's true.
mainly you do like troubleshooting, okay, like you want to take data, right? It's already done, but you want to take the data, send to your cloud system, okay, all that, okay. So when you want to do that, you must able to, you must be, clever in reading the what manuals.
Reading the manual.
Yes.
When you always say manual, what is manual means here?
Manual means that because this, okay, let's say you have a hardware. For this hardware, like a user manual.
Okay.
So this hardware they have a user manual. So in the user manual they will tell about the hardware. Okay, this hardware, okay, what is the memory, how many I/O you can use.
You mean the real PDF manual?
Yeah, PDF manual.
Okay.
So inside that, okay, they will tell about hardware number one.
Okay.
And number two, they will talk about. I tell about what the contents. Okay. So first the hardware. Second one is the memory, the capacity lah. How big the program can be. What's the memory value. Then the third one is what software is using. Everything like they will tell you. Then how to upload, download. Sometimes in the manual you can see that. Okay. The configuration and also okay. Then later on, fault. If fault, okay, what is the meaning of fault?
Yeah.
If the LED is blinking, what is the meaning? If LED is stay ready, what is the meaning?
I think that is the part I
Yes.
really want to know.
Okay, good. So all that data, right? Everything in the user manual, not only for PLC, the VFD, everything. So whenever I go to company, they request, they tell me, okay, this is the error, right? So normally the VFD, they will have error code.
Okay.
Come with the code. What is the error? Sometimes communication problem, want to overload everything. Okay. When you refer to the manual, they will tell you what is the problem. Okay. The fault is what is the meaning, and also what is the remedy to. So they will tell okay, communication problem. Then they will tell you what to do. Check the cable, check the PLC, all that. So
Okay.
the manual, if to go through the manual to understand, searching the information in the manual is very very important. If you do troubleshooting,
Got it.
that's the main thing I do normally.
Always ready the manual first.
Yes.
Okay.
If you okay, let's say that if you know how to solve, then okay. If you have not don't know what is the issue, why suddenly behave like this, you don't have an idea, then straight away go to the manual. Just download the manual, then see in the manual.
Okay. Got
Okay,
it.
later I will show you all this how to use that all that.
Okay. Okay. Alright.
Because the last day you will be using this drive to connect with your PLC to run.
That is a BFT, right?
Yes, there is a Siemens BFD.
Okay.
Siemens BFD with the motor, then we have a HMI.
Okay.
So on the last day we will connect all these three and do some simple programming. So that time I will show you how to read these manuals, everything. How to take data from this manual. Same thing, because if you want to connect a device, let's say this load cell for example. Okay, you have a load cell, you have a PLC. Let's say the load cell, they have Ethernet port. Okay, now you want to know how to program the load cell. You don't need to worry. Every details in the open the manual, go to the communication part. They will tell you okay what communication can use, how to do the communication, what are the data you need if you do communication with PLC. Everything is there.
Okay.
Just need to know how to use that.
Yeah.
I need to study a bit on that.
I think that is the information. Yeah. I want to learn from you on this one.
Okay,
Yeah.
okay, no problem.
Okay.
Next. Yeah, this is how to use the calculator. Okay, next. Okay, this is the addressing. Okay, the addressing. The PLC input, output, everything. Okay, okay. They use octal method. Okay, just now you see right, octal. Okay, so Siemens, all the model are. That's the one thing. One good thing about Siemens is all the models same thing. Like Omron, Mitsubishi, I know. Like smaller models, different way. The bigger model is a different way. All that. Okay.
Says. I assume this is like for one PLC lah. One PLC you can have from 0.0
Okay.
up to 7.7.
3.7. No. Can go bigger.
Can go bigger.
Can go bigger.
After 7.7 become what?
Yes. 3.7, then 4.0 to 4.7.
I mean after 7.7, let's say.
No, 8.7. Because the second number Only from 0 to 7. The front number can go.
Oh, the front number is not the octal.
Yes, it's just.
Also, it's a combination decimal and octal.
Yes.
Why? Okay, I don't know.
Okay, why? Okay, here I will tell you why. Because Siemens they use byte.
Okay.
Byte, inside one byte you have 8 bits. Okay, 8 bit. Can I erase this?
Oh, sure.
And
Okay,
what
okay,
pictures
okay.
on can take picture also.
Yeah.
Okay. Okay. So one bit or they call Boolean bits is like on or off. Like digital lah. On off. Okay. So they have a Boolean bits, one bit lah. Okay. Then they have byte. Byte is 8 bit. So that's why they're using octal. So one byte. Okay, so in B0, this one means the byte, right? So inside one byte, I have what? I have 0.0 until I0.7. I have 8 bit. Okay.
Yeah.
So always the octal number is this number because this is the bit number. The front number is actually the byte number. So if you see like this is the byte, this is the bit number.
Okay.
Okay. So the PLC normally it will show the byte number, means how many bytes I can use. So this PLC, the input can go up to 1000 bytes. 1000 bytes means 1 byte I have in bit. So means 8,000 bits I can use. Inputs only. Means I can use 8,000 digital inputs. But it cannot go up to that lah. Only they already restricted up to 1000. Okay, because it's a combination of digital and also analog as well.
Got it.
So once I finish this, then one byte finish already, right? I go to the second byte. Inside here is 1.0 until 1.7. Okay. I go to the second byte. Like this, right? Okay. If these two bytes together, it means it's a word. Word means it's a 2 byte or 16 bit. So this one will be input word 0. 0 is the first byte number. Okay.
The I.
Okay. So IW. W means word. IB is bit. Just I only. IB is a byte lah. This I only is a bit.
Okay.
Now, when they use word, when they use bit, okay, because they not when we normally won't use byte much. Because why they use byte? Because Siemens they start with 8 bits. Some PLC start with 16 bit. So some PLC don't have byte. Straight away bit, 16 bit only. So your digital inputs, right, like push button, sensor, all that you will connect here. 1.0, 1.7, all that. If analog means you must have a value, you will use this.
Okay.
Why? Because inside here I got how many bit? 16 bit. If all the 16 bit 1, 1, 1, 1, 1, 1, what do you get? You will get some value, right? So analog means it's a value.
Okay.
So that's why for analog I need IW to store the value. Okay. At the same time, the same IW. So once IW0 finish, the next one is IW2. Why? Because inside this 0 I have 2 bytes, right? 0 and 1. Next one is the 2 and 3. Okay. Inside here is 2.0 until 2.7. Here is 3.0 until 3.7. Right? And these two words together it become a double word. Okay? So double word means 4 byte, right? 32 bit. Because if you want a bigger value some more, 32 bit. Because the 16 bit can store value up to 65,000. It can keep the value. If more than that, I must use 32 bit. Okay? But for now, we only focus on this first.
Okay.
Second day, third day, or then only we focus on word and double.
Okay.
Okay, then it will be easier. So here I just want to tell you the same I can use as a bit, can use as a byte, can use as a word, and also can use as a double word.
Okay, sir. Just double check the name and see.
Here?
Yeah.
Okay. Alright, thank you.
Okay,
Okay.
good.
Yeah.
Any question?
No.
Okay, right. Go to next. So the same things for Q. So I is for input, Q is for.
Okay.
Okay, next. Memory. Okay. I is a physical input. Means you must connect wires lah. Q is the physical output. Means must connect wires. M is what? M is a memory. Means that is inside the PLC only. Normally what they call as a internal relay.
Internal relay.
Yes.
Okay.
Because you need to understand PLC is like it's developed from what?
Hardware.
Hardware, relay system. Before PLC they was using relays, timer, all that. So when they convert into a programmable unit, okay, so they already replaced all the relays, no need relays. But inside the program they need something to hold, right? They use memory.
Okay. Got it.
So some PLC they call latching memory, sometimes they call auxiliary memory, auxiliary relay.
Is this all this IOM is something very similar concept to like programming variable in the programming?
Yes, this is all variables.
All variables.
Yes, all the variables.
Okay.
Okay. What they do, because in computer programming, right, they don't have like input outputs. So what they call as a variables.
Right.
Input variable, output variable, internal variable, constant variables.
Right.
Even if you go for like OPC, all that, they're still using the name variables. But in PLC they call addressing.
They call
both the same
actually
thing.
it means variable.
Yes,
here.
it's both the same thing.
Okay.
So because that one they call variables, but here they call like address or tagging.
Okay. Got it. Yeah.
All same meaning but different terms they use.
Okay. Got it.
Okay.
So when we say, I just ask one more. When we say we do mapping,
Yes.
mapping is converting your external signal
Yes.
address to this
Yes.
in IO.
Yes,
and
I/O.
Okay.
The inputs input outputs.
Okay, there's an activity called mapping. Map is
Mapping.
Okay, got it.
They call I/O mapping, right?
Yes.
Because you need to know, okay, I0.0 is what input, 0.1 is what input. So you need to do the mapping. So mapping, or we call tagging.
And in the program, because let's say I assume
Can
my input is TT101 temperature 4 to 26. Okay. So this TT101 it goes to map to I0.1.
No, cannot.
Cannot.
Must go to IW because it's a temperature.
Oh.
Value.
So how you should map? I mean, what is the expected variable here?
Yeah. So IW 0 depend on which number is available, but must use IW.
So you think it will be named like IW0.1 or
No, just put IW0 or IW2, 4, 10, 20.
Or there will be no bit anymore.
No bit, because it's a word already, right?
Or let's say it's a TT inlet mapping. If you go to IW0, IW1, IW2.
Yes.
Oh, that's a meaning.
Because why? Because you are talking about temperature. It's a value.
Okay.
Let's say you talk about a sensor, just a on and off sensor. That one will go to the bit.
Like the push button.
Push buttons, sanitary switch, proximity sensors. That one will go to the bits.
Oh.
Anything value go to the word.
Okay.
Because why? Very simple concept, simple logic. Bit means one bit, right? It can store what value? It can store either 0 or 1 only. Okay. The word means can store 16 bits. 16 bit means it's a value 0 to 65,000. So your temperature value 4 to 20. So inside the PLC it becomes 27,000.
So you say this how you say this 1, 2, 3, 4.
Yeah.
There are four different
Data
type.
Yes.
It's just like a programming. You have a data. Your variable type is integer or string.
Yes. This one actually word called integer.
Okay. Okay.
Okay.
Got it. So that's the concept here.
Yes.
Okay.
All this will be very good for me to explain to you easier.
Yeah.
Because in PLC, one of the most initially difficult part is the data types.
People understand what is the use for this different
Yes.
type of data type.
So sometimes what I do, like because you are familiar with integers, string, all that, so you can take this. Normally the first day I don't teach this all. I just focus on this only. That's why just now also I tell you I just focus on this, because if I teach this one, they will very confused. Because they never used before, never seen before. So luckily you are familiar with the integers, values, everything. Integer means what? 16 bit word.
Okay.
What also 16 bit?
Okay.
So if you want to store a value, if you want to store the temperature value, you need a 16 bit of data.
Okay.
So where I can get the 16 bit of data? IW0.
Okay. So I have to define it to map it to a
IW.
Yeah.
Yes, correct.
Okay. If I map it to the bit type, then it will not work.
Yes, correct.
Got it. Yeah.
Got it?
Okay.
So just now M is memory, yeah?
Okay.
We go to next. Okay, data block. Okay, data block also is similar to a memory also. Okay, but the difference is that it's a block type.
Okay.
So they have this is the block DB1, the main one. This one is similar to your memory also. So B by word W. Okay. The front part is the blocks, means I can create multiple blocks. Okay, DB1 is different, DB2 is different. So each block I will define as a different taggings. Okay, but memory is they already give you like one range from this M to this M. You only can use this range. Okay, so that one is what model 1214, right?
This is 1214C.
So 1214, I think the memory can go up to 8,000 bytes. Okay, if 1211, 1212, it go to 4,000 bytes. The memory, okay. But the DB, inside 1 DB, I can go up to 32 bytes. Okay, 1 DB, I can go 32 bytes. The DB itself, I can go up to I think 4,000 DBs. So consider memory and data block is the same thing. It's like an internal only, not in additional wiring and everything. Only thing is memory have less memories, data block have more.
Oh, the characteristics is the same. One is one less, one is more.
One is more. Another one, okay, another difference is data block can keep the values, can retain the value.
Retain.
Yes, can keep the value. Whereas memory, if I do memory reset, the value will go.
So one is like a RAM, one is like a
Yes.
Okay, got it.
Okay,
Yeah.
got it? Okay, but this one, I think DB we will learn in day 4 or day 5 only. So the first 3 days we only focus on input, out, I, Q and M.
Okay.
Siemens very simple, only these 4 letters only. But the same 4 letters you can use as a bit, byte, word or integers, double integers, floating point, right? Floating point, real, right? All that.
Got it. Yeah.
Because some PLC, bit they use different.
Okay.
The word they use different alphabets lah. So it will be confusing. And Siemens very simple. This 4 just focus on this 4. Additionally, they have another one called P pointer.
Okay.
And in special case, we use pointer.
Siemens. Okay.
They have an additional one. They sometimes you see because most of the time you see all these numbers. Sometimes when you see P pointer, pointer means like you point how many byte you want to use because maximum here 4 byte, right? Actually, you want to use 8 bytes now. Alright, so you must use pointer. Pointer 8 bytes, something like that.
Okay.
But that one later.
Advanced.
That one is advanced.
Okay. Got it.
That one also very rare I use. Only some of the function only they use.
Okay.
Not all the function they use. Okay.
Okay.
Alright. Next. Okay. So okay, never mind. We go for a break. Okay?
Go for.
Break.
Oh, okay.
After
Sure.
break, we go for a break. After the break, we come and continue this one.
Yeah. Sure.
Okay. So want a coffee or tea? You can have a back and grab a coffee or tea.
Can do.
Yeah.
I can just touch around the hardware here, right?
Yeah, yeah.
Okay. Thank you. Wow, this one worth to take a picture. I've never seen so many PLC at the same place.
Actually, PLC got so many models. So many. Like I can tell you, even I myself, I know 20 brands.
20?
Brands, yeah.
Oh,
I can
so
tell you
many.
20 brands. So many. Siemens, Omron, WinCC. Even Japanese itself, they have so many models. Japanese, they have Omron, WinCC, Siemens, Delta, Omron, WinCC, Siemens, Delta, Panasonic.
Panasonic as well. But in Malaysia, not very. I don't know. Never seen any. Got Oh.
Then what else? Fuji, Hitachi.
Cheaper. Cheaper, really. Siemens is the most expensive lah.
No, Allen Bradley is most expensive.
Allen Bradley is the most
Yes.
expensive.
Allen Bradley expensive.
Got it.
instead you want to go makan, that area got some Chinese shop lah. Chinese shop. That one you stay right?
Yeah, I just now when I come, I eat over there.
Oh, okay.
Okay.
And then here also mama shop. Okay, go back. Okay. So this one regarding the hardware lah. Okay. So here's the power input. This board lah. Can you see So this one is you need to use 24 DC. Okay. Because this one is a 1214 DC, right? Okay. So 1214 DC. So the first one, there is the power in. They have DC and also AC.
So they are PLC using AC in.
Yeah, I mean you just power up
Okay.
to power up the module lah. Okay. So they have DC and also AC model.
Okay.
Okay. But for 1005, always is a DC.
Okay.
You see here. Later I power up. This is the DC.
Okay.
Okay. But they don't put here. Can you see? They just put CPU 1511C 1PN.
Okay.
Okay. So later we'll explain what is this and thing.
Okay.
Because from the part number itself, we can get so many data.
Okay.
Okay. For this model, for 1002, the second one is the input type. So always is a DC.
Okay.
Okay. So it's a 24 VDC, okay, DC voltage. Okay, the last one is the output type. So they have a DC and also relay model. DC is a 24 VDC. Relay means, okay, you know relay?
I don't know.
Yeah,
My
it's like a
understanding
switch.
relay is about switch.
Yeah, it's like a switch. Okay.
Yeah.
The thing is, relay will have two things. One is coil, one is contact. So you energize the coil, the contact will open or close. That's all. So normally, why they use relay is, let's say my instrument is is an AC. Okay. My PLC, let's say, is a DC output. Okay. So my PLC directly cannot power on the instrument. So what happened? The PLC will power on the relay. So relay will have a contact and coil. So
you are saying like in terms of, let's say you three-phase motor lah. There's a contactor inside.
contactor and relay are same thing.
Right.
The difference is contactor will have 3 contacts.
Okay.
Relay will have one contact also, or 2 contacts.
There's a
four
definition
contacts.
different.
Yes.
One phase is called relay. 3 phase together is called a contactor.
Contactor can also. But there's a difference. But both the function are both same. Okay. I'll tell you how. So let's say this is PLC outline. Okay. We go to a relay coil. Okay. So this is 24. This is we connect to the 0 volt from the power supply. So from the PLC is 24 is given here like a lamp are positive negative. Then I connect 0 volt. This one will activate. Okay. So the same relay will have a contact.
Yes.
Normally open, normally close contact. Okay. Let's say this is your instrument. Okay. The instrument needed 230. For example, this one I connect to a neutral. Okay. So instrument need 230 AC to power up this. Okay. So my PLC directly cannot connect here because why? It's a
High power.
live
Live. Okay.
230. So what happen is we connect a relay here. So the relay coil will be connected to PLC output. Then this one you connect 230 AC. So once the coil is energized, this contact will go here. Then can energize this. Same thing with the contactor. Okay, contactor also same thing. Contactor also, it's a similar thing. I just take one output from here. Okay. Contactor also will have a coil. Okay, and we'll have 3 contacts. But the difference between contact and relay. Relay will have normally closed and normally open contact. Can use this also can, this also can. But contactor will have only normally open contact. So this one can be 0 volt, and this one can come from the output circuit.
Why we have to specifically like differentiate DC and RLY here? I mean,
Ah,
it sounds
which one?
like they are
Yes.
also DC, right?
DC. So relay means it's like a building relay inside here.
Built in.
Yes, like a building relay inside here. So this relay can support 230 AC and also 24 DC.
Also, you mean the AC can go inside the PLC?
Yes,
and come
inside
out?
the PLC can come up directly to the instrument also can.
Okay. So if you only DC, you cannot do this.
Can do this. So you need the additional external relay
Oh.
to power
Okay.
your instrument. If I say your instrument 230,
When you say instrument, what kind of instrument it is called?
instrument is like example, like contactor, relays, all that.
So it's functioning as a relay
Yes, as a
to power up
relay. Power up your what?
high power thing
Yeah, high power thing like example lamp, valve. Because sometimes valve is 24, but it's an AC valve, not a DC valve.
Oh.
So I need to use a relay. Or I can use the PLC with
Very
built-in
common
relay.
this relay built in.
Yeah, relay common.
Oh, okay. Got it. Okay.
Okay.
Yeah.
Okay. Then so that's why. So the power input is 24 DC. Then there's a power out. Okay, because the same thing lah. Whatever connection that will be the outlet. Okay, it's like internally looped. Okay, so this one you can connect. Use this to looping here, all that can use lah.
Right.
Then can you see inputs, right? Actually, this one is the same model you have. Okay, so can you see DIA? Right on top, DIA, small one. Okay, here. Oh, this one. Yeah, you can take out.
Okay.
You can take out. Yes.
Okay.
So you can see the power in, power out, the DIA, right?
EIA. Yeah.
Okay. So DIA means you know what is the meaning of A, and the next one is a B, right? You know the A is actually the byte number.
Okay.
So just now we see for one I, right? 0.0, right? This is the byte, this is the bit, right? Okay. So the byte number is the A. The first one is A, second one is B. This one all, can you see 0, 1, 2, 3 until 7, right? Can you see there's a dot in front of the numbers?
Yes.
Dot 1, dot 2. Okay, why? Because this is a big number. Okay. But why they didn't put 0? Why they put A? Right. Because inside the software, the front number, the byte number, right, you can change to any number. That's why they didn't specify the number. Okay?
Okay.
I will show you. Like this one is a Mitsubishi,
So for this one, only have 7 plus, 8 plus 6, 16
Yeah.
in 16
14.
inside, 14.
Yeah, 8 plus 6.
Okay, 14. Okay.
You see this one, these inputs, right? They already specify here X, right? X01. So it's already specified the number that you can't change the number.
Oh.
But here they put A. Why? Because in the software you can change to any number.
I have a question.
Yes.
Say, for instance, go back to we do a program now,
Okay.
and then we have a PI. Let's say it's come from a limit switch.
Okay.
The limit switch. Then my limit switch have 2 wire, right?
Yes.
They come to here. I say I connect to I don't know what is the pattern number, but how come the DIA here only have one N point 0? Oh, okay, here until here. I connect to a 0.7
Okay.
PIA 0.7.
Yeah, okay.
So inside my program when I do mapping,
Yes.
it is fixed already. It must be 0.7 already.
0.7, yes. Some number 0.7.
Some number 0.7.
That number, here they didn't specify the
Okay,
number.
they didn't specify.
In the program, I can specify the number, what number I want to use. If I specify 0, then it become I0.7.
Okay.
If let's say the byte number is specified 10, then it's I10.7.
Oh, why they want to? I mean, why they should not just fix
Okay,
it?
why? Why? Good question. All your question is good. No problem. Okay. Why? Because initially, okay, I come to here. Like here, I have all this. Okay, like this, can you see they already put I0, they didn't put A.
Yes.
Because this model is already fixed. So you cannot change the number 0. It's already, first one is 0, second one is there. Because this is a 200. Okay. That one is, I tell you, this one is the successor of this. Okay, for these models, can you see? This is the CPU. This is the CPU. Right? This is the CPU, this is the input card. So after the CPU, only you connect the input cards, IO cards. You can connect, first is the output card also okay. Input also can. Right? So if you can connect any cards here.
Oh,
So
you can rename the number
yes,
whatever
so
you need.
the number later in the software you can decide what number you want to use.
So there's a meaning of mapping here because if you connect to a lot of I/O card, then you have to decide yourself.
Decide
how you name
yourself
it.
what number you want to use.
Okay, got your point already. Okay.
Then later
But let's say if I assume not to say it's the 200
yeah,
let's say it's 1,500
yeah, 2005.
1,005. Then I have, let's say I add 4 I/O card behind.
Yes.
So you see this is the 1,005. Okay, sorry, this is
1005, yes,
this is 1,005.
yeah, that's 1005.
Okay, I mean so the 1,005 itself has no I/O at all.
No, yes, you have
It has to-
this one building.
This one built in where is okay. The numbering is not shown here. The numbering is
No, it don't show here.
oh yes.
Okay, can get it back. Here. Which number?
Let's say this
you
is
want?
AI. This is AI.
Yeah, yes. First one is the AI AO. Second one is because AI how many AI? 0, 1, 2, 3, 4, 5 input, 2 output. Then the digital input output is here.
Oh, I mean like all this how do I call this port?
The terminals.
The terminals. All
Yes.
this is a fixed number already. This is a okay. There's no this is a DI. Oh, okay.
You can see the number here.
Yes.
0, 1. Here also they put A. Can you see?
Yeah.
This
Say I terminate one
Mm.
the wiring number I go to A7.
Yes.
Even though here it only say A, didn't say anything, but inside the program,
Mm.
it must be, no matter what number, has to be 0.7.
Yes, 0.7 is there.
Oh,
But
it
you
cannot
don't know
be,
what number.
it cannot be a wire here is 7.
Mm.
Then in the program, I address it to 0.6.
Cannot.
Cannot.
Because it's different input already. It's not your limit switch.
I can rename, this is from configured, this is from this IO card, then it's 1.7.
Yes.
If from another IO card, it's 2.7.
Yes, correct.
Got it, okay.
So this is I have for that additional IO. This is the input output also. Sorry, this is the input card. Purely input. This can you see? DI16. Very small. Very small.
Okay, the 16x 24 VDC.
Yes.
Oh,
Okay, it's an input card. So this input card, so you see here,
okay.
they didn't mention, but they just put A only.
Okay.
So later on you add. So you in the configuration you need to design the numbers, what number you want to use.
Oh, now it's super clear.
Okay. Later in the program you do that, then you'll understand better.
Okay, okay.
Okay. Then that PLC come with that analog input also. So the 1M right here, correct? There's a 1M there.
Yes.
Later I will tell you what is that. Later when we do wiring, so we'll have better to understand. Okay. Then you have a memory card. Okay. So this PLC already have a memory inside. It's like 100 KB or 150 KB. A small memory, just nice for programming. Okay, but if you want to do like bigger programs, if you want to do data logging, all that, then only I need memory card.
Okay.
But for 1500, can you see that's a memory card you can put anywhere?
Yeah.
But for 1500, the memory card must connect.
Must connect.
Must connect, then only can put.
Okay.
This one.
Always use the SD card.
Yeah, Siemens one.
Or Siemens one.
Must use Siemens one, yes.
Can I use other?
Cannot use others. But for this model, they release a new version now in
Okay.
December 2024. They call 1002 Gen 2. It's a
Okay.
newer model. That model you can use any memory card.
Okay.
If you're still using this model, the old model, must use this. The newer model got two new features. One is you can use any memory card, but and they compact a bit really. Then another thing is if your phone have an NFC, I think you must download their Siemens app lah. Download. If your phone have NFC, now got error, right? Now for this one, if you got error, you can see from the screen. This one you can see, right? What you do, you need to go to the software and see what is the error.
Oh.
But the newer model, if you have your phone have an NFC, just bring here, it will show what is the problem.
Wow, so advanced.
New one. We haven't buy one. Maybe in future lah, maybe in next year buy. Because need to buy one. Because I always buy Siemens parts from one supplier lah. Every time I buy one part, he will send me the catalog. He say, you buy this one, you buy test this one, you buy test this one. I say, I'm not using. Later in the future, I buy that one.
Yeah.
It's a new one.
Very advanced.
Yeah, very advanced one.
Yeah.
Okay. Then here we can see the CPU model lah. Then down here we can see the part number. Below, you can take out the tower also.
Okay.
You can see the part number there.
Yes.
214. At the side also you can see the part number.
This one.
6ES7. And it's always start with 6ES7.
Oh, 6ES7.
Yes.
Is the part number.
Siemens PLC always start with 6ES7.
Okay.
PLC. Touch panel, if not mistaken, 6AV. Yeah, 6AV.
Okay.
For Siemens, if you ask any models, yeah, we have. Because I do a lot of Siemens, so I buy Siemens products a lot. Other products, mainly I have PLCs. HMI, depend lah. Some model have, some model don't have. VFD also same. Not all the model I have the similar brands. Only for Siemens I have complete. Actually, here
Siemens has a lot of
drives.
VFD, right?
Yes, different drives.
Yeah.
Some for the bigger system, some for just a smaller control, some just on and off also have simple one, starter, right?
Right.
Some to control. This one all can control PID,
Oh,
can
okay.
control PID, but now right now cannot control because why? I need to install an encoder.
A program from inside the PID.
Yeah,
So you give a analog signal go inside.
Analog signal can do PID system here, but for that I need a encoder. Need to install an encoder here.
The speed feedback.
Yes. But here itself can get the feedback. But if I want to do simple programming, just on and off, control the speed, everything, can do without the encoder.
But normal 3-phase motor always have an encoder?
No.
No, right? Yeah.
No, normal 3-phase don't have. You must buy one with the encoder at the back attached, or in the front you attach an encoder.
Oh,
Mm.
okay. Can you tell from outside? Let's say you see a motor.
This one normal mode.
I mean, you see I'm not saying this small motor lah. Say probably a bigger motor lah.
Yeah.
And then you just look at outside. Then you can see that this motor has a built-in encoder.
Yeah, you can see.
Always normally.
Always at the okay. You will have additional cable.
Let's say it's normal.
Normally we have
three
three cable.
Yes, 3-phase cable.
3-phase cable.
And then
Then if you have an
always-
encoder, then you have additional cables.
always from the end.
At the back, different. The motor design also different, a bit different.
Or everything different. But definitely not from the
Yeah, not
junction box here.
No, not junction box here.
Always come from somewhere.
At the
just
back,
small wire.
normally encoder they will add at the back is like a building lah. Or in front you will add an additional encoder.
Okay. Then it sends a speed
speed
feedback.
feedback to the drive, that can do some advanced programming. This one can do, but it's normal programming.
But to be honest lah, even you don't have a speed feedback,
Still, this one can get the feedback.
you can just still use your
Use the same value to get the feedback.
right, use your the command signal lah,
Yeah,
use the
yeah.
command signal still
Yes.
can do, right?
Yes, can do.
Oh, okay.
Can do. Normally, why they do? Okay, some system why they do speed feedback. Normally, what they do? This one they don't control using analog or Ethernet. Okay, they just on and off this one. The speed is just set here. What happened to get the feedback? They connect here, the encoder, additional encoder. Why? Because if I'm using a communication, right? If I'm using a communication, this one can send the data to here. If the motor not running right, this one become fault. Correct?
Yes, correct.
Overload
That's
something. Yeah, because it won't get a value, so it will give a fault. When this one give a fault, I can get data here.
I mean, in terms of practically lah, in the industrial practice
Yes.
people use advanced VFD like this already.
Yeah.
Like say Siemens and advanced already.
Yeah, Siemens and Watson. Any VFD like that, what also send.
Yeah,
Same thing.
and then they always will configure it with a motor that has a speed feedback.
Yeah.
Always.
Yeah, always.
Or they will not say I buy a very expensive VFD, but I buy a motor without the encoder.
Can also lah, but this one not expensive. It's not expensive. This one has around
How much?
how much? This one I know because 700 or 900. Yeah, 1,600. Yeah, this one dynamic because this one is just a maximum 0.55 kilowatt only.
Oh, okay,
Not
okay.
very big motor.
But normally VFD is more expensive than the motor itself.
Yeah, of course.
Says so, but I mean, if people invest in buying a VFD already, definitely they buy a motor with a
No,
encoder.
not necessary.
Not necessary.
Because I go troubleshoot. Sometimes I don't. Yeah, they just want the motor. Why? Why they use encoder? Very simple question. Why they can use direct online one. DOL, right? Okay, why? Because they want to control the speed.
Just want the speed control. They don't want the PID.
Not PID. If they want to do PID, by special programming, some advanced motor control. Because this one is just to control, okay, high speed, low speed, everything. Your PLC will send the data here, so you can. This one can process.
Probably
Can
people
control.
invest in is or how they design it. If they want to have a more accurate
Yes.
PID control,
Yes.
then they have.
Yes, accuracy. If you need accuracy, then you use encoder.
Okay.
Because normally why? Encoder why they use? Because they want accurate, not only speed. Normally encoder because okay questions. You asking me good questions. Okay. Why they use encoder? Actually, encoder can measure two things. One is the pulse. Okay. Another one is the RPM, rotation. Okay. Why they use pulse? Because they want the accurate rotation. Let's say the motor need to rotate from here to here only.
The servo motor lah.
Yes, servo motor normally come with the
A servo
encoder.
motor don't use a VFD, right? Or
No, they use a servo driver.
servo driver.
Yeah, that's
Servo driver.
This
Okay.
servo driver. So it's already. So if I want an accurate position, I want to be. But the servo motor cannot use for bigger loads.
Okay.
Correct.
Yeah.
It's a smaller load can. But if I want a rotation, but it's a bigger load, what I do? I use this induction motor with the encoder.
Oh, got people use this
Yeah, of course. Because
I use notice a normal motor.
Mm.
This how you say it's a big top lah.
Yeah, big top.
But they use it for the purpose of a servo motor
Yes.
for positioning.
Yeah, positioning. So that's why they use the encoder. So they will check. Okay.
But
So
this kind of motor very bad in positioning.
yeah, of course.
So
That's the reason they use encoder. So what happened? So they know okay how many pulse to rotate to here. So they will always calculate the pulse. So in the program they will tell what is it? Okay, the PLC when send the signal to the motor. Okay, motor run. Then once I reach this particular position, so I get a pulse. The pulse get feedback to the PLC or to the drive to stop.
okay.
Okay. Yeah.
Got your point. Yeah. Okay. Let's.
So that is the reason they use encoders. That's why I say not necessarily I must use encoder. Depend on the application of the motor, how you want to use the motor. Because last time I will do one project. You know, just now I tell you the project I do one time. Mitsubishi convert to Siemens. That one got 4 motors. Yeah, 4 motors. All the motor, the positioning is not that important, but the speed is very accurate. So that is why they use inverter, the VFD lah. Okay. So for motor, all the motor I use 4 to 20 to control. I didn't use communication.
Okay.
I use analog.
only.
Analog, just wire only, hard wire to control. So how it works is, when you set the value in the PLC, in the HMI, you set the value lah, how much, what is the length, everything. We go to the first motor. So first, I'll do some calculation. First motor run. When the first motor run, I get a feedback, right? I use that feedback, do some calculation, send to the second motor. So first motor speed and second motor speed is not same, but second motor is depend on the speed feedback from the first motor. So it's not the position feedback, the speed feedback, right? So for the speed feedback, I don't need encoder, because the inverter itself can give you a speed feedback when the motor running. So I can use that. If let's say they use, but it's a bigger motor, but let's say they want the position is very important, then they use encoder.
Built inside.
Yeah, inside or additional, or sometimes what they do, let's say there's a DOL, direct moment motor, okay? But you want to know the feedback of the speed, so you connect encoder, the encoder direct to the PLC.
Call it.
Because PLC can read encoder also, right?
Yes.
They call high speed counter.
Okay.
Good.
Yeah. Over.
Okay. Then we have output here. Same output, also same thing. DQA and DQB.
Right.
Okay.
Got it.
Okay, so this is a DC output, that's why they put 24 with DC output. Then you have a LAN cable, right? So Siemens LAN cable or Ethernet they call Profinet.
Okay.
This now you see. Then so Siemens Profinet usually they use the green color Ethernet cable. The connector look big, but it's still for what? The 485.
Yeah.
But it's still big lah.
This is called the RJ45, right?
Yeah.
Okay.
Okay. Then here's the LEDs. Okay, run, stop, error, LED, everything. Then this is the option board. Option board is okay. Can take out the power. Okay. So now, let's say this one got some input output, right? How many inputs? This one is 14 input, 10 outputs. Okay. You need additional inputs. Okay, you can connect this at the side here. Okay. You take out this cover. Must use the S7. Okay. So can use this. Then can connect this. This connector. Okay, or here also can add some I/O. Here, that I/O.
So this is what you call this?
Option board.
Option board.
This one called expansion module.
Okay.
So this one is a board lah. This some board.
Only available in this.
For this one, this one is already fixed like this. So let's say I want this one called analog input only. So you don't have analog output, right? Really, you don't have. So you can buy one of these analog. Or analog output additional modules also can.
Okay. So this also one option to expand.
Yeah, expand the modules. It's normally available on smaller modules like this lah. Mitsubishi smaller modules. You want to add something, you can add here.
Okay. Very RP and then all your cable from top.
No. Only water only.
Only water.
That's why they give a space, everything, nice space.
Okay.
So on top you have only bottom. This one maximum output only one output and analog lah. Analog input only one analog input. If a digital only 4 input or 4 outputs only.
Okay.
Later in the software we can see all this. Okay, but now cannot connect. If you want to connect this one, you need to power off, then only can connect. Can you see? Yes, this sensitive, right? So electrostatic sensitive, so can damage the PLC.
So that is how to work. Anything you want to add expansion, whatever, you off everything. Off
Yes,
the power.
better to off.
Okay.
Expansion is still okay, but better to off.
Better to off. Okay.
For this one, for this module, how to add? Don't have anything, right? Okay. Can you see that you connected here?
Oh.
Okay. No, not like that. For this one, but I don't have that. Something like this, but for this I don't have.
So it's still hooked up to the
No.
main rail.
No, they drill like this.
Oh.
This drill.
Okay.
That one is a rack.
Oh, there's a rack.
Rack.
Okay.
Because the rack system. This one is a rail system. Just buy one rail. Then this is the connector. In between this, but this is not for this lah. For that. For this one similar to this, but a bit bigger.
Okay.
A bit slim and a bit long.
Also, that is how to connect.
So you connect here, then another one can connect here.
Got it.
This one recently only I bought. I think two or 3 weeks back I bought this one.
2 or 3 weeks back.
Yeah.
Oh, very
Because
new.
very new. Because normally I don't. Because I use this for training. So very less people ask for this.
Okay.
So that day one guy asked for this because he want to do advanced programming, learn advanced on this lah.
Oh.
But I tell him I can use the same program here, but okay then we also planning to invest one by because this one is around 6 to 7,000.
6 to 7,000.
This one is 1,500, 1,600 can get one.
Okay.
So then I tell my boss now when we buy one lah.
Very professional.
Yeah, so one by one if someone requests for advanced programming, very advanced programming, can use this.
Got it. Okay.
But still need to buy some, one module, then some communication modules for that. Because for this I already have everything. For this only.
Okay, got it.
Okay.
Yeah.
So that's about the hardware. For this one I can tell you a bit. So this is here is the power. The power up. Okay. Then here you can run and stop, on and off. For this don't have, you must use the software to run and stop. For the older models you have a small switch to run and stop here.
So all the PLC to start the PLC after I on my power
On.
supply is switched on already. And here it will not run by itself. I have
No.
to manually
No.
run it.
No.
Not it.
Always go to run.
It's always
Stay with run.
always
If
stay with
something
run.
happen, communication problem, power trip or something, then suddenly go to stop mode. Then only I need to settle all the error. Then I run it.
Oh,
But for this, if like this, but still no, but just error still running right, still okay. If error already go stop mode, you clear the error, then the stop I need to use the software to run back.
okay.
For this no need, for this just
Normally power supply on,
automatically go to run mode.
automatically
Yes,
run on.
run mode.
Okay.
Then here you can do the settings, the IP address, everything you can see here. What is the error you can see here.
Got it.
Okay.
Okay.
Later I power up this one.
Okay.
Then here is the memory card slot. Then here is the I/O lah. Add the I/Os.
This is the I/O.
But this one is
So here is a
two port.
two port lah.
Yes, okay.
In
Another
and
one
out.
I want to show you.
Okay.
Can you see the part number? 1511.
Yes.
C, right?
Yes.
Okay, C means compact.
Compact. Okay.
Compact means come with some I/O. That's why all the 1200 always come with the C. Because all the 1200 model is a compact.
Okay.
For 1500 model, only this one is a compact. Means come with some I/O.
So they are have those
Yes.
on the I/O.
If you don't have the C, only the CPU only.
Okay.
Like this, the 300 model. That one you see is 315 only. So means it's just a CPU only. Okay. Then PN. PN means it's a Profinet.
Oh, PM means Profinet.
Yes. That one will have a two, PN and DP. PN means it's Profinet, DP is a Profibus.
Okay.
DP they call decentralized Profibus.
Oh, decentralized Profibus.
Yes.
DP.
PN Profinet.
Okay. Question.
Yes.
Modbus also use also use this RJ45.
Okay, TCP/IP, Modbus TCP/IP.
Right.
Yes.
My question is, let's say I assume I have a PLC, I say at 1500,
Mm.
and 2, and then I go module. So essentially my RJ45 port used up already because I do a ring here, right?
Okay, okay.
Yeah, and then but still I have a lot of
Modbus, you want to program
yes,
Modbus.
for example my VFD all using Modbus.
Yes,
I
yes.
want to connect to here. How?
Okay, so let's say you already have two, right? So one port you use for the Profinet, another port you want to use Modbus CAN.
But let's say I
Both you already use.
I have a 10 model.
Okay, already use both.
I already.
Done. You add one additional Ethernet module.
Oh, I/O, consider I/O.
No, it's an Ethernet module.
Ethernet module.
Yes.
Okay.
It's a communication module. Why buy one communication module? Use that two for the Modbus.
Oh.
For here, this one's okay. For this one, communication module, this side must add. Can you see this cover? This side must add. I/O module, right hand side. Communication module, left hand side.
Oh, so this is not called the I/O module, communication module.
So this side, all is here. Communication or I/O, all
I
is
can
this side.
randomly slot, doesn't matter.
Yes, no problem.
Oh, for this one you have to left and right must be
Yes,
here.
yes. Left is communication, right is I/O.
This communication module is considered one kind of switch or not considered a switch.
Like a switch lah. Sometimes we left one port or two ports. Like a switch also can use.
Oh. Okay, got it. Yeah.
Yeah.
Yeah. Okay.
Okay. Next. Okay. This one later we'll see lah. Okay. But okay, never mind. This one we can see. So you know why we use byte, why we use word, right? Because one bit means it's just 1 or 0, right? If I have in byte, I have 8 bit. So if all 1, 1, 1, 1, 1, I will get 255. Okay. Same thing for word also. Word is actually integer. What is beef? Actually, word and integer same, 16 bit. What is the difference is word only positive values.
Oh, okay.
Integer can be positive, negative values. So the same number they make it half. 32,000, positive 32,000, negative 32,000.
Okay.
So that later on we'll go inside that. Okay. So like I said just now, your digital input is a bit. So must use I0.0, I0.1 because it's just on or off. If let's say analog, you will have a value. So you must use one word, right? One word. Why cannot use 1 byte? Because you see 1 byte maximum is 255 only. But my analog value is 0 to 20 milliamp, 0 to 20. Inside the PLC is 27,000. So I need one word to store the 27,000. So that's why I use one word.
Okay.
Okay. Then later on when we do analog programming, we understand better.
Got it. Fine. Okay.
Okay, got it?
Yeah.
So later we see. Next. This one only. Later. Okay, you can escape. After this one, you can escape.
Okay. Oh, just go.
Go to the software. This one only. This one later. Analog.
Okay. Alright.
Okay, you minimize.
So I go to another folder or?
No, just minimize. This one. That's all.
Minimize.
Yes. Our theory is that's all. Like after this, all practical. Okay. Now what we do? Okay. Minimize this. Okay. Now, I want to first thing I want to upload the program from the PLC. Okay. Okay. So here we have a PLC. Here here we have a PC. Okay. So from PLC to PC we call it upload. Okay, or backup lah. But this is the term they use in the software. Okay. From PC to PLC we call it as a download.
Okay.
This is actually different between our internet.
Right.
Right. I will tell you one. Let's say this is our internet. This is our PC. So from the internet we take something, right? We call it as a download. If we store something here, we call it as a upload.
Yes.
Right. Why? Because internet is the master. Because all the data is where? Is inside the internet. So you is the user. So if you want to use some data from the internet, you download that. If you want to store some data, so you upload and keep inside.
Okay.
Here, the PC is the master. Because all the data is here, all your programming is here. Who is the user? PLC will use that program here. So that's why, if the PLC want to run one program, so I select from the master, I just download here. So this PLC will use that particular program to run. Same concept as this. So if I want to store my data here somewhere, so I upload to PLC.
Okay. Got it.
So that is the concept. One, I know always we confuse with the PLC internet.
Right.
Okay, so this is the concept. Okay.
Okay.
Now, if I have a PLC to backup, so first thing I need to know the IP address.
Do you want to jump a little bit? I asked this one.
Okay.
What does the MAC address mean here?
MAC address. So
No,
normally
we
IP address
frequently
we
use
have
that.
a MAC address, but very rare I use.
It's not when you do configuration with your TIA portal,
No need.
connecting a lot of
No
things. You do not need the MAC
No need.
address.
Just the IP address
Or
enough.
just the IP address.
Yes.
Okay, got it. And continue. Yeah.
The MAC address, because I never used before MAC address. Maybe some networking programming lah, you know,
Maybe
some
go to the IT. Yeah.
IT side maybe they need.
Oh.
If you connect it to server or something, then I think we need the MAC address.
Normally when we work, IP is sufficient.
Yeah, IP is enough.
Okay, got it.
Okay. So for the 1005, the IP address from the screen you can get.
Oh, okay.
Okay. On the screen you just go network you can get. Okay. But for this 1002, you need to use the software to scan.
Okay.
You use the TI portal to scan first, then only can get that. Okay. Now, if I want to download or upload anything, the IP address, because IP address will have 4 numbers, right? The first 3 numbers must be same. Last number must be different. Okay. So now we don't know what is the IP address. So what we do, very simple. You can right click the internet.
Right click.
Open network setting. Change adapter option. Your network cable is unplugged. What?
Oh, okay.
Okay, now connect. Okay, you double click properties. Go down. Can look for Internet Protocol version 4.
4.
Yeah, go up. I think version 6 only they will use the MAC address.
Oh, okay. But I remember for PLC, we always
IP,
go for
yes. Version 4, yes. Okay. So now, since we don't know what is the PLC IP address, right? What I do, I will put as a IP address automatic. Okay, okay. Okay. So this one can minimize later want to change. This one can close.
Okay, so I'll wait for it.
Now already automatic, huh? Okay, now you open TIA portal. Version 18, which one will take some time?
This TIA portal, yesterday I asked you, you say I can copy from you, right?
Yeah.
Question, that software I copy from you. So what is it? Is it genuine software trial version or it's a
No, it's a full version.
it's a full version?
Full version, but the license is not.
It's a what license?
Crack license.
What is that?
Crack.
Oh, crack license. Oh, okay, got it. Yeah.
So can use no problem.
It's a V18 can use no problem. Okay, got it. Understand.
But when you do projects, then only you need the original license. Because why? Because now my laptop is original license. Because this is the laptop I use for projects. Okay. So what happened is, so let's say I'm doing some project, someone come and want to check my laptop, then I can give okay.
But I just asked a question.
But when you do projects, then you need. But if the PLC won't know.
The PLC wouldn't know. Let's say tomorrow I use that crack version, I install a certain laptop and I try to connect to the real PLC and start to try to upload and download and change anything. If you not like something pop up or something stop the PLC, nobody will detect it.
No.
Okay, thank you. Got it, yeah.
Okay. Create new project. Okay. You name it as upload day 1. Okay, then here you click here. You select your folder, desktop. Okay, create. Very clear. Leave me on. I make a call. Okay, good.
Okay, yeah.
Can.
Yeah.
Sorry. Just the wife message me. House no water something.
Oh.
Then I check my email because management they do some repair in the pipe. Didn't inform, they just email me. Okay. Now, so if I want to do new projects, then I can configure a device and everything lah.
Okay.
Okay, means I do new project then download.
Yes.
Okay, but now I want to upload, right? So I go to project view. Yes.
So this is a okay.
This is called portal view. This is called project view.
Okay.
Okay, so project view where on the left hand side you will add all your hardwares, okay? Then on the right hand side you can add all the instruction, the libraries is there. On top is there what? The project, insert, online with the PLC tools, everything is there. Okay, later we'll see that one by one. Okay, okay. First thing. Now I don't know what is the IP address, right? Okay, I can go to online access. Can you see got so many lah? Ethernet connection is your Ethernet port lah. Then PLC, SIM, wireless, everything, right? So now we are using the Ethernet connection. Ethernet. Okay, you open the Ethernet. Update accessible device. Just double click. Okay, so you start to scan here. Yes.
Question.
Yes.
Normally, when you do this, let's say you want to work with this PLC, because consider this, how I should say, in a project, probably you have like, I don't know, a lot of PLC, and then every PLC, they are somehow, they connect to the switch, right, and then they communicate to each other.
Yes.
So now I scan it, I connect to this PLC only. When I scan, I can only receive this one, but I cannot receive PLC everyone else.
Yes.
Oh, okay.
If you connect to the switch, then you will get all.
Or if I connect to the switch, then I will get all.
Yes.
But if I connect to here, I will
Directly
get
means I only can see here.
Okay, got it. Yeah.
Okay, good question. Let's say that one got 2 port. No, this
This
power
one,
pack
okay.
got 2
Yeah,
port.
this one has 2 port.
Let's say one port is go to the switch, then from the switch I go to the VFD everything. Then one port is available. Okay. Then let's say this one my laptop I connect to another switch, I scan. Okay. I will get this PLC and also the others also. Because the two inside there is act as a switch also.
Okay.
Because one is empty, I connect to the PC. Another one is I go to the switch. From the switch, I go to the VFDs.
Yes.
So the piece, my laptop connect here, right? I will scan this PLC and also whatever connected to this port, so I can scan.
Like, so you mean it's like if this is like a lower level than the PLC, then I scan this one, then I can receive everything lower level than this.
Yes, yes.
But I cannot see anything higher level than this. Like from the high level, I don't know what you call this. I'm not a networking guy, but like
Okay. Low level. Okay. But okay, what I can see all the Siemens modules I can see here. Let's say PLC, then drives. Okay. But not only Siemens. Let's say I have different brand VFDs. Is already have a Ethernet IP address. Okay. So the conclusion is. Anything connected to the PLC, my PC can scan, whether it's a lower level or higher level.
Actually, the question is okay, I know this is, I'm a beginner here. I want to ask this question here. Say I use a 1500 and then I have a lot of things. Probably I say I have something is, some are just low level like drive, VFD drive, is a Modbus. Some of it probably is a power meter.
Okay.
Like the switchboard power meter.
Okay.
Somehow I like to connect to here.
Okay. Connect using Ethernet.
Yeah.
Okay.
Connect using Ethernet whatever. Probably something is like a BMS also. For sure, this one definitely not have that master switch. Very likely that probably my let's say the PMS, the power meter, I would not like to directly connect it to here. I have to go through another switch and another switch communicate to here.
Yes, okay.
And then now again, I want to do some programming from here, but using input from that all this kind of different device.
Yes.
So I connect to here, I scan it. Can I see everything else? Cannot see.
Can see. Okay. But if it is Siemens, it's come with like this. Okay, PLC, IP address, all that. If it is not Siemens, some different model,
Right.
just show you the IP address only.
Just like this one.
But just IP address only. It
Just-
won't show you what is that.
Oh, so it's, you will say that 192.168.0.18
That's all.
something,
Something.
but you don't know what is it.
What is that? Yes.
Okay, but you have to figure out, oh, because I configured that to be 18 already.
Yes.
So this is actually a power meter.
Yes. So what happened? Here only show whatever TI portal can read. So TI portal can read Siemens HMI, Siemens PLC, Siemens VFD, and any brand VFD using Profinet.
Okay. Whatever is not Siemens, it
It
will
only
still show here, but you don't know what is it. That's it.
Yes, correct. Even very simple, your laptop. If let's say I have one laptop, I connect to the switch. From the switch, I go to the PLC. Okay? I use another laptop, I connect to the second port, I scan. I will get that PLC and also a desktop. It will show a desktop.
I want to ask this. I'm not the networking guy,
Can, no problem.
I just don't want to confuse the terms here. So is it correct to say that it can read anything is within
Within,
the-
yes, within this.
the subnet?
Yes, correct.
Can read anything within the subnet?
Yeah, of course.
Okay, got it.
Of
Yeah.
course.
Okay, so there is a term here. So when I
Yeah.
communicate to people, I
Yes, because
yeah.
within the subnet, within the
Within the
similar
subnet.
subnets,
Yeah.
so this my laptop can scan
Can
whatever
scan.
connected within the subnet.
Okay, got it. Yeah.
Okay.
Yeah.
Right. So now you click here. So now I get IP address ready.
Yes.
Okay, now you click here. Now you click online diagnostic, but you cannot online now.
Oh, okay.
Yeah, I tell you. So 192.168.01. This is standard lah. When you buy new one also same thing. Okay, when you create new project also same thing.
Okay.
So it's always same. Okay. So now I can online and diagnostic. Actually, I can go online diagnostic. I can see what is the problem with the PLC. I don't need to download or upload anything. Just go here. Just go to the online access. I can see. Okay, now it's not really done now. Actually, TI portal very heavy. The software you must use minimum i5 you're using Intel lah. Okay. If I'm using AMD, I think Ryzen 700 or 500.
I5 what gen? Minimum.
Minimum. But if you have, patient thinking all lah, minimum 9 or 10 gen lah.
For 9 or 10 gen. Okay.
Better lah, better to use. My laptop is what? My laptop is 10, but I'm using i7.
Okay.
But still it's slow also. You can see that one is what gen?
This one is i5, but I don't know what gen is this.
Oh, it's a big pro one. Okay, wait. And my laptop all 7 or 8 gen. But for training purpose can use lah. 7 or 8 gen.
Yeah, programmer always use the most advanced laptop.
Yeah, that's right.
Yeah.
Okay. But better to use bigger than this. Okay. So I'm telling the least recommended.
Got it.
Okay. So SSD must use SSD. Okay. Then RAM.
How big is after install normally?
TI portal, I think you need around 15 GB space.
Also small, yeah.
15 GB. But depend lah, you want to install only TI portal. Then later on you install the drive, there's so-called WinCC, all that more than that.
Like typical one project
Typical.
how?
15 GB.
No, the project file itself.
Oh, the project file.
Ah.
Project file MB.
Very small.
Very small.
Okay. No matter how big the project.
Yeah, no matter how big
the
the project is.
The TR model is a big one.
Yeah, for the software.
Okay.
RAM minimum 16 GB. Minimum. So like for the best one is 32.
Okay. Okay.
Then better. My laptop I use 64 still. Sometimes
Can run.
Can run, no problem. That one can work. Okay, why I need bigger RAMs? Because of course like to operate the software I need have minimum 8 GB, to operate only the software. But when you do projects, right, for training normally I use 16. All my laptop 16. Because training you won't open much windows. But when you do projects, right, you open care portal, you open the process flow, the document, you open the manual. Sometimes you open YouTube and see how to program this Modbus, you forget already.
Got it. Yeah.
So better. When you do projects like this laptop, this one is a workstation.
Okay.
Okay, good. Okay, now you see I cannot get anything, right? Cannot. Why? Because my PC don't have IP address. Okay, so this method we do here because we want to get the IP address.
To read this number.
To read this number, that's all. Okay, now we go back to here.
Before I go back, question.
Okay.
I see this is 192.168.01. This is a disk application.
Yes.
Is this number? It appears to be 0.0.1 is because you set it before.
Yes.
Oh, okay. It's not automatic generated from
Not
inside.
automatic. When you buy a new one, is in the ISO standard,
Okay.
not the IP standard. ISO means no IP address. Because there's a two types. One is the ISO, one is the IP. Like TCP IP. IP you have IP address.
Okay.
ISO, when you buy a new one, there's no nothing inside.
And then how you going to set it?
Then we create a new project. Then we download, it automatically update a new IP address.
Then it becomes 0.0.1.
0.0.1.
So let's say, assume today I have a 10 devices, then I want to name it to this 0.5. So if I name it 5, disconnect, later I see it again, it will become 5.
Yes, correct.
Okay, got it.
You when you create new project, inside the project, you need to change the IP address. Then only you can download
here
through the software.
Okay.
You can change it. For this one, you can change in the screen itself. The 1005. In the screen, you can change.
I want to ask a little bit more. So says all these PLC and a lot of devices, they connect to a lot of industrial switch. I'm not a networking guy. Then we have to do something called patching.
Patching, okay.
Because this is what my project team always tell me.
Okay,
Why
okay.
this is connected? Because haven't patched yet.
Patch, okay.
So what essentially are they doing here?
I'm not very sure. Let me see. Patching.
Patching, yeah. Because it's like let's say we have a lot of PLC all installed already, all terminated already. Are we ready to download the program? Not ready yet because not patched yet. So I was curious, and then this patching has to be ensembled with the industrial switch itself. It's like setting the right address but like you say
Okay, that's actually good. But because I never heard about patching.
I know it's a networking
Networking lah. So I
process,
see
yeah.
it's patching. They say like update the software or firmware or something. Okay.
I think not that neat. It's a networking patching. It's like, but never mind.
No. I know where you come. Okay. Actually, there's two types of network switch. One is managed switch.
Right.
One is
Exactly.
unmanaged switch.
I think they're talking
So
about
you're
managed
talking
switch,
you're
yeah.
talking about managed switch.
Yes.
Unmanaged switch is normal switch.
Oh, okay. So normally people use unmanaged. It's
Just
a
normal.
switch.
Just connect normal. Managed switch, because the managed switch, okay, let's say I have an 8 port, right? You can do setting on the switches.
So
on
the
the
IP
ports.
not necessarily have to come from here. I can set it from the switch.
No. IP still here.
Oh.
In the managed switch, normally what they do, you give priority. Who is the most priority data from where to take. Then managed switch, if you want to block one data, you can block one one port on the block you can block. Manage
Okay,
switch.
okay. I kind of get what you say.
Yes.
Is it something like a broad junction? If it's unmanaged,
Yes.
whoever can go to which way. Managed switch is you set up a traffic light there.
Yes.
You can tell who
Yeah,
can
who
go
want
to where,
to, yes.
which number only can access to which number.
Yes.
Okay. If I didn't catch it or didn't do the configuration at the managed switch, nobody can have the data pass through it.
Yes, correct.
Okay, thank you. Yeah,
Yeah.
clear it up already.
Yeah, and for advanced feature, yeah, like the same thing like traffic priority. You give security configuration, like minus feature you can do like traffic priority, security configuration, customize lah from which one to control. Actually suitable for larger network, more device.
Right, because my last project is like 70 over PLC, so
Oh,
right.
actually your project, what project you do?
I was done a semiconductor plant
Okay.
in the last project lah.
Okay.
So
Where?
in Malacca.
Oh, in Malacca.
Yeah.
Okay. So you connect to all the PLCs. Then what do you do?
We have a lot of PLC for
Okay.
a lot of different functions, different
Function,
systems,
process lah, okay.
a lot of systems. So we have to do commissioning, right? So we bring out the system one by one. We have to do check, but we have a lot of this how you say roadblock because all this patching is not done yet. This networking has problem and so on and so on.
Okay.
So just wondering how that
You connect all to one system or just one by one? I mean,
Um,
standalone.
essentially in the end it's all the PLC, all the few devices.
Okay.
It go to one SCADA.
Oh, SCADA.
Right.
Okay.
So everything has to read from the SCADA and
Yes.
do the commissioning.
Okay. So you need, of course, you need all the PLC.
Right.
One
It's not
switch.
exactly like everyone have to talking to each other. Lah.
Yeah, of course.
But everyone have to
Send
monitor
data
and
to the
control.
SCADA.
Yes.
So in between you use a controller or just direct to SCADA?
So let's go to the point.
Mm.
Some is through the PLC,
Mm.
some is direct to the switch. Yeah.
No, what I mean is, okay, let's say you have 10 PLC, the SCADA can talk to 10 PLC, or what you can do, 10 PLC go to one PLC, then from one PLC SCADA take the
Normally no. Normally it's a direct all
to the PLC, okay.
all
Like
go to
a-
the SCADA lah.
Like a DCS. You know DCS?
Right, yes, I know DCS, but actually I don't know what's the real difference between the DCS and the PLC. I cannot tell actually.
Okay, very simple. DCS actually is more complex than PLC.
Okay.
DCS is more complex than PLC and more expensive than PLC. Okay. DCS is like it's already built-in SCADA.
Ah.
So you have a SCADA, you have a DCS controller. That DCS controller connect to another controller. That controller go to your devices.
Wait,
like a
so
PLC.
you say, can you elaborate more what's the difference? Let's say
Okay.
PLC, PLC is program only.
Mm.
The
DCS
runtime everything is at the server, right?
Yeah.
And then DCS has no server.
No, wait, I will tell you how it goes. Okay. Let's say I have a PLC one. Just do two. So this one go to your machine. This one go to your machine. Okay. Then what happen? They connect these to one DCS controller. This one come with the DCS lah. This is actually the DCS. Actually, it's a SCADA system. Same thing.
Okay. So the DCS here
But it must use DCS controller.
is a something like
It's
this.
something like that controller. One controller.
It's a controller.
Yes.
Okay.
So you can collect the data from the PLC. I go here. From here, I go to the screen. I consider screen.
Hmm.
Okay. SCADA, same thing.
DCS it's not considered as a SCADA.
No, it's not a SCADA. They don't call it SCADA.
Oh, DCS, normally they don't call DCS as SCADA. It's
They
different.
call DCS.
So actually DCS is the same as our
Similar to
data
SCADA.
server.
Similar. Okay. So this one. So let's say I have a switch. Actually here also I have a switch. Let's say I'm using Ethernet, right?
Okay.
So this one connect here, this one connect here, and this one I can directly connect to a SCADA. I no need a controller here.
When you say SCADA here, it's a server rack,
It's a
right?
PS. It's a PC lah.
It's a PC.
Yeah.
Okay.
Mm.
Whoever lah is either run, but
But normally
people buy a
SCADA
server lah.
server lah.
Okay. But you can install the runtime at your laptop.
Yeah,
and
normal
run it
also can. It depends on the speed, everything involved there. And this is a switch, okay? Or in between here, you can put one PLC also can. Means all this data sent to this PLC, from this PLC I go here. Also can.
But no meaning lah, the DLC. I mean,
And no meaning, no, not like no meaning.
I mean it doesn't serve any
Then it-
purpose already.
But this one is like a server. Work as a server means collect all the data, send here.
Okay.
Ah,
But in the end,
In
let's say
the end,
the SCADA
direct
system, the runtime is at the computer there.
yes, of course.
This DCS how?
The runtime is at the computer.
Also at the computer.
Yes. The same thing, whatever you see the screen, here you will see the screen. But the thing is, DCS laptop, as a laptop, right? You have a screen. Same thing, distributed control system, right? You take the data from here. You take this. For here, it's optional only. You don't want this one? Can. Why they use normally a PLC here?
Mm.
Because maybe one PLC is Ethernet, one PLC is Profibus.
Okay.
So what they do, I use like one Siemens or 400 or 300. One is for Profinet, all the Profinet connect here. One is for the Profibus, all the Profibus connect here.
Okay.
Then from that you take data.
Question.
Yes.
Says the PLC. I say a SCADA is a server SCADA already. Right? Does it really matter how it? I mean, just now you say so the SCADA server which can be a laptop, right?
Yeah.
Normally their communication protocol is what? Is
It's different. Any of these can be Ethernet or serial. And if Ethernet means, of course lah, you can use Profinet, Siemens, or you can use Modbus. Or you can use OPC.
PC also.
OPC you install in your PC. So OPC will be in the center. OPC is the one talking to all the PLCs. One PLC using Ethernet, one PLC using Modbus. All that you take data to the PLC, then from the PLC I go to the SCADA.
Let's say compare this SCADA here already.
Yes.
You compare to the DCS. Almost looks the same.
Almost look the same.
So what's the
What is the
people
thing
want to
is,
use
SCADA
the
is
DCS?
basically a monitoring system. Just a monitor. This is the one control, this is the monitor.
Right.
this is actually considered your like a PLC. This one will control, send the data.
You say it's a PLC, but it's
It's like a PLC, but it's called DCS.
the visualization, the
Visualization, of course, you
HMI.
need. No HMI. Visualization, of course, I need a PC for visualization. But the DCS is actually a controller, similar to a PLC,
okay.
but it's considered a bigger controller.
Because when you say the term controller here, you see I assume because this is what I always know. Process plant is always use DCS.
Yes.
Yeah, manufacturing is always use
PLC.
PLC. lah.
Yes, correct.
So I work in the process plant also before.
Mm.
So the question is this, but I don't get why it's very blurry the
Okay.
Yeah.
You just give me which one you know.
For example, DCS here. I say it's a process plant. I assume just randomly say, okay, it's probably a 5 system inside the process plant.
Okay.
One is probably a water system.
Okay.
One is a raw material system.
Okay.
One is a processing system.
Okay.
One is a final product system, and one utility system. Okay, 5 systems.
Okay.
So each of it, I say, is controlled by its own PLC.
Yes, of course.
PLC 1 is a water system. PLC 2 and 2 is a raw material system, and so on and so on.
Yes.
So all the control of the process system, how where is the PID, where is the interlock, where is all this function, I/O, everything, is inside the PLC, not in the DCS.
No.
Not in the-
DCS can do program.
Can do program, but
Yes.
it's not in the PLC. But you mean that essentially DCS is a big PLC, lah?
Yes, consider big PLC, that's all.
That's all.
That's all. More centralized. It means okay, this PLC, what is the data works is
It handled a very small
very good,
I/O and
very
very
good.
small brain.
Okay, this one only control this.
Uh,
Not only control this. Connect to here. This DCS, whatever, take data from here and here to control here. So here I can do the program.
okay.
Control-
Whereas SCADA, normally you cannot simply use the signal from here to
Yes,
the other
no.
side.
SCADA is just to visual. Visual, you want to control, can control. You send data to here, this one will control here. You cannot link this PLC to this PLC to control.
I know what you say, but I try to be more clear.
Can.
So you say, I say, let's say this one, we have a lot of PT, and
Yes,
so on.
okay.
Okay. From SCADA, I don't know, you scan, right? And then you receive the signal from here or from
Yes,
here, and then
yes.
you go back to here.
Yes.
You can, but it's not advisable. You get the signal from here, and in real time, all the time is this PLC is doing some PID tuning, get the signal from this
Can
PLC.
do also.
Can do
Can
also.
do, but it's between these two guys only. SCADA is not.
Okay.
Not
So
equal to
it
each other.
can be
Yes.
like this also.
Yes, correct.
But if you can do like this, almost the same as a DCS.
Yeah.
Functionally it's almost
Yes,
the same.
functionally is almost same.
But this one actually it can do everything is no PLC even. You can have everything come back to the DCS.
Yes.
So in terms of hardware, how it look like? You have like 1,000 I/O actually.
Yeah. Will bigger hardware. Most Siemens they call PC S7.
Yeah, actually before that time I not even know what is a controller. I always heard people say it's
PC S7 is a Siemens SCADA or Yaskawa. Yaskawa they call what I forget it. Yaskawa also they famous for this. Yes.
So it's like one brain only.
Yes.
But you can have I don't know, it's still called remote I/O, you can have
Of course,
remote
remote
I/O.
I/O.
So you have 100 remote I/O connect to one PCS7,
Yes.
one brain.
Yes. So the who control is here.
And
It's like control data.
then it's a very centralized already.
Yeah, that's why they call it centralized. This one
Distributed.
distributed centralized system.
Then why is distributed? It's a very centralized already.
Means distributed because you have all the distributed I/Os, right?
Because the I/O is distributed,
Yes,
but
yes.
the brain is only
Yes.
one. Then this is the intention.
Yes.
Then they call it because they mean to be one brain control everything.
Control everything, correct.
And here is because PLC usually is a very limited power.
Yes.
So they have to split the brain to many different.
Many things. Just SCADA is just take the data and want to control. You can control only one by one.
One by one.
Yes.
But they don't mean to always let you to cross it.
Yes. Cross it cannot. If you want to cross, you cross between the PLC to PLC.
Okay, then I got your point already.
Yeah. Then another thing is DCS have high more security compared to PLC. SCADA. More security functions. The security features you do here.
Okay, I got it. Thank you. Yeah.
That's why it's like you say that like process plants are normally they use DCS.
Right.
Semicon, because semicon is like the machine stand alone.
You don't have to centralize everything.
Yeah, no need to combine everything. Maybe you combine to get the data, the values.
Right.
This machine, what is the temperature? This machine, what is the flow? What is the pressure? Everything you want to take data can, but you won't control everything. Just to read each data and everything.
Right. Normally, you don't need like a process plant. You have to like
Yes.
set all the do all the PLC tuning for
Yes.
process system. Yeah. Okay.
But another one is what? Okay, the main difference now. SCADA is large. Because why? Because you can connect to many PLCs, so many IOs. This one is within this PCS7 only, depend on okay. PCS is more local, means the particular systems only you can connect. I think DCS, if not mistaken, you cannot connect to the cloud system or the SCADA can connect to the cloud systems. Okay?
Can also, I mean, if your PC
Yeah,
also
of
has
course.
a OPA,
Yeah, of course,
you
you
can
can use the
use
OP
the
lah,
OP,
of course. Then DCS is like they say, it's more precise and continuous process. This just focus on that process only. Like SCADA is like monitoring, just monitoring and higher level supervision only.
Right.
Then of course like DCS is more expensive lah. Like you say lah, DCS more to chemical plants, power plants.
Right. You see, DCS, normally they cover the space is very big one.
Very big one because
the whole process plant very
whole
big, right?
process plant is
Yeah.
controlled by, because if one fault, because you need to take care of all
Yeah.
others.
But I know that SCADA, it's not SCADA, PLC. PLC normally is used in a very small system or small area, right?
Yes.
And typically, especially this high performance, one thing I know, and not to say I know, I guess the difference is PLC has a very fast scanning.
Yeah, of course, PLC
Yeah.
are very fast scanning compared
Yeah.
to DCS system actually.
Right, so
Yes.
their response, especially on the robotic, on this kind
Yes,
of stuff,
robotic,
very
in
fast
milliseconds.
response. Yeah.
Not in milliseconds, ultras.
I don't know.
Yeah,
That's
ultra
really-
seconds, yes. Another thing is, okay,
Manufacturing always use PLC.
manufacturing, because they have systems like machine by machine, stack
Right.
machines, right? So
Right.
they don't need like small, they just buy one small PLC, just pressing machine. Because here I know my company, I do projects for them. Just small PLC only, just big, that big only, just pressing machine. Press, okay. Actually there's a one row. Here they press. Second one is another pressing something. Third one is the packaging. Like a one row lah. From here to until there only. Very small one only one person only. You know what happened? All these three, all different PLC. Actually they can use one PLC to this. What happened? They first buy pressing machine. So the second and packaging they do manually. Then later on when they are fun, they buy the packaging machine one by one. So the company, you know how big is the company? I mean the production area lah. I think if this two building until the end. They're just nice. This big only. There are 40 machines. So you just imagine how small the machine. This big only one machines. So 40 PLC. I go back up all the PLC because one of the PLC last time got problem. Suddenly program lost because of the battery.
Okay.
So they scared already, so they asked me to back up all the PLCs. So I go back up 40 PLC. So this one like manufacturing, right? Small systems. They just use small PLC or bigger PLCs. Okay, like one this row, want to put now 3 PLCs. In the future, want to upgrade, only one PLC can control. Yes, can control one PLC. Just more I/O.
Okay.
Like manufacturing, semiconductor, all that. Like chemical, all that is used these days. Another one is expensive, very hard to get.
Yeah.
That's the thing. That's why still.
PCS very hard to get.
Yeah. And
Because
training
very-
also, I'm not sure who give. Because last time some company request training for us.
Or to do the PCS.
Yes, DCS training, but we don't have the hardware. hardware is very expensive. They don't have smaller hardware. Like this, you see, a Siemens. So I can buy the smaller hardware to do training later on. When we have money, then we can buy the bigger one like this. So like
they buy one piece, one BTCS minimum also very expensive already.
yeah, this is I think this is $7
Because their power is definitely very.
yeah, because controlling straight away controlling more I/O. This one I can choose.
I mean, you can choose like I don't know.
less I/O that later on then we can add more I/O. This one is found straight away.
Okay, your point. Okay.
Got it?
Yeah.
Alright. Okay, before we go for lunch, please. Okay. So now what we do? So since we already know the IP address, the laptop don't have IP address, right?
Right.
Okay, now we change the laptop IP address. Go here. Double click. Properties. Go down. Yeah. Okay, use the folder. Okay, you set one IP address. The first three number must be same. The last number, okay. Okay.
Just click OK.
Yeah. Okay. The subnet by default, right? Okay. Okay, close. So you can close.
Okay.
Okay. Now you update again.
Double click.
Double click. So you update again. Okay. Now you get the PLC, right? You open the PLC. Actually, this one is important before you going to upload. Okay, online and diagnostic.
Double click.
Okay.
Okay.
Okay. Now you can see the block data all can see. Just now earlier don't have, right? Because
Okay.
earlier my laptop don't have IP address.
Okay, so if I
Now
set the communication
same
correctly.
subnet.
Ah.
Yeah, okay. So here got error. What is the error? You go to diagnostic buffer. IO device not found. Yeah, because no, last week I connect one module at the back. I removed that one. That's why I got IO error.
Oh, okay.
It's supposed to this module is supposed to be connected to that error output module.
That's on this IO module here.
There's
Okay.
a one module, additional module that's similar to this.
Oh,
I connected to that because
okay.
normally day 4 and day 5 we learn analog, right? So that time only I will connect.
Okay, okay.
So when I want to do this one for today's training, I remove that one so no error.
Okay.
Okay. Now go to general. Okay, in the general, what are the data we see? There's a two data here. One is your PLC firmware. Okay, 4.2. Okay. Whenever Siemens release new TI portal version, they release new firmware. Like I said, they don't release new hardware. Just improve the firmware. So 4.2 actually is the old firmware. New one is 4.7.
Say I have a program. Let's say this is a running plant already, and then they have a program. And Siemens release a new firmware. You download the firmware to the PLC, it will not affect anything.
Actually, no need to download the firmware.
No need to download.
No need to download.
Oh,
Unless the new firmware have new features and that for a particular
normal
period.
people will not like
No need.
keep on updating your Windows.
No need.
No need. Okay.
Okay. Because why? Can do. But the thing is, before you do, you must back up the file first and keep.
Okay.
Then only you can upgrade. Actually, you can upgrade the firmware. When you upgrade firmware, if there anything error, then you save your program.
Oh, so
But-
there's a risk there actually.
Yes. But normally you don't need to do that because why? New firmware, new features. If let's say that particular machine you want to use the new features,
Then only.
then only you do that.
Okay, got it.
Then other than that, if it is running fine, you are not going to do this. Use these features everything. Only to update it.
Got it. Yeah.
Okay.
Okay.
Number 2, TIA portal version. Can you see version of TIA portal projects?
Yes.
This is very important.
Okay.
Why? Means this is the version the previous programmer used in his laptop to download.
Okay.
Okay, means the previous programmer used version 18 to download. So if you want to upload, your laptop must be version 18.
I cannot use a V20 to.
20 also cannot, less than also cannot.
Oh. Project must be always the
Same
to
thing.
the version.
Okay. But this scanning, right? This scanning, your laptop can be any version. Starting from version 13, I think. Starting from version 13 until version 20, this online access, right? This one can do to any version.
Okay.
So let's say your laptop is version 15. When you do this one, you see version 18, right? Then you must use laptop with version 18, then only can upload. This scanning, no problem. Any version can scan this one.
Scan no problem,
Scan.
but doing the programming cannot.
You want to upgrade also cannot, upload also cannot. Only what you can do, online access.
So it means let's say you guys do project, right? You have to have a few laptop of different versions.
Yes, normally the programmer what they do, one laptop, they use the virtual window.
Or has to use a virtual
Window, yes.
Oh, then your laptop has to be more powerful even.
Yes, that's why the RAM 64 GB RAM, the SSD 1 terabyte SSD. So because one project I use version 17, after that I won't use. So what I do, I use the virtual window. I do the program everything, test setting everything, then I can delete the virtual window. I know some programmers they come for training. Actually, some of the programmers also they come for training. So they want to learn some advanced functions. Sometimes they don't have time to go themselves to learn. They come for training.
Or you can do you don't, so you take still the no basic training, straight away go to advanced training.
Yeah, because sometimes they request for only advanced, intermediate advanced.
Oh.
They come for like they ask me, okay, can you teach Modbus or PID control, this data logging, all that. Then I say, okay, whatever you want to. That's why I ask you. Whatever you want to learn, just give me the list. I can see how many days I needed to teach you.
Okay.
So that's what I normally do. So, but in my case, what I do, my laptop I have version 18. Version 20 also I have, but I haven't installed yet. Then some laptop I have version 15, 15.1, 14, 14.1, 13, 12. Only 16 and 17 I don't have.
Okay.
Because all that because I installed because of a project only. Because last time we used 15 for training. After that only we upgrade to 18. So some laptop. So if you didn't see this one, it means what? Okay, that one will happen when you use your laptop to scan the 300.
Already old model.
Okay, like I said, the 300 also can use TIA portal. Right? Can use TIA portal also can, SIMATIC manager also can. So if I scan, if I get this one, like this last, any version also can. Means the previous programmer used TIA portal to do project there. If you didn't see anything, it means they use SIMATIC manager.
Okay, so probably they did anything they do without a TIA portal. You cannot see anything here.
Yes.
Okay.
If you cannot see, it means they use SIMATIC manager.
Okay. Got it.
SIMATIC manager no problem. Any version, because they have a new latest version, you can use latest version.
Okay. Got it.
Okay. So now our version is same, no problem. So what you do, you go up. Okay. Just click one of these. Just click on it. Yeah. So to tell my software that I want to upload to here, okay? Go to online. Can you see upload device as new station? Yes. Start search.
What is the station mean here?
Station means one PLC.
Oh, one PLC is one station.
Yes. Okay, so So can you see you get one PLC. Then if you connected the network switch, then you will get multiple devices lah. Okay. So 192, this is the IP address. So using PNIE, okay. Can you see type of PG-PC interface, right? PC means PC lah. PG means in German they call PG.
Okay.
That's why they call PG-PC interface. So we are using PNIE. It's a Profinet or Industrial Internet. Okay. They have a USB also can, but one thing with Siemens.
So normally we use the internet and we have to choose a PN.
PN, yes.
Okay.
But no, the one thing with Siemens PLCs are they don't have USB.
Oh, other
They
have
have, others have.
Oh, okay.
Evidently, which Omron, all others have USB. Only Siemens they don't have.
Got it.
Why? Because USB function is just simple. Upload, download. That's what you can do. You can do communication, means between inverter to talk on.
Okay.
So they just, I never seen before with any Siemens model. But drive all yes.
Okay.
Drive, HMI, yes, they have USB.
Okay.
So to upload, download all that.
Can use a USB.
Yes, that's why they have a USB option. Why? Because TI portal can back up PLC, can back up HMI. You see? Can back up drives, everything. That's why they have an option. Okay, now then the PGPC interface is your laptop network lah.
Okay.
Your laptop name. Okay, upload.
I click upload.
Yes.
Okay.
Because only one line. If you have multiple, then you select each one, then only can upload.
Okay.
Okay, loading configuration. Not sure what program is. Okay, can you see PLC and also on drive? Oh, okay. So this one can close, online access can close. Okay. Yes, okay. So I have one PLC and one drive unit, but the drive I cannot recognize. You see the drive? Yeah, I cannot recognize. Okay, because I only upload from the PLC. Okay. So you open PLC, you go to configuration. Device and networks. This one. Yeah. Double click. So my PLC connected to a drive, but I can recognize what drive is it because I just back up from the PLC. I didn't back up from the drive, right? Okay. Okay. So
This
that
is
what-
showing this program in the PLC has configured for
drive
have
communication.
drive communication
Yes.
inside.
Yes.
Oh, okay.
But it cannot tell you what drive.
Okay.
Okay. But if you want to, because let's say of course it's in the machine, you know what is the drive, right? So you can back up from the drive.
Okay.
If you're using Siemens one, same thing. Just go here, back up, then here you can see on the drive what drive you're using.
You say backup from the drive. I
This
mean
is from the
what?
drive.
Let's say, question. I have PLC and a drive. Let's say this is the tool lah. I use this PLC to control the drive. The drive has a lot of parameters and so on. I
Yes,
don't know what
yes.
have to be done there lah. It needs a program inside the drive also lah.
Yeah.
Oh, so PLC has a PLC program, drive has a drive program.
Drive program means the drive parameters.
The drive parameter.
Yes.
Okay. So PLC will not store drive parameter.
No.
No. And then when I do backup, I only upload from PLC, but I will not directly upload from the
No. You
drive.
didn't upload the drive parameters.
So here it's only show this PLC is
Connected.
communicating to some drive,
Yes.
but it will not have any information about the
Yes.
drive.
Any information on the drive.
Okay.
What is the drive? Everything. The
Okay.
PLC only can know there's a drive. That's all.
Question. Since this PLC today is not it's not using a ceramic, use other Danfoss.
Yes.
Then how?
Same. If the Danfoss I'm using a Profinet communication,
Okay.
then it will show like this, still show like this.
It still show
Still no show.
GFD. I don't know
Why?
what is it.
Because I use a Profinet.
Okay.
If I use Modbus, for Modbus I don't need to do configuration like this. So if I do Modbus, then after I back up, it won't be like this.
And let's say just now you said Modbus, it's not a Profinet.
No,
PLC communicate to the
drive.
Danfoss using a Modbus.
Modbus. It's like considered like a
TCP/IP.
TCP/IP. Like a Modbus is considered like what? Hardwire.
Oh.
So like a hardwire, like a hardwire system. For example,
Why Modbus is considered as a
I will tell you why. Because the PLC send Modbus data through the Ethernet cable. Okay, so at this side it can be anybody. So the PLC won't know who is that. Okay, PLC only send data, so the Modbus will have the address and the data and everything. So PLC won't know who is this device,
Okay.
like a hardwire.
Like very universal.
Yes, because Modbus is universal communication.
Oh.
So what happened? So in the PLC, if I'm doing hardwire, the PLC won't know who is this device. PLC only know whether it's on or off.
But the Modbus, the communication is more than on or off, right? It can.
Yeah, of course, it's just more than that.
Okay. Right. Okay.
The concept I'm telling.
Concept.
The
okay.
PLC, I just send data. I don't care who is that. Like
Okay.
output lah,
Okay.
normal digital output. I just on the output, but I don't care whether it's a relay or contact or anything.
Okay.
So when I back up, I only have PLC only.
Let's say I say this is still the case.
Yes.
This is a PLC. This is a Danfoss.
Mm.
It's really a Modbus.
Modbus.
I scan this. I upload this to the
Yes.
computer,
Okay.
and then I see here.
Mm.
It will show there is
No.
a device.
No, it won't
because-
show.
Not show because here is only will show whatever is from Profinet.
Profinet or Profibus.
Or for Profibus.
Yes.
Okay. That's a logic here.
Because Profinet and Profibus are Siemens protocol.
Oh, so it only shows the
Siemens protocol. Yes. The Modbus is like a universal protocol, so it won't show the universal protocol.
Consider same class as a 4 to 20,
Yes.
0 to
Okay.
10.
Yes, that's why I say it's like similar to your hardwire. Okay.
Okay.
Why it don't want to show you? Because when I do project for Profinet and Profibus, I just drag in the network device side. I just drag the drive and connect here. I do the configuration here.
Yes.
So and I download. When I
Modbus
back up,
cannot do.
Modbus cannot do configuration. Modbus I do programming.
Okay, I got it. So the point is, here is only show what the TIA portal can configure.
Configure. Yes, very simple. What I configure. That's it. But the thing is, it only show Profibus and Profinet.
But I go in a little bit deeper.
Yes.
So let's say it's still a Danfoss, but instead of using Modbus, I use a Profinet.
Yes.
Then here we show.
Show.
You can configure the Danfoss.
Can configure Danfoss.
Huh?
Yeah, of course.
Oh, okay.
But here currently only show Siemens.
But when you say configure, what you mean by configure? You can configure.
Modbus. I mean configure the Danfoss. But
I mean normally in a project, depending on how big it is, normally the VFD, let's say the OEM vendor will come, right, do their own configuration. So when you say the programmer can configure, meaning to say he can override whatever the OEM is done.
the parameter you cannot change.
Oh,
You
okay.
can control the drive
So
using Profinet. You can control using
or
Profinet.
you cannot change the parameter.
Change the parameter.
But
Even same thing this one also. Because why Siemens can change parameter? Because TI portal can do programming for Siemens.
so if this is not a Siemens, what you can do here?
What I can do here, I can just add the drive like this. After I add, I will get what is the I/O. So I just do the programming to control the drive.
Or receive the full list of the I/O.
Yes, receive all the I/O. What is the like forward, backward, everything I have.
Got it.
That just control.
Okay.
But I cannot set a parameter.
you cannot set the parameter
Yes.
inside.
Same thing for this guy also. For this guy, I add here the same concept, but I want to do parameter can, because why? TI portal can do program for this. Because TI portal already has the SIMATIC.
Sorry, I keep on buying this question.
Can, no problem.
Okay, so just now go back to this PLC Siemens that force again.
Yes.
So this time it is a Modbus. You cannot see from here. Then how do you do your programming? How do you know that this Modbus, no matter how you connect,
Okay, so
how
what the
do
thing
you
is,
address
okay,
this?
the thing is, in the Danfoss, they must choose what type of communication they are using.
Okay,
Modbus
okay,
or Profinet
okay,
or hardwire
okay,
terminals.
okay.
Okay, lah. So now you choose Modbus.
Okay.
So when you choose Modbus, in the manual, user manual, they will tell you, okay, Modbus, this particular address is speed control. This particular address is the forward backward control. This particular address is temperature, feedback, everything. In the manual you have.
Okay.
So the particular address you have, right? The same address you need to use in the program. You need to do additional Modbus programming.
So I will have function block as a
Block for that to
receive
the data.
data. Okay.
Then after that only, after I receive, then only I can use the data.
So this additional function block, you receive data from the Modbus, then you map it to what?
One memory or something, then only I do programming.
So you have to
Map, you need to map. I need map.
M,
M or the DB.
I have to use M or DB.
Yes. If direct Profinet, if I do the configuration here, after I do configuration, I already get the IO.
Oh.
So I can straight away do the program.
Oh, okay, okay.
Modbus is additional block to get the data first.
So you have to do an additional block to get the
Additional
data.
Modbus programming.
Okay. Clear the concept? Okay, yeah.
Now,
Clear
another
the
one I
concept.
have to tell you. This is Siemens.
Mm.
Then how I can get Danfoss?
Yeah,
Correct now?
yeah.
Okay. So what I need to do, can you go to tools here? No, go to, no, option. Okay, can you see GSD file? GSD, right? General Station Description, okay? So what I need to do, I need to go to the Danfoss website, and I need to go and download GSD file for Profinet. So there will be one file. Okay. After I download, I use this one to install.
Can you repeat again? Let's say from the Danfoss.
Okay, never mind. I show you here. You click here, device, drives and starters. Can you see? I only have Sirius and Dynamics. Both are Siemens one. I don't have Danfoss. Okay, so what I need to do? But if I need to do that if I only want to use Profinet. If I'm doing Modbus, no need.
Okay, got it.
Because Modbus cannot add here. So Profinet can add here.
Okay.
So if I want to add here, I need the drive like this.
Right.
Okay, you click here.
So that is a drive.
Yeah.
Okay.
Okay, so I just take one drive. Go to Dynamics G. Yeah, so I just need to know which drive I want to use. Just drag and drop here.
So I just pull it here.
Yes.
So
So
if
if
I want to install a new other vendor,
Other vendors one.
maybe I have to copy that drive to here first.
Yes. So that's one called GSD file.
GSD. What's the full name of GSD?
Yeah, General Software Description. In the
General
options.
software description. This is actually it's a driver.
It's a driver, yes.
Oh.
In LM they call HSD. Hardware Station Description.
Okay.
In Siemens they call GSD file. Okay.
Got it.
Like a driver lah. Okay. Once I install here, actually I think in this laptop I have installed before. You click here. Why driver can close? Why once I install here, can you see other field device? Go to Profinet.
Profit.
Profinet second one.
Yeah.
Go to drives.
Okay.
Oh, don't have one now. This one don't have. If I add other brand, it will show here.
Then I can just pull it, drag and drop here.
Yes, later we do. I show you. Because I have one drive. You want 10 ports also can.
I mean, if to make the programming easy, or I guess troubleshooting easy, if the other brand, whatever device is it, can support the Profinet, we should always use the Profinet, right? Why have to choose?
Modbus, additional
Right.
programming. Modbus, you need to. Modbus, because if
Any
you do
advantage?
that one, the GST file, programming is easier.
Right.
Anyone can troubleshoot.
Right.
If I do Modbus, want to troubleshoot, you must understand what is Modbus first.
Oh, so what is the advantage of using Modbus?
Okay, what is the advantage of using Modbus? Good question. So, if the drive is failed, your PLC won't go to stop. Still can run, but the drive signal you won't receive. That's all.
If the drive,
Fail.
you mean in the program?
Yeah. So if the PLC won't stop, PLC still can run. Drive already faulty, but the Modbus block, like I said, the block, right? From the block you have an error code. So you can use the error code to create an alarm error. But the PLC won't have a communication fault. If I'm using a Profibus, I mean if I'm using Profibus or Profinet, it's a drive fail. What happens in the PLC will have a communication fault.
And then it will stop the.
Stop the PLC. But that also you can configure whether you want to stop, so you can continue.
Very frequent, this kind of.
No. If you ask me, if anyone using Siemens, then they use different brand.
Yeah.
They will use Profinet or Profibus. They don't go for the Modbus.
Oh.
Because Siemens already have this file.
Because if you say the drive got problem, will stop the PLC. It sounds very serious also.
Serious, but the thing is, there's one additional program they have, so you can use that to make sure don't stop.
You mean still can use a Profinet do additional programming?
Yes, yes.
Oh, okay. Okay, I got your point here.
Got?
Yeah, very clear. Yeah.
Alright, so you already back up ready. Okay, go to program blocks. Some scaling lah, block lah. Okay, you go to motor control.
Okay.
Now, so this is the program that is inside the PLC lah. Okay, so can you see I input, right?
What do you mean by program block?
Program blocks, this is where I do all the programming. So they will have like block by block.
It's like your one PLC, you can have like 10, 20, 30 different blocks.
Many blocks. Okay. You just need to arrange. Or you want to do in one block also can.
Okay.
Normally the main, this is the main one, main block. Is already by default you have. The others all you need to add. So what this one I do is, in the main block I didn't do any programming. I do in the programming in the function blocks. I mean FC the function. It's like a subroutine.
Yeah. So you mean one PLC program? There's always one main block.
One main, yes.
But many
One is
sub
sub blocks.
It's like a-
or subroutines.
It's like a programming function block lah. So,
Yeah. Because you can arrange your program. Like these are I arrange two. Because one is for analog, right? Need to do the calculation.
Okay.
So need to do the scaling. Then one is for the control.
Okay. Okay.
Okay, good.
Yeah, clear. Yeah.
Okay. So 45. You just save first before we go. Right. So we go for break. Then after the break we can continue.
Okay, let's do it.
Yeah.
So are we taking too much time or we have
No, just
good Okay. So what time we are coming back?
1 hour.
1 hour.
Yes.
1:45 in here.
No
Okay,
problem.
sure.
You take your time because one person can be flexible.
Yeah, can
Because
fast
if
and
groups
slow.
means if I want to start, because sometimes if they come early, one person no problem.
Okay, thanks a lot. I'll come back at 1:45.
Okay, sure.
Yeah, thank you.
Okay. PLCs. Okay.
Hey, sorry, I'm late.
No problem.
Okay. You don't mind I make a tea, right?
Yeah, can you make a difference? No problem.
You want to opt in?
Yeah, one password.
1, 2.
Yeah.
Where you had your lunch?
No, normally I bring food from house.
Ah, okay. Easier.
Yeah, easier only to go. So I do some other jobs lah. Because sometimes I do
Doing other projects, yeah.
not project basically, quotation, invoices, or because only two of us. So he will handle all the marketing everything. So I will handle training, all that. So I have there's a project request from Singapore.
Oh,
Mm.
sometimes you go inside to Singapore to do project as well.
I think not very common lah. Maybe some like
But it's a
two
very, very
years once.
advantageous, right? Because
Because you can simply go inside Singapore and do a project.
cannot.
Cannot because you must have to permit.
Yeah, how you
Normally what I
do?
do? No, normally what I do?
They engage a local company again.
I think the because also the local company lah, they want to program, so I just do the programming part only.
Oh.
So I just do the maybe I go and visit what are the data I need, some input output, the flow chart. If they already give me, no need I don't need to go lah. So this so project already give me all the data.
When you say flow chart, what kind of document you use? Official document.
Okay, so let's say you want to give me a project. I myself I only do programming only. Right. So for me, you need to give me the IO,
Okay. List of I/O.
list of IO, and the flowchart.
You say flow chart is a PFD flow chart, or the sequence of
The
operation.
sequence, yes.
Sequence operation.
Yes.
Oh, okay.
You just give me okay when I press the start button, what need to do. then
But
after
normally you request them give you in a flow chart format lah.
yes.
Start and then
Stop, what happened,
yeah.
not working, so I need to go back, press start again, give alarm, everything lah. Proper flow PLC program. Then only when I install, then only maybe commissioning time, maybe I go, or sometimes they will have a team to do that. So
because this one, many different industry use different name. SOO, FTS.
Yeah, of course. So normally they use FTS lah.
Oh, the one you say is FTS lah.
Yes, functional design specification.
Okay.
Later I will go through with you because that one normally I don't only some training I go through like project procedures.
Actually, that one I'm interested. Like
Yeah, I will go through. So
starts
whether
this one.
you take a project, what are the important data you need until like from start until end.
Right. Input and output of a
Yes,
I mean,
the whole
the contractor project.
Yes.
Yeah. Okay. Yeah.
Okay. So just now upload, okay?
Yeah. No problem.
Okay, but we do a few times later on.
Okay.
Okay, now we start to do a new project. So in the new project only, I will show you how to add modules, everything.
Okay.
So what do you do? Just go to project new.
Here.
Can also. So just put it there, day 1, lesson 1.
Okay.
Maybe the name, I want to put specific. Configuration. No. Lesson 1, after the lesson 1, you can put configuration. Later on when you open this file, you know, okay, this one I use for configuration, this one I use for what? Programming or that.
Question. Just now we have save project, right?
Yes.
I want to ask essentially what it means by a project file here. The question is this.
Yeah.
Today, I'm Chan. Okay, I come here. I have a configure like one PLC plus one VFD and
Okay.
one IO.
Mm.
And then I downloaded it, and I uploaded it, and then I save it. Project one.
Okay.
Tomorrow, let's say you come in, probably you do the same thing again. You
And upload.
Yeah, you upload this plus another PLC, so your scope is bigger already.
Okay.
And then you save it as project 2.
Okay.
So that project, essentially, it just means that whatever file that you have
Uploaded.
uploaded to your computer,
Yes.
it doesn't mean the version of the program itself inside here or whatever.
Yeah, of course. The version is because when you upload, because it's version 18. So version 18, the firmware, your program blocks, I mean the program, the configuration, everything.
Actually, the question is like, how do I know? Of course, normally it's a one programmer lah. It could be multiple person also play with this. Today I upload, and then
Okay.
this is like a version of July 18.
Oh, okay.
Tomorrow you
the
come in
project
here,
version.
you don't know, is this the one done by Chan already, or is the one I done it last month?
Okay, so you can do comparison.
Comparison, but that's the only way to find out.
Yeah, only way to find out whether. Okay, I know what you mean. Okay, I just rephrase it. Okay, let's say today you come, so there's a machine running, you back up the file, okay, you keep in your laptop, okay, then after 1 month, they call you again to do some troubleshooting and everything.
Right.
So now what you do, you have the file, you don't need to back up again. But you don't know, in the meantime, if anybody go and do some changing.
Right. Who knows that's
So what I do, I open up my project, I just go online. Okay, I just go online. The file you already have, right? The backup file.
You are not
Upload
uploading
again.
You just scan and open.
Yes. So I do upload again because I already have the file. Okay. So what I do, I just connect the cable. I just go online. Can you see go online here? But now cannot click lah. Okay, now cannot click. Okay. I just go online.
Okay.
So what happens if no changes, and I think you can do. Go to project. You open up this one, upload one. Okay.
This one.
No, okay. Okay. The second one.
Second one.
Yes. So we open back the same file.
Yeah.
The same file. It's already open. You click here. Why cannot? You just click. Okay. Go online.
You will see anything here?
Okay. This one you delete because there's no drive, right? This one we don't care. We care about this one, green color. So means In your laptop and inside the PLC is the same, program block is same, PLC tagging is same.
Oh, what is not changed is green color.
Yes. If it is changed, okay, you go offline. Go offline. You go to program block. Let's say by mistake you change something. You go to motor control. Open. By mistake, let's say you delete this one. I click the normally close symbol. Yes, delete. Now there's a changes, huh?
Yes.
But how I know?
Yes.
Okay, you go online.
I have to click here and then I go
You
on.
can click any one of these, okay, no problem. Still the same thing. Can you see? It shows there's a changes in your this block. Okay, but which one is the change?
I can't tell. I
Can you right click, but that one later also we done, but I might show you. Right click, quick compare. So means let's say someone go inside your program already add something new. This is your old project go there. Okay, for example compare with online. Okay, you click yes. They need to close the block.
so this top.
Wait, it is automatically closed. Okay. So it will tell you where is the difference. So maybe you go down here. Okay, can you see network 3 all same, right? Green color is same. Okay, go up. Network 2 same. Network 1 different, right?
Okay, so this blue and orange is a
Difference.
difference.
Okay, go down. It will show you where is the difference. Here.
Or you highlight in blue color.
Yes. So online means is inside the PLC. Offline is your laptop.
Okay. So this is a program version 1.8.1 or something. It's just that you have to compare. And tell
Yeah,
me.
but the one the project file you want to save is depend on the programmer how they save.
Oh, this is a
Normally, what I do, okay, I know what you mean. Normally, what I do whenever I do project, okay, when I start, okay, I save as okay, project 1, version 1, okay. Then later on, I add something, version 2. I test first, add something, version 3, version 4, version 5. Sometimes I go up to version 20. So what happened? Because let's say I'm doing version 20, some additional programming, I test. If not work, then I do some changes. I messed up. I delete this one and I go back to version 19 again. But that one is when I do projects.
So I understand what you say. One project file, one new file. Let's say you are the master of this project. Essentially, your project file is all your configuration, all your program file for all the devices.
Yes.
So anytime, no matter you go to upload, today you want to troubleshoot only this PLC. So you go to here, upload, change, download again. So you do this program, and inside your computer, you have an updated version compared
Yes.
to the original.
Yes.
But it doesn't change your other files you've done for other device.
Yes,
So
no.
it's a collection of all the file.
Yes. Another thing, when you upload, this is an upload file, right? When you upload, you won't get the drive. Correct? Just now you didn't get the drive name.
Right.
But who do the program will
You
have the
can
drive?
see the drive.
Yes.
Okay, because he has a file in his local
Because
computer.
yes, so that means there's two type of file. One is the project file, the original. Another one is the uploaded file. So there's a two difference.
So this is a two different files.
Yes,
Okay.
two different files. Okay. Those who do the project will have the complete list, everything. You only upload, so you only upload from the PLC. You only get the PLC program only.
Okay.
The one who do the project will have the PLC program, will have the HMI program, will have the drive program, everything he will have. So if you want to do a backup, you need to do 3 backups.
I ask a question.
Yes.
Says, for instance, a commissioning team on site and a project design team and a programmer
Yes.
is a different location.
Yes, correct.
They do from a headquarter,
Yes.
finish the
Program.
design, the program,
Yes.
and then everything deployed on the site, right?
Yes.
The site commissioning guy he want to commission the
Do the
system.
commission, okay?
So he received what file? He
Yes.
received
The project file. That's called
the
project
whole
file.
project file.
Yes.
Okay, okay.
Because you cannot do anything with the uploaded file.
Oh.
Uploaded file is useful. Let's say the program lost, I download back. But uploaded file, you need to like it's all separated. HMI one file because this is TI portal. TI portal all together, right? HMI, PLC, drive all together. But when you do upload, you need to upload 3 programs. One from the HMI, one from the drive, one from the PLC. So 3 files. But the programmer who designed the program will have only 1 file with all the 3 together.
Got it. Okay. Yeah.
So later on, the last day, that's what we do. We can see that.
Okay.
So in one project, you can see one PLC, one HMI, one drive, all together in one file.
Okay. Got it. Yeah.
That's what the last day we did.
Okay.
Got it?
Yeah. Got it. Okay. Nice.
Alright, we go back. Go to project, open back the configuration. No need to save. Okay, go to add new device. Okay, so can you see? If you install TI Portal Professional and WinCC Professional, okay? So TI Portal Professional, you go to controller, you will have all this. If you install TI Portal Basic, you only have 1,000 rupees. Because the basic price is how much? I think it's around 3,500 to 4,000 ringgit only the software license. Okay? And
That expensive. The
What's
TIA portal.
uh,
You know, yesterday I tried to look from the internet see how much is the TIA portal. Not a cracker, like a
Original.
Original. There is a company selling around 200 over ringgit.
that is black.
Oh, that is crack. Crack also 200.
Yeah. You cannot get 200 because even the basic one is around 3,500 to 4,000.
I'm very surprised that how come so cheap. But it's selling from, you know, this RS.
RS.
Ah.
RS online.
Yeah.
Maybe I think it's
They're quite reputable.
trial version.
But try they can sell trial version. Okay, I don't know lah. Just
Because-
curious.
Because maybe because it's a CD. Very simple. TI Portal, you buy a CD, it's a you install in your laptop, it's a trial version. Until you connect the license, it becomes full version. It's trial version for 7 days or 14 days. So the one if you are talking about us online, I think it's a CD. You're talking about a CD. Not a license.
Trial version.
Mm.
Crazy. Try 200. Better go online. Just download it.
Yes, you can register to Siemens.
Yeah.
There's 2 types of registration, just a normal registration one. Another one is the authorization registration. So they just email you something like. Normal just sign up only. Normal you put a email, one password, okay, sign up. You can download some software from that, but TI Portal cannot download. Then there's another registration for authorization. For that you need to put your name, company name, and your address, everything. Then they will send you an email, authorized email. From that you can download all the softwares.
From the email.
Yeah.
But that is
After
fine.
your email, then you can go into login again to the Siemens website. You can download. But all is child version. They don't sell license. So you can run for 7 days.
7 days.
Yes.
Okay, got it.
Just now I talked about the license price.
It's a few thousand ringgit.
Yes, of course.
Okay.
So if you're using TI Portal Professional, it's around 11 to 12,000. Only TI Portal Professional. So TI Portal Professional, what I get? I will get all these. I will get HMI.
Okay.
So you go to the HMI. I will get the basic panel. Okay? Basic and comfort panel. Which one is the better? If you need any software, you can request from me also. We also sell software.
Oh, license software.
Yes, yes, yes.
Okay, okay.
Yeah, you know the Step 7 professional version, but always new version. 20, yeah. It can program for 1002, 1005, 300, 400. Okay, SIMATIC basic panels. Okay, basic panels, and another one called unified panels. Here don't have. Okay, so it's come with a 3 DVD and 1 USB. Okay,
Okay.
it's around 12,000.
That is for if the person want to do a official project,
Projects.
must use an official license.
License. Why? Because you will get the certificate, license certificate. And license key in the pen drive. So they call it a flow drive. The software they will give you the CD. The CD can install multiple laptop, no problem. But only one license. If you want to use, you connect the USB, you can use.
But you must always have the USB.
So it's optional. The USB you connect, you can transfer the license into your laptop also. Okay.
Oh.
Then you can straight away you can use the laptop.
Got it. Okay. Yeah.
Okay. If you buy WinCC Advanced, then you will get comfort panels.
Okay.
Then runtime also there. You will have a runtime.
This is the runtime.
Yes, runtime. Can you see runtime application? The SCADA. Yeah. So you will get until runtime advanced only. If you buy WinCC Professional, then only runtime professional. This is the SCADA.
Okay.
Yes.
This is the one on the server.
Then you have a WinCC client. So many licenses.
Okay.
So many licenses. When you want to work with OPC, then the professional also they will come with depend on how many tags you are using. How many variables you are using in the SCADA.
Variable.
Yes.
Okay.
How many they call number of tags.
Okay.
So 1,000 tags, 2,000, 4,000, 8,000, 16,000, 32,000. And the highest one is 65,000.
Okay. Got it.
So depend each one they have different pricings. Means number of tags means number of IO you want to show in the achievement.
What is the relationship between Siemens, WinCC and everything? And Aviva.
Yeah, Aviva is a software also. I mean it's a SCADA software also.
It's a totally separate. It's not nothing to do with WinCC.
No, WinCC is a Siemens SCADA.
Siemens.
Aviva is not mistaken under Schneider. Last time they called SIMATIC. Last time they called SIMATIC.
Oh.
Now they call Aviva. Aviva also they have two types. One is Aviva something, another one is Aviva H.
Compatible. Let's say I use PLC, I use Siemens, everything.
SCADA can compatible to any PLCs. But there's a different many type of SCADA softwares. Wonderware,
Yeah, one
like you said, Aviva. Last time they called SIMATIC.
So actually not necessarily because I use a Siemens, I have to use a WinCC. I can
Not
use.
necessarily you can use because if you ask me WinCC expensive compared to Aviva.
Oh, Aviva cheaper.
Yeah, Aviva considered cheaper lah.
Got it. But the configuration is a little bit challenging lah. Then
Yeah, similar thing.
Similar thing.
But this one is direct because it's in the same project. So direct, just pick. You put one button, just pick from the PLC. Okay, what is the tag? Just pick only.
Oh,
If I want to use Aviva
yeah.
from the Siemens from this project, I need to export all the tags first. Then in the Aviva, I need to import first.
When you say export and import, what file is that?
Normally it's a CSV files.
CSV file. It's a list of tags and then a list of type and so on and so
Yes.
on. Okay, got it. Yeah.
So many things. Actually, if you ask me to teach Siemens, complete, I can teach you for 5 days. I mean, 10 days also I can teach you. So many things to do. But advanced, after day 5, I is considered advanced. I mean, it's not like advanced. You can separate into branches. You know,
Good.
one advanced is VFD control. Another advanced is Modbus. Another advanced. So normally I only teach VFD control. So those who request for Modbus, then only I teach them Modbus. Those who request for data logging, then I only teach data logging.
There can be a lot of things about the
Yeah.
bus also.
Yes. Because Modbus is Actually, one day you have to learn Modbus. But before that, you need to understand PLC, Siemens basics first.
Right.
So because Modbus is a different protocols, so you need to use the Modbus programming or that.
Okay, yeah.
So I say, Siemens, if you ask me to teach, I can teach for 10 days. I do a lot of things, I do a lot of projects, I do a lot of trainings on Siemens, that's why. If other brands, I have limited hardware, so I can do like 10 or 7 days a weekend. Other than that, yeah, because I don't have the hardware to teach. Siemens, I have the VFT, the HMI, everything like complete set. And,
So you can have everything together.
yeah.
Okay.
Okay?
Yeah.
For the drive, so you need to install separately the software. It's not come with the TI portal.
Okay.
So the drive you need to install the start drive software separately. But this start drive also only for SIMATIC only. If other one they have SIMO code, SIMO word, there's a few types. So all that have their different softwares. You need to install, then only it will come out like add-ons, software add-ons. Then only it come out like this here.
So you say this drive normally where to get these files here? Where to get this drive?
This drive the software.
Yeah, the software here.
Siemens website you know.
Oh, it's a free anyone or today I'm configuring that drive probably. Then I go to look for that model, go online. Maybe tomorrow I'm looking for another brand again. Then I go to another brand website, download the drive.
Yes, but if you download another brand, it won't come here.
Oh, okay.
It will become another software. So there itself you can do the parameter settings.
Okay. This one is a
Siemens.
Is a configuration for the Siemens. All the RAM speed or whatever.
Yes.
Okay, got it.
Okay. Okay, go back to the controller. Okay, go to 1002. CPU. So we have so many CPUs. Have you heard about safety PLC?
Is it this SIS thing? Or
Yeah.
Oh.
They have SI something.
never touched, never see before.
Okay.
Yeah.
So the CPU, this is normal CPU, this is a
Right.
safety PLCs. Because safety PLC, they have a safety instruction inside.
Okay.
But I never done programming on safety lah. But for safety, if you want to do safety programming, then
What is the difference between a safety PLC and
normal PLC, okay, normal lah. Okay. Safety PLC, they have safety features. Okay.
like everything inside is hardwired, not to say hardwired. Okay.
So safety PLC, same thing, same like normal one. Okay, is normally they use in where safety is is involved. Like you use in
Oil, gas, this
oil
kind of
and
things,
gas,
yeah.
all that, because they have some function called safety functions. So if you use a safety relay, then you can directly communicate, then directly can program. So they have some safety functions. But the same thing, normal PLC is both the same program.
Actually, it's the same hardware.
Same hardware. Only the inside will have a yellow color at the side. The
Oh,
safety
you can
PLC.
see from the
Yeah,
appearance.
visibly you can see.
Okay.
Yes, they have safety programming.
Never use, never touch this.
No, I also never touch.
Yeah.
Never touch. So I've seen only once. One company I do troubleshoot. I do here, but there's another system they use safety PLC. I just see only, I never touch it. But I know the safety PLC they have safety block, one block for safety programmers. But I'm not sure what type of programming can do.
Okay.
So yours is 1214 DC, right?
Yes.
Okay, open. No, open here.
Oh, open.
Yes. Then 3 part number. Yours is the last one. You can see that. But just click on it. Don't double click.
Oh, okay, just click on it.
Yes.
This is a 0xp0. Wait for everything. Yeah, so 40. Okay.
Okay, yours is version 4.2. Remember just now when you upload PC 4.2 and TI portal version 18?
Yes.
Yes.
This
So what is the
software
difference?
version.
You can see here, 4.2 is the 100 KB, right? Both memory is 100 KB, got 14 input, 10 output, 2 analog input, 6 high speed counter, 4 pulse output, 3 communication module, 8 signal modules. Then Profinet interface for programming, HMI and PLC to PLC communications. Okay?
Okay.
Go to, you click 4.6, see what's the difference. Same thing, the work memory become higher, bigger, under 50 KB. Okay. Then the next is okay. Profinet IO controller, iDevice, transport protocol, TCP/IP, secure open user communication. So the user communication now you can use secure or normal. Secure communication means you can just simply use your laptop to communicate. You can simply use a third-party brand to communicate to Profinet. So only Siemens to Siemens only can communicate. Okay. So web server and OPC. Actually OPC inside the 4.2, so they are. But you need to choose 4.2. Then
Because the
only
firmware inside is 4.2.
yes, because that the firmware you can download. If you choose 4.6, it will tell you you choose 4.6, but your PLC is 4.2. You cannot download it.
Okay.
That one also because of TI portal.
Okay.
TI portal version 18 until 4.6 only.
Okay.
TI portal version 20 until 4.7.
Okay. So firmware also subject to which
So every time they release a new TI portal, they upgrade the firmware. So inside
you have
the
the option to further upgrade the firmware
yes,
if you want.
if you want, yes.
Okay.
Because you see, this one panel, a small panel, I use this. I mean, this is a project for UTM. So they do some monitoring system. So I use a same 1002 1212. The firmware is 4.7, but the software I use TI portal 18, 18 until 4.6 only. Still can download.
Oh, still.
Still can download, but it will give you like warning light. It will tell you selected 4.6, but actual is 4.7. Still can work, but I like 4.7 give me like new features lah, but I'm not going to use them. So I just stick with version 18. If no, I can use version 20 to program them.
Possible. So
Yes, yes.
18. So you use older TIA also.
Yeah, older TIA also can.
Okay.
Okay. Now, this is the device configuration. Okay. So on the left hand side, can you see got some modules can add? On the right hand side, can add some modules.
Yes.
Okay. Okay. You close this one first. Click. Yeah. Okay. So on the left hand side is a communication modules. You click here. Yes. Okay. Can you see industrial remote communication?
Yes.
Yeah. So is they have LTE, DLP3, all Ethernet. So can use like a modem lah. So remotely access, remotely transfer somewhere data. You can use this.
A small question. Quick one. Any possibility to add a module that has a wireless function?
Yeah, that's the thing.
Oh, which one?
This one.
All these also?
Mm.
Also, if you say wireless, meaning to say after configuration, say this is a monitoring of temperature lah. So I can configure somewhere else with a receiver on the wireless.
Yes.
And to have a real-time data of
Yes,
the
yes.
temperature
Yes.
without any
Any cable.
Okay.
That's the distance.
Okay, got it. Yeah.
Can close just remote. Profibus So now this PLC don't have Profibus. So let's say my drives they using Profibus. So I want to use, so I can add one module.
With a Profibus.
Yes.
Okay.
Profibus connect with
Okay.
the connector. Okay, you can just click one of these. Open. You just click on it. Can you see? It shows I only can do here. I cannot put in here.
Okay.
Okay?
Yes.
Off this one, Profibus off. Okay, point to point interface. Can you see RS232, RS485, RS422? Okay? Okay. RS232. If I'm using, it's the same thing like Profibus, 9 pin only, but it's not Profibus protocol, it's the RS232 protocol. RS232 is like a common protocol. Let's say I'm using Omron HMI. Like Omron HMI, let's say don't have Ethernet port, they only have RS232.
RS232 is this printer board?
No, it's a 9 pin.
9 pin.
9 pin similar to the Profibus.
Oh, okay.
So if I want to connect to this PLC, so let's say that my HMI don't have Ethernet port, so I can use this. And add this one, RS232. For example, let's say this one. I want to use this WinTech HMI, for example, as a China model. So let's say this one don't have Ethernet port, only have RS232. Can you see here? I can use RS232 or RS485.
Yes.
So I want to talk to the PLC, I want to monitor this, but that PLC don't have this port.
Okay.
So I add here.
Have to add another port.
Yes, another port, then only from here to there I can connect.
Got it.
Yes.
Normally.
If I have Ethernet, then I can use Ethernet, no problem.
Okay, got it. Yeah.
Okay. Then same for RS485 also. RS485 is actually you can use for Modbus.
Oh.
Okay, because Modbus got two types. One is TCP/IP, which is using Ethernet.
Sorry, actually I'm not familiar with this port. 485 and 232
What's the difference?
yeah. One is a more pin, one is a shorter, one
No,
is
no,
a
no.
less pin.
Both are 9 pin only.
Both are 9 pin also.
Yeah, both 9 pin.
So when you say RS232 and RS485, actually what's the difference here?
Okay, what's the difference between these two first? RS232 is one-to-one communication. Means one PLC, one HMI, that's all.
Okay, two devices only
Two
between.
devices. 485 is one-to-multiple communication.
Okay.
Similar to Profibus.
Also, you can
Yes.
chain it, jump it multiple.
So, similar to Profibus. Actually, Profibus, they're using this 485 protocol.
Oh, actually, Profibus is very similar to
It's actually 485. They use the 485 protocol. They just do some modification. Make sure this can communicate to Siemens PLCs. They name it as a Profibus.
232 is very much, to be honest, very much like the PC 232 in the old days.
Yeah, PC, our US. This one are 232. This one, right? All 232 only.
Okay.
So it's one-to-one communication. Just connect the HMI or just connect
One-to-one.
one VFD. That's all.
Okay. Now I'm clear with this. Okay.
Yes. So 485 can do Modbus also, because Modbus got two types. One is TCP, which is using Ethernet port. One is called RTU, which is using 485 protocol. Okay.
One is called Modbus has two types. You say one is called not the normal TCP which is using the
Ethernet port, yes.
And then if they use this RS
485
port, that is called
RTU, yes.
Or RTU meaning is Modbus.
Modbus RTU means you're using 485 protocol.
Oh, that is a meaning. Because I always see people say RTU. I don't know exactly what RTU meaning.
No, RTU is the remote
Terminal unit.
unit.
Yeah, but is it essentially
It's
means
because they're using 485 protocol.
because they're using 485 protocol. It's a 485 Modbus.
Yes.
That's called RTU.
Yes. If Ethernet Modbus, they call it TCP/IP.
Okay, got it.
Okay.
Yeah.
Click here. Okay, go down. I'll show you what is the interface. Is a AS specification. We call what do you call AS ASI interface.
Or industrial remote. Actually, this one is all wireless here. Just now you say, the Ethernet extension is
Internet extension.
let's say I have a few BSB and then I connect with
Ethernet.
Ethernet.
Additional Ethernet port.
yeah,
Can. Under the industrial remote communication.
or under here also.
Yes. So you can use this one. CP114. Yeah. Yes, on Ethernet port.
But
This
this
is
is
only
only
sending email. So SCM I will just sending email. Once I receive the report, I will send.
Yeah.
this is only extend for one port.
One port lah. I think only at one port only.
Oh.
Two port or like that.
Or if there's let's say like a swing really like one PLC, you have to control 10 pumps together, 10 50. Essentially, it means that you need a switch outside.
Yeah, of course.
Oh, okay, okay.
That's why they have Siemens. They have their own switch. Solens.
Solens. Okay.
They have a eight port switch. They have a 4 port or 8 port switch.
Normally the switch are also together in the PLC panel.
No need. The solid switch is just it's like an external unit. Just a module only. It's a DIN rail track. Just put the DIN rail. They have a 8 port switch.
On the DIN rail.
Yes. So no need to attach to the PLC only.
Okay. Got
It's
it.
just a switch only, right? But it's a Siemens lah, that's the thing.
Oh, okay. Got it.
Okay, so okay. That's about communication modules.
Okay. And just like you
Yeah,
said,
AS interface is like like a special communication direct to your actuator sensor. So some actuators, okay, is like a I/O, right? Like a hard wire, okay, hard wire. So they will have like 24-volt hard wires. Some actuator they have like a I/O link. They don't have the modules. It's like a round thing.
you mean this is the I/O link?
Yeah, I/O link. Yes,
this
yes,
is
yes.
AS is for the I/O
Yes,
link.
yes.
Oh, okay. So
It's
it's
a
a
round
round
pin.
round pin.
Round pin, yes.
Oh, okay. AS is for the I/O. The
Yes.
I/O link.
I/O
Okay.
link, yes.
Yeah, this one. Yeah.
Because some sensors is like a bit smart sensors, right?
Right.
Some sensors just on off only, so it's a direct wiring. This sensor got some smart
It's a
data.
very advanced one.
Advanced, yes.
Yeah.
Okay, and close these communication modules. Okay. Now, CPU, okay, additional CPUs lah. Okay. Can you see boards? Boards. These 3 boards is you want to add in the center.
Okay.
Okay.
Just
Just now
show
you try
board
the board.
here. Okay.
Okay. So in the board also they have a signal board. Signal means the I/O lah. The IDO.
Okay.
Communication board they have for like RS232 only. Or RS485. I think 485. Yeah.
Okay.
So RS485 you can add at the side also can, in the middle also can.
Got it. Okay.
And then there's another one is a battery board. One additional battery you can use this.
What is the function of the
Battery.
Yeah.
Battery normally to protect memory. The program.
In the case of power failure.
Yeah, power failure. But actually this PLC is not battery because it's using memory card type. Okay, but still you want to use the battery if the power loss or you want somehow reset the PLC, you want to keep the value, you can use the battery board.
Then what is the point of adding the additional battery here? I mean this battery board here.
Yeah,
Oh,
Next
But
one.
this one has no battery.
No battery.
Oh, okay.
Want to add additional.
Okay.
Okay. So the board all is in the center.
Okay.
Okay. Then start from DI, DO, everything on the right hand side.
Okay.
Okay. So just add one DI. ADI or something like that. Just click and add.
Oh, this one.
Any one of these. Can you see only here, right? You just double click, it will go here. Or you want to specifically put one plot, then you can put lah. Okay?
Okay.
You add one DO. Okay. Then you add one AO. And close the DI, DO, close. AO.
This is in and out.
It's a combination type, yes. AI, okay. Let's say AI, yes.
Question.
It
This
puts
hard
what?
communication.
What's it?
Hard
Oh,
communication.
HRD, yes.
Yeah. It have a specific model that can support only, not all can support.
Not all can support specific model.
So, but from here,
Here, I think
you cannot tell. But I mean, you have to go to the website to search where is the model, and
Yes.
then you can decide
Yes.
which one is the supporting line.
Yeah, but this one is a normal analog for 20 or 0 to 10. This one RTD is for the PT100 or PT500. Directly can connect. No need transmitter.
Oh, okay. So it's a so you mean it's a how to say no need transmitter. So the element
Directly, your probe directly can connect to this input.
Okay.
If you're using this one, the probe go to the transmitter, first need to transmit the data, right?
Right. That one
Yes.
Actually, that one
Yeah.
inside has a transmitter already.
Yes.
Okay.
So transmit convert to the analog value.
Okay.
420 or 0, mostly 420 lah.
But TC also.
TC is thermocouple direct.
But normally they do this
Hmm?
your signal will not be accurate, right? Because your signal wire is too long already. I mean that's what I know lah. This
Yeah,
one-
of course.
Yeah.
Because
So I'm wondering is there any advantage of people really using this or not?
but you can use because I know it's too long, right?
Yeah. Too long and then you have a signal loss or whatever, then your resistance is not correct already.
Not correct. Yeah, maybe you can use a repeater. But for this, I don't know how to use the repeater.
But anyhow, then I'm just curious on it.
Yeah.
I know that okay, there is a not necessarily you
Yeah.
only receive a 4 to 20, you can receive this
Directly
kind of,
temperature, but only for temperature lah.
only for temperature. Okay.
Because other than that, it's already built-in transmitters.
Okay, got it. Yeah.
Okay. Then you add
Okay.
one AI, any AI for AI. Okay. Then AO.
Got it.
Alright. Now you already add everything. Okay. Now we see the I/O. How the I/O works. Okay. Open this. Make it bigger. This one. Some more bigger. I want to see I address, Q address. Okay. So DI14, DQ10, right? So this is the addresses here you have. So this is the built-in lah, right? 14 input, 10 output, 2 analog input, right?
This is the PLC model.
This is the PLC built-in IOs. Okay. This is the one you additionally will add below here. DI8, DQ8, AI4, AQ4.
Okay.
Okay. Now we see how to read these values.
Yeah.
This is the most important. So that's why, because in this project we are not doing any programming. We just do configuration.
Okay.
Just say later on in the same project we add 1500 one. So we can see what's the difference between 1200 and 1500 one. Okay. So DI14. Okay. Now, what is the I address? 0, 1, right?
Mm.
Okay. This 0 and 1, what is the meaning? What number is represent actually?
The variable length, is it?
Yeah, the variable length is actually your input. You see your input is a DI, A and B, right? Correct.
Yes.
The 0 is A, the B is 1.
Oh, okay, that is the meaning.
Yes.
So you mean by default, I0.0?
It's always start with 0 lah. Actually, you can change it.
Okay.
Double click. You just put 5. Double click. Delete. Put 5.
Oh, I can change.
Enter.
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 Oh, I can. So here is where I rename the A and B.
Yeah, the byte number. This one is the byte number.
Byte number.
So that's why in the hardware they just put A and B. They didn't mention what's the number. Because why? It's a changeable. The number is configurable.
Question.
Yes.
And you know, when I read the wiring diagram,
Yes.
they always have a name it all the IO card. They always
Yes.
have a given a name, right?
Yes,
In the wiring
yes.
diagram.
Yes.
Is this wiring diagram name also reflected inside the program? Or no?
Yeah.
Yes also.
Yes.
Oh, because I see here, I don't see any like a special name for the.
No, they don't put special names. Where is the name? You go here. Maybe you can close this. Then you can open. Can you see this is the name?
Oh, here is where you can.
Yeah,
correctly.
rename. But this one I don't care about the names lah.
Oh, okay, okay.
So from the wiring diagram, because I can see like this, right?
Yes.
Then I know already which slot, number 1, 2, 3, 4, or the PLC one. Then in the same time, in the wiring diagram, how it looks. But normally I will use E-plan lah, okay? So they will put like this. Input I0.0 in from where? Okay, they will switch one. That is in the wiring diagram. Alright.
Yes. Yes.
They will put a terminal block here lah.
Yes, and a terminal
So
block.
this is your field device. Go to your terminal block. From the terminal block, go to your input.
Right.
Yes. So the I0.0 from where you get. So what happened is, so of course lah, you will have multiple, right? All the input here, correct or not?
Yes.
I0.1, I0.1. So in the previous page, they will put like this. Okay, CPU, DI.
Yeah, this one page is dedicated for this.
Yes, DI. Sorry.
So because let's say multiple, I mean, definitely I'm not a control
Electrical
guy.
guys, okay.
Yeah, but imagine this doing troubleshooting or doing field
Testing,
testing,
yes.
input check and so on. They refer to the wiring diagram, right?
Yes.
And the wiring diagram normally have the, I don't know, it's a
Diagram.
called the loop diagram also.
Yes.
Like every single loop, this loop is coming up from this IO card
Yes.
until the device and loop back.
Yes.
This is, so they have to refer to this to know exactly tag for this one actually is from which card, what number,
Yes.
and so on and so
Yes.
on. Because on the panel itself, you open the panel, you read the setting inside. If somebody,
The same number, the
Yeah.
tagging,
if somebody terminate wrongly, you immediately can tell, oh, because this is different to the wiring diagram.
Yes.
So just wondering, how people name, for example, name the termination block and name the IO.
Name the IO is simple.
module.
Yeah, I give you one example. AI4, this is AQ4, right? So normally what they do, whenever I do projects, because I do control panels also, last time I did lah, but now only less. This one also the lecturer request, that's why I do. Before COVID I do a lot, because that time my boss do training, so I do a lot of control panels, wiring, everything. So the wiring diagram done by a German guy.
Okay.
Because like he said, my boss partner is a German guy, right? So he have a company in Singapore,
Okay.
same name. He do projects. So whenever he do projects, the panel, we do the panel. Panel. So he will give us the wiring diagram. So we read the wiring diagram. From the according to wiring diagram, we order all the parts, everything. Do the wiring, everything. Then we do Once done, then only we send. So before when we do wiring diagram, of course I need to follow the wiring diagram. Right? So normally what they do is, so like they put in PLC 01. Okay.
Okay. This is a tag name for the PLC.
PLC.
Okay.
So or sometime what happen, they will put like A 100 for example. Then this one is A101, A102, A103, A104. Or you can they just put DI1, DI2, DI1, DQ1, AI1, AQ1.
Okay. So this is the name given by the engineering team.
Yeah,
Okay. They name it. Okay. This PLC one, DI cut one is A01,
A01 or just put DI1, DQ1. Let's say I have 3 input cut. So
Okay.
DI1, DI2, DI3.
Okay. That is one show in the wiring diagram.
In the wiring diagram, this is one page. There's another page that is specifically go to your inputs.
Right.
In this page, here they will put PLC1. So I know this IO is from the PLC. Okay? Or in the wiring diagram at the back at the middle lah, they will put. Okay. Let's say this is another page that is 5.2. This one from where? The A101. They will put. This one is from the A101 model.
You know the next question I think is a very important one.
Yes.
That is what people has to put on the wire marker.
What number?
Yeah. What has to be written on the wire marker actually?
The wire marker. Okay. Is depend. Some panel the wire marker they will put this address.
Address
In this address lah I5.2.
So like A1.
No, they don't put A1, just put I5.2.
Okay.
Ah.
Because it's from the one panel.
Yeah. So
Yeah.
we go to the I5.2. Right?
I5.2. Because one panel only has one I5.2.
Yes. Okay.
Okay.
Of course one only. Right? Or sometimes this cable, this is terminal block. Of course the terminal block they will put what number X1. This terminal block number 1 for example.
Right.
So, terminal block, the front, this is the terminal marker, right? The block marker lah. And this is a terminal block. On terminal block, you will put the number.
Okay. Because the one terminal block has like I don't know 1 to 16 something like this.
Depends on how many terminal blocks you want to use. At least like for example, you can see here. Check it. That's the number, right? Okay. But this one I haven't put the terminal marker yet. Okay. But because why I'm not using the number. Means I'm not using this one. I will use number 1, 2, 3, 4, 5 there. Okay. So I will put number 2 here, for example. So what happened? From the PLC to here, I will take the terminal marker number 2 and put 1 here, 1 here.
So this wire marker, is there a standard? There is no standard like everyone follow.
Yes, not standard because this number 2, right? If you're using E-plan, it automatically they give you number E-plan software.
E-plan is
Yes,
a
electrical wiring.
program to do
Yes.
electrical wiring.
Yes. If you do AutoCAD, then you need to do manually.
Oh, okay. But a standard practice is whatever.
The number or the address lah.
I mean, is it a standard practice is any termination here must have wire marker on both sides.
Must have.
Must have.
Then only when you do wiring also can. Troubleshooting also will be, then only you know from where to where you want to take. If no, it's very difficult.
Right.
Okay, like this lah, you see, I just mark it as a PLC one and
Yeah.
when like so in the wiring diagram for this page I use the same name.
Okay.
Then so whenever each, because this one I haven't done the wiring diagram. So for this one, okay, this terminal.
Yes.
0 plus 0 plus 1 lah. So like this, right? Then in the page I will put this name and
Okay.
one. So anything is not working, it just open so they know already which kind.
Okay,
So
got it.
I just mark AIDIDO everything.
This is your terminal block name lah.
Yeah, but this one is for like university, so just use the normal name. I didn't use the actual name.
Right,
Yeah, because industrial name you can put AI, you must put X.
Oh,
For terminal blocks they must use X.
terminal always use X.
X, yes. Then MCB you must use F. Relay you must use K.
Oh, that is a standard.
Yes.
I know K is always for the contactor, right?
Relay or contactor can
Yeah.
use K.
Okay. Okay, got it. Yes.
Then regarding the PLC the wiring diagram lah, especially the PLC wiring diagrams, not the 3-phase or that. Mine normally I do wiring diagram from the PLC to the relay contactors all that. Any question you can ask me because I have done around 20 plus panels last time.
Is this wiring designing the panel is part of the automation engineer job? Or no?
No, not.
Normally
It's part of the automation team lah, but not the programmer job.
Or not a programmer job?
Yes, programmer actually myself. Here I do program, I do the wiring, I do the funding diagram because I do small thing lah. But if you see a bigger company they do programming. Programming one. That one also PLC programmer is different, HMI programmer different, SCADA is different. If we talk about bigger programs,
Then who is the one responsible to design the panel?
there's electrical team will do the design.
Electrical team.
Yes.
But electrical they have the knowledge of instrumentation and control. I mean, do they have? Or?
If they have, then it's okay lah. But for them, no need. Because for them also, they will tell you how many I/O. So from there they will know. Okay, what then they will communicate with the PLC programmer. Okay, what are the PLC you're using?
Oh, it's sort of like he asks you what is the model of PLC?
What a model?
What module?
What module, everything. So the PLC guy who designed the PLC everything, he need to give this data to the wiring diagram who designed the wiring.
Oh,
Because
so you feed the information to him.
Yes.
He designed it.
yes, so the wiring diagram guy, because the PLC, this Siemens PLC all in the E-Plan AutoCAD, you can see the exactly same thing. They can download from their website. So they just download, fill in all this, they just design all this. Once they design all these, they will get all this ready. Automatic. So all the inputs, output. And also the programmer need to tell them what is the I/O you are to use because they need to modify here.
Question. So just like you say, let's say today we open it up, we develop a program here.
Yes.
Essentially, I can export it, convert to the.
No, you cannot export this one.
Cannot. Or it still have to somebody.
Yes, so you
one
need
by
to tell
one.
them, okay, this is the part numbers I'm using.
Okay. Somebody have to do a manual transfer here lah.
Yes, so you need to tell them the part number. So what happened, of course, if they doing projects for Siemens, of course, in their AutoCAD or E-Plan, they already have all the Siemens parts. They just drag and drop.
Got it. Okay, clear.
Drag and drop because in the software itself, they will have, you can design the panel, everything. They will give you the size, the trunking size, everything. MCB also, you can put the Schneider.
Everything is automatic.
Everything is, you can download the library, inside the library they have. So, let's say I'm using Schneider, let's say C6 for example, 6M1. So you give the part number to him. They will put, because why the part number is important? Because of course because electrical designing is one guy. Who give instruction what are the parts using is another guy. You need to give the correct information to him. Then only once this one done, then only when who build the panel, they will buy the correct part according to your wiring diagram.
Yes.
If you do mistake in wiring diagram, then my parts also mistake.
Okay.
Let's say for you tell them I need a power supply 5 amps, but you didn't mention properly. He designed 2 amps. So when I build a panel 2 amps, then when I do testing, I say why 2 amps is supposed to be 5 amps.
One more question.
Yes.
This wiring diagram
This one you have IO here. I assume like one page you have the master.
One page this
PLC.
one page this one page this one.
Yeah. Yeah, if there's less lah. Like
Yeah,
if you
yeah.
have a lot of IO, then you have a lot of pages lah.
Yes, of course.
Then normally your scope is what? I mean, what do you show here? Because let's say you have a lot of control bar, you have a lot of transmitter, 3 wire, 4 wire, whatever.
Yeah.
Then you have a lot of stuff here. Usually a project, instrumentation, tech name is all well defined already.
Yes.
So when you're doing this, you exactly know that you're designing this, you exactly know that this AO is going to TT101.
Yeah.
This one is receiving from control bar CD101
Yes.
whatever.
Yes.
So down here you have a CD101, you have TT101 and so on and so on. You will include that at the bottom here as well.
Yes.
The instrumentation, how the instrument is terminated.
Yes.
And one is the earth and one is what.
Yes, because inside in the instrumentation also there's a terminals.
Right.
The terminals also have numbers.
Right.
What number, what the
But you will include that also,
Yes.
that information.
Yes.
So when the people, the site guy, the site team do the installation,
So they don't do any
refer
mistakes.
one diagram, which is your wiring diagram. only.
Yes.
So when they install a TT, then they see, oh, this termination, this wire, this
Yes,
wire.
from these terminal blocks, for example.
From here only. Okay.
So from here only, because I have to, let's say this is, so this one is, let's say the analog input A103 for example input, the address will be IW because it's an analog.
Okay.
Okay, so I don't know what number, let's say I put 50.
Okay.
So they will put like this, go to one terminal block, right?
Okay.
Then they will put it here for 20 million. So for programmer, you know, okay, I need to configure this for 20 million.
Okay. This is A103 and this is address is 50.
50. So
Okay.
which one? Then they will put the number here. What number? The terminal number, right? Because the terminal have number, what? 0 and 0. This or something like that. Yeah.
Terminal has number.
And this terminal numbers 1, 2, 3, 4, 5 the number.
Oh, but why is it then 0 and 0?
0 plus 0 negative. Okay. Is it there in the analog part?
I'm trying to look for.
No, they don't.
Yeah.
2 and 2. That one. Can you see that?
Don't know how to do that.
Oh, they just put number only 1, 2, 3, 4, 5. Here, this one. Here it is. Yeah.
Okay.
Can you see? 2M and 2 is for one signal. This one failure. 3M to 3. Or you can see that one is just 1, 1, 2. You can see 0 plus 0 minus. 1 plus 1 minus.
Okay, got it.
Okay. So it's like 0 plus 0 minus. 1 is plus minus.
0 minus. Okay,
0
okay.
plus 0 minus. So
Yes.
you know positive, negative, right?
Yes.
Then this is terminal blocks. X, 10, number 10 and 11, for example. Okay. So this is X10 is the group, the group marker. The 10, 11, the particular input.
And the termination block.
Yes.
Okay, got it.
This one will go to your
The question about termination block.
yes.
Is it common or compulsory to use a fuse?
Fuse. Okay. I will come to fuse. Wait.
Okay.
I will tell you. Okay. Now this one is TT1 for example.
Okay.
So TT1 will have a terminal number also, right?
Yes.
Okay.
Yes.
For example, 1, 2. That is
Probably they name it like whatever plus minus.
plus minus or 1, 2
Yeah.
lah. Okay. That
Yeah.
is okay. So
Yes. Okay.
so like this only. So when they do wiring guide will do connect this one. So in the wiring guide, what happened? In the wiring diagram, here they put the cable marker.
Yes.
Cable marker. Okay. So this is IW50. So they will put IW50 plus IW50 minus. Okay. Or number, any number, according to depend on the implant number lah. What number it give you. So
Okay.
means
Either it's an automatic generate from the E-plan or
Yes, E-plan, automatic generate from the E-plan. So what happened? I will connect one cable here, one cable terminal block, right? Here also must put 20, here also put 20. Here 21, 21. I have no idea.
But if you put a very simple, just like the number is 0 to 1000, this kind of thing, people very difficult to troubleshoot, right? He opens
Because
the panel, he look at all this one.
Numbers, so you must have the wiring diagram.
You must always, then he must always go to open all
Yes,
this.
because then only you know. If you put like this, terminal marker just put 5.2, so it is easier to them to understand. 5.2. So if somebody take out already, I know, oh, I 5.2 is the input. So easy to connect.
I got your point. Okay. Okay, yeah.
Now, what happened? From here to here, sometimes you won't have the terminal cable marker.
Don't have
Sometimes I've seen.
okay.
Or
That is the most challenging part.
most challenging part because it's from the outside. Sometimes it come in multi-core.
Yes.
Right, multi-core. So what happened? This is where they play. When they use multi-core, right? In the multi-core, each cable has number 1, 2, 3, 4, 5.
Yes.
So they will put it here. What is the number? 1, 2. The cable number.
You really bring up a very good point that
Yes.
I always face problem. This multi-core, how
Yeah.
to do a proper tagging and so on.
Okay. Then multi-core. Then for this also you must put. If you want a proper tagging, when you want to connect to this side, right? You put this address.
I mean, do you mind? I
Can.
ask, I don't know. Because says for instance, this is a TT.
Yeah.
I'm not a control guy, but I assume sometimes they definitely they will not use two different wire, right? They use, this is actually it's the same multi-core.
Yeah, same inside same multi-core.
And then what is an industrial practice, good practice to tag it? You only tag this one or you tag the wire or how?
No, take the wire. Each wire you want because this is inside the panel. This is outside the panel. Right. So once you come inside the panel, better to do the tagging.
So the tagging is here.
Yes.
And the
This side also you must put the tagging.
edge here also.
Yes.
The multi-core,
Multi-core also they will put some tagging, some number. Let's say 105, for example.
Okay.
So because this 105 multi-core, let's say inside there I have 10 core, right? So each TT1 only use 2. So the 10 core can use 5 TT1 IO data.
Also, you mean the multi-core, not necessarily one instrument, one multi-core. It can like a group of 10 instruments together also.
Can.
Can do like that also.
Can. Why you want to waste one by one?
Right. But in that sense, how you say? You weren't sure because actually I've not seen so big a multi-core can be like supporting a few instrument.
Oh, I do a lot of them.
Okay.
Because sometimes from that panel to this panel, all the sensors all go to that panel. From that panel, I need to carry right. Let's say I have 5 instruments, I don't need to bring 5 cables, small cables.
I want to know. No, I want to ask. It's a little bit more less programming, but more engineering already.
Yeah.
Because you say you do iron diagram this people install based on this something.
Yeah.
But he read here, he cannot tell that actually you want to have this form using the same multi-core. I cannot tell to be honest. Where do you find this information? If you want to tell him that this core is sharing one multi-core, you should have a loop diagram that has this
Yeah, of course.
or it will be presented, it will be
Yes.
included in the wire diagram.
Because this is I
okay.
put different pages. Let's say I put another input, same input.
Then you will
Yes.
circumvent something like this.
Yes. So
Oh.
then only you can understand this one IW52. So this is another TT, right?
Yeah,
Okay.
let's say there's 2 TT here. Okay.
So this is the cable number 1, 2. This is cable number 3, 4.
Okay.
And this is a cable number 1. The terminal number is still same.
Okay.
This one is a 1 plus, 1 minus. So 20, 21, 22, 23.
Okay. This is
Then
okay.
this one is a 12, 13. So when this one will be 4. The whole thing. have 5 set and I have 5 set.
And then in your schedule, cable schedule, then you will write this tag number, whatever. 1 and 2 is red and blue, and then 3 and 4 is brown and black.
Brown, black, or sometimes in different colors, sometimes same color, but in the cable have marking 1, 2, 3, 4, 5. Sometimes in black color lah, this black color, but in the cable they have a marking 1, 2, 3, 4, 5. So it's easier to do the wiring.
So, and in the wiring diagram, you have to tell that this cable, what is the name of this cable?
Yes, then only they can trace.
And it will be tagged at the cable as well.
Yes, at the cable also you need to do the tagging. That's a proper one lah. Because I said, this one is a temperature for
Good point.
yeah, let's say the tank 1 temperature lah. Okay. So let's say in the SCADA, you can see the temperature, tank 1 temperature. Okay. So you open up your wiring diagram. You see IW50, right? Okay, IW50, this point, this is the one WK. Just go and check. 420 here or not, don't have. Okay? You go and check here. Here you have 420. Here is okay, your DT1 is okay. But here is not working. So means in between the cable is something. Nothing. So how to identify? So you open up wiring diagram, they say you are using multi-core cable. This is the number, cable number is C150, example. So you open C150 and see cable number 1 and 2. So you check at the point 1 and 2 got value or not got value. You go and check here, don't have the value. So in between something happened.
Okay. Yeah. Thank you.
Okay, good.
Good, yeah.
Okay. Now, shall I erase this?
Yeah, sure.
Okay. So because you have all this experience, right? So that's why you can, can relate, can do some imaging.
Yeah. Have the experience, but have the missing gap lah.
Yeah, because you have seen this,
yeah.
but you never really involved hands-on.
Right.
Always you will have some doubt. Okay, why they use like this? Why they use like this? Yeah, same thing.
Yeah.
Okay. Now you open this. So this is my IO1. Just now you change to 5 and 6 type.
Okay.
So if I put 5 and 6, very simple. In the program I want to use, I must use I5.6. Let's say the first one is a start button. I need to use 5.6. Sorry, 5.0.
Oh, 5.0. Okay.
5.0.
Okay.
Okay. So if I put 0.0, then I must use in the program must be 0.
Okay.
So you change to 0.0.
Here.
Just put 0 in it automatically change. Okay. So now, so your DI is 0 until 1, right? So it means you have 14 inputs. So I 0.0 until I 0.78, right?
Yes.
Then I 1.0 until I 1.5. 6, correct? Okay. So total 14 lah. But we know inside 1 by I have until 7.
Yes.
Right. So what happened to these 2? So not use because no terminal blocks, no terminal to connect. So not using them. So if you are using in the program also nothing.
Okay. No response.
No response, nothing. Okay. Then can you see you add 1 DI cut? Right.
Okay. Yes.
You have 8, right? The number lah. Okay. So you already use 0 and 1. Next available number is 2, right?
Yes.
So you can change to 2 because by default it will give some value. So change to 2.
Okay.
So your DI 8 is 2, right? So means I 2.0 until I 2.7.
Okay. Okay.
Okay. So this is the very important because this is the number later you do inside the program.
Okay.
Let's say inside the program you put 2,
Okay.
but here is still 8. So it won't respond. When you get the input, it won't give you response. Because when the input is on, it will on 8.0, not 2.0. So this one is very important. Okay. Now DQ. DQ is 10, right? 10 output. So same 0 until 1. Okay. Why 0 until? Because it's 2 bytes. Okay. This one only 1 byte. This one just number 2 only. Inside here got 2 bytes. That's why 0 and 1. Okay. So here Q0.0 until Q0.7 8 inputs, Q1.0 and Q1.1. 2. So what happened? Q1.2 until Q1.7 not in use. Okay? Not use. First 10 only, right? 2.
Yes. Yes.
Then you can see you add a DQ, it become 12. So it change to 2. Why they become 12, right? Because it become 12, right? Maybe you can add, maybe you can change this one what? Into DQ16. Right? That one you can change. No, not the name, the module. You can delete this module and change to DQ also.
Okay.
Another DQ also. So that's why the number always like different numbers. Because make sure later on you change the module, it won't clash.
So you mean it's a random given?
Random given numbers.
Okay.
Because it will give you a space. Because here is 12 means so until 11 is already available. So let's say you change the above one, it can occupy until 11.
Who knows, I want to slot in something in between.
Yes.
Okay.
Okay. Then another one is the DQ8. This number is 2. So Q2.0 until Q2.7. Okay. Good. Now we talk about analog. So I have a built-in analog, right? Okay. 64. So this number also I can change or just leave it like this also can. Normally built-in analog numbers normally they will use like bigger numbers like 60, 50, 100 or that. You know why? Because maybe in the future I want to add additional digital input, digital output means we'll have a clash. Let's say because you see input are only used
Digital and analog, will they clash?
No, yes of course clash. So must use different numbers.
Yeah, I mean let's say I have a DI. I use 0 and 1 already.
So the next number 2, right?
Yeah, and then I use analog
2.
0 again.
Cannot because already used the 0.
Oh, even though it's an AI and AO,
Yes.
you have to follow.
Yes, because AI or AO, they're still using the same bytes. Still storing to the same bytes. So if byte 0 I already used, I cannot touch.
Okay.
So let's say next available, actually the 3 is available. I can change to 3. Example, you change to 3. We try to change to 2 now. The second one.
This one.
Yeah. Try to change to 2. Cannot. Next available is 3. So I can use 3, no problem.
So what is a good practice? It's like DI 0 to 100.
Yes. That's the best practice. Easy. That's why the building itself it gives you 64, 67.
Okay.
Because if you want to add I/O also what digital I/O, you won't go up to 64. Why not?
Right.
Because one byte got 8 inputs. So don't tell me go to like if 60 times 8 how much? 480 inputs. No. Something like that. So that's why. Okay. So 64, 67 is just nice, no problem.
Okay, how do you call it?
So AI2. Why 64 until 67? Okay. This one only 2, right? So analog input must be IW. Okay. 64. The next one is IW66. Why? Because we know word means I have 2 bytes inside. So inside here I have IB64 plus IB65.
Oh, so here the IB one is actually now it's until 67.
Inside here how many bytes? 4 bytes.
4 bytes, but actually it's a 2 variable
2
inside.
words, yes.
Oh.
2 analog.
Okay.
So the next number is IW66, IB66 plus IB67. So that's why they tell you that the byte number this guy is using from 64 until 67.
I know what you're saying. I will move on first. I'm just curious. Now it's confusing because one variable taking up 2 space here.
Yes.
When you do mapping, then how you do?
What's it?
I mean, when you do the mapping, like this program want to take a signal from.
No need to worry about that.
No need to worry about it.
Because why? The moment you key IW64, the next number is automatically 66.
Okay.
Yeah. No need to worry, but later on inside there also I have something to show you.
I got your
For
point.
better understanding.
Okay.
Okay. So you have 64, 67 I already used.
Okay.
So the next AI here, right? Actually I can start with 68. So it'll be easier for me to do programming, right?
Yes. Then it will be 175.
Yes.
Okay.
Then this one can start with 64.
Oh, okay. Because there's no error. Okay.
Yeah.
64.
So easier. So AI form. So 68 until 75, right? So IW68, IW70, IW72, IW74. 4 analog inputs.
Okay. Yeah.
Okay. Then another one is the AQ2, which is 64 to 67, like similar to this. So QW64 and QW66.
Okay. Got it.
Okay.
Yes.
So these are the addresses I can use when I do programming.
Yeah.
Okay.
One is the HSC and pulse here.
What's that?
The HSC and pulse.
High speed counter and pulse. High speed counter they use for encoder. If you're using encoder, so you must use this high speed counter. This is the address.
But but we didn't connect any
Encoder. So not using this limit.
Oh, it's a come in default. Actually, you mean this PLC has the
Can connect 6 high speed counters, 6 encoder, 4 pulse output. Pulse output is for your
connect? You mean connect X in what bus?
just using the I/O.
Oh, there's the I/O for high speed counter.
Yes, but they won't show you. You use these I/Os.
Oh, okay.
So that's why they how many got 6, right? So each high speed counter means an encoder will use 2 ports.
the IDO port or
Yeah, the DI port. 2
DI
DI port for high speed counter. 2 DI port. So what happened? It needs got 6, right? Means I need 12 inputs I will use.
then you have to go inside the configure. This DI 1 and 2 actually is for the high speed counter.
Yes. So you have 14 inputs, right? If I'm using 6 the encoders, I will use all the 12 inputs. Then
Got it. Okay.
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 High speed counter also same. They will use two outputs because I mean sorry the pulse. They will use two. That's why the pulse is at the output.
Oh.
So each pulse will use two. One is the pulse, one is the direction. This one for the servo motor.
You mean the pulse is the main function is to give signal to the servo?
Yes. On off signal.
Or servo motor it's not using 4 to 20.
No. Servo motor not using some they use some servo motor. I've been troubleshooting. Like some using analog for the speed. Okay. Some they just use one pulse, one direction.
I got. Sorry, just take 5 minutes to dig into. I work with some servo motor also. Of course, I'm not a programmer.
Yeah.
But I remember this is how it works, right?
What brand? Do you remember what brand?
Can't remember what brand.
Okay.
But essentially, there is a positioner, the height positioner.
Okay.
So you measure the height.
Okay.
So the height will give the transducer, the height transducer.
Okay.
You send the feedback to the PLC, right?
Okay.
Tell you this is like 247 mm, how many mm, and
Okay.
so on.
Okay. The distance. Okay.
Yeah, and then you set a set point. Let's say now the set point is 200. You want to go to 245.
Okay.
So you key in the HMI.
Okay.
And then the servo motor will see, you read the transducer, oh, this is not a 245. Then I will move on the correct direction and extend it.
Yes.
Move until 245 or 244 already, then I stop it. Yeah.
Okay.
But from my understanding, just reading at the HMI, I expect it only read the transducer position reading and then give a signal to the servo, either is run forward or run reverse. I don't know that, or they have to give a pulse signal.
Yes, pulse.
Actually, they are giving pulse signal.
You must give pulse.
It's not giving one.
Because why?
One DO.
No. Why? Because why? Like inverter.
Ah.
How to control inverter? What are the data from the PLC you need to send to inverter? You need to send two data. One is speed, one is forward backward. Correct. For VFD.
Correct. Yes.
One is speed, one is the forward backward.
Yes.
Okay?
Yes.
So speed is using analog plus analog also can.
Yes.
Okay? Then one digital input.
Yes.
Okay, you send. But servo motor, how it works? One is pulse, one is the direction. The pulse itself is already come with the speed and distance.
It's a DO.
Yes, for PLC just a DO only.
How your binary 1 and 0 can become a.
So that's where it plays that it become a very high speed pulse. On off.
This is the one telling him that if my frequency of on off is this
Yes.
much,
So
then you are moving at this speed.
moving. So you will have two data. One is the frequency, one is the number of pulse. Okay? So the programmer what they do before they do that this number right 245, 240 they will measure from here to this position what is the pulse value. How many pulse, how many thousand of pulse I need to give. For example, from this position to this position, like say 100,000 pulse. Okay? So they will do some calculation. Make into distance.
I roughly get what you're saying.
Yes. So when you give 240, so he know I need to go until pulse 8,000 pulse. So I move until 8,000 pulse because how I know I have an encoder feedback also. The encoder will give me the position, where is the position to the PLC.
Okay, you're fine. So if I go back to just on that example, I say from 200 mm go to 245 mm. So there's a 45 mm difference. Essentially, when I key in a set point already, the PLC calculate 45 mm, go forward, you have to, using this RAM speed, if you're using this RAM speed, then you have to complete the movement in 10 seconds,
Yes.
and then you need to have 1,000 pulse.
Yes.
So it will
Yes.
10 seconds, complete 1,000 pulse.
Yes.
And then you will follow the speed and move to the right position and stop there.
Yeah.
If after the 1,000 pulse, I still see the encoder, I still see the transducer reading different to my set point, then I give you an error.
Yes, correct.
Ah, so that is how the servo motor.
servo motor works.
Got it. Okay, then I clear. Yeah.
Yeah, because there's another type of servo motor run on similar to this one, VFD,
Use the AO.
AO and DO.
Okay.
Just one is to forward or backward, another one is a speed. So another way is one is pulse, one is the direction. The pulse is combination of your distance and also the frequency.
Got it.
Yes.
Yeah. Okay.
Because
Yeah.
for me, all the while I'm working here for 10 years, all the while I was thinking just a pulse only can control servo motor. So there's one time I go troubleshoot one system. They're using servo. I open the manual, it's everything in servo. Then in the manual I see they don't have pulse. They use analog to control the speed.
Also possible.
Yes, possible.
Interesting. Okay, I got your point.
Okay.
Okay, yeah.
Alright. Next.
So this is a
Yeah.
function. Okay.
Okay. So this is the IO lah. Okay.
Okay.
So I can close. Okay. Then you can, once you done this one, then you can go to the PLC tab. Show all tab. Yes. Double click. So you can manually do the mapping. Okay. Start button. Example. You put start.
Okay. I should write here start.
Yeah. Start. Okay. Enter. So automatic by default lah I0.0. If you put any name also same. Okay. So let's say stop. Start stop lah, for example.
What is the percentage it means?
Percentage means it's a global tag. It means
Not or you
Later
mean global is
on-
all the function block can use.
yes,
Okay, got it.
all the blocks can use. Because
Okay.
inside each block you can use the internal tagging also. That tagging don't have global. That tagging will have a hashtag.
Okay, got it. Yeah.
Because same thing when you do some variables even when you use using SCADA or something, when you do variables you will put the percentage, right? They call global variables.
I never do SCADA.
I mean,
I will
sometimes-
listen.
Yes.
Okay. Okay.
Stop.
Stop. Okay.
Just put in some names lah. Okay. Then one output, let's say motor.
Oh.
Okay. So motor is the output, right? So you change the address Q0.0. You can use this to change also can, or just can.
I can just key in
Just key in. No need percentage. Just only percentage actually.
Q.
0.0.
Okay.
Can. Okay.
Yeah.
Like this also can for your I/O addressings lah. Okay. Or you go back to the device configuration. You right click property. No, right click the properties. Okay, this one bring it up. This window here. Yes. Yes. The one here. Sama. Bring to the half of the page. Okay. Then got so many things. This one so many settings are for I/O. So later we see. So you go to I/O tags. Okay, can you see? It will list down all the I/O, like I list down here, all the I/O here.
I forward.
Can you see? I have a IW64 and 66 built-in analog input.
So this name here actually it means
No, this name just now we created
I know.
inside here.
in a normal practice, this name here is something like
For this input, like a button,
Yeah.
push button.
probably it's something like TT101 dash
Of course.
AI
Of course.
It's a BFT dash force fault or something.
Yeah.
This is the kind of things we expect written here, right?
Yeah, of course, that's the same name is according to your wiring diagram.
According to the wiring.
Yes, because this is the wiring, okay, literally. So in the wiring section, just now we do this. So normally the push button, right? Normally what they do, they put start PB, PB01, PB02. So that is the number when you open in at the back of the push button you can see
Okay.
PB01, PB02.
So that wire and here is exactly the same.
same, must use the same name.
Okay, okay.
But for training, I just use normal name lah.
Got it.
Because we don't have the wiring there. Okay.
Okay.
So for analog, I can key in here. Let's say this is TT1, TT2.
Okay. PT1. Okay.
Yes. You go to show all that. Double click. So it automatically update here. You can close this using this one. Automatically update it.
Okay, got it.
So this one is all tag, Actually, if you want to separate the tagging, you can add new tag table, like one tag table, all the input, one tag table, all the output,
Okay.
one tag table, all the analogs. You can do like that also.
Okay.
But if you click show all tag, of course, all the tag will show.
Okay.
But when you do like tagging, like page table tag by table, you can do.
Okay.
Okay, good.
Okay. Yeah.
Any question until here, you can save this project file.
No problem. Yeah.
No, okay. So we go for a break. And after the break, if this one is okay, we come and we add new device, we do for 1500. So we see how to add the modules.
Okay, sure. Okay.
Because normally I won't teach this.
Normally.
Because they come to learn, troubleshooting and programming only. Not like configuration, all that.
Even normally not.
No, because they are more to their maintenance guys. So maintenance guys, for them is most important is the troubleshooting. So how to, but hardware I will show them. But
Okay,
this-
so your audience
Like
is.
these details I won't show. I
Oh, you're
depend
fine.
on my participant. So what they expect from me. So
That is
you
really
expect from-
appreciated. This one to me is very, very important.
Yeah, that's why
Yeah.
we do like one-to-one training also, because I really can customize for your. So sometimes I take from company also. They say two, okay, I just go with the two. That's why I don't have any like
Standard flow or.
standard. A slideshow to teach what. No. Normally I just write it down what I want to teach here. That's all.
Okay, okay.
This is what I teach. Then according to your questions, the way you ask questions, what are the questions you ask, then I know okay what are the knowledge I can share with you. I customize all that.
Really appreciate. Okay. Yeah.
Okay.
Alright.
Great. Where you park your car?
Just out there. Well, in the morning I come here, there's not many cars. After lunch it's full already.
Yeah.
Hey bos, woi apa macam? Wah, sekarang jadi big boss sudah. Wah, what to do? Macam ini terpaksa pula. Macam mana? So far so good ya. Itu hari ya saya ada sembang sama siapa? Baru saya tahu ah. Oh, sekarang siapa? Siapa nama Sentil dia pergi Aruba. Oh itu sebab dia jadi big boss lah sekarang. Wah you ambil dia punya position lah. You lah. Wah what to do lagi sekarang big boss ah. Oh, mau apa? Boleh saya masuk nggak? Saya under you lah. Hah? Tak lah, kalau jadi isi syok sedikit lah, klien mana syok. Texas, tapi saya nak join data center lah. Saya memang looking out, and then actually I got one offer sudah lah. Kalau tapi tak lah, saya gurau-gurau saja lah. Saya tengok macam mana you sekarang just catch up saja. Sebab saya tengok sekarang banyak data center project . Wah, then you banyak sibuk lah. PMC pun ada you juga. Semua itu bridge kah? Oh, GDS. Saya nampak itu Infinaxis pun under you juga kan? Itu Infinaxis. You ada client Infinaxis juga? Oh, itu you adalah PMC? Oh. Google you pun ambil juga. You adalah consultant. Wah, betul kah? Besar itu. Wah. Sekarang main hard betul-betul big player sudah lah. Bagus lah, dan you orang semua banyak kerja kau sekarang lah. You ada position kah? Ada commissioning manager ke apa kah? Design apa? Mesti IR punya kah? Oh, mechanical, electrical semua lah. Oh, you sekarang memang you looking out to fill all the design position lah. Oh. Dinesh? Okay, you banyak big boss. Ya. For apa? For data center kah? GDS punya data center. Itu under siapa? Under MyHub ke? Under client. Itu GDS punya itu commissioning manager. Under MyHub. Oh, contract under MyHub lah, bukan tolong client untuk interview lah. Under MyHub PMC lah. Oh, okay. Oh. Ya, boleh tanya-tanya lah. You tanya ask around. Ini contractual role bah yang you sekarang interview. Oh, 1 year you bagi dia 1 year contract lah. Oh, sebab saya pun get an offer. Tapi saya join itu pure commissioning punya company lah, itu Comtech. Bukan Comtech, COMTCH. Ya, saya tak dapat, belum join lagi. But I'm thinking if my heart also have, you say this one is going to GDS kan? Saya nak try je. Oh, tak apa mah, sekarang semua data center pun Johor juga. Ya lah. Open to anything lah, but I mean if commissioning then I think it's easier lah kalau you ada lain. Tak ada apa, kalau you resident mechanical resident maksud. Oh, boleh try. Berapa role you tengok sekarang? Berapa Thanks you nanti, sir. Thanks you nanti. Yeah. Okay. Okay, thank you boss. Bye. Sorry, sir. Okay. Okay.
Today itself, I have 3 participants message me.
Oh, the problem.
One was the day I sent a request for PLC software. He's coming on next month. So before he comes, he want to install in his laptop. So I sent. So he suddenly he cannot open the file.
The version 18 lah.
It's the Mitsubishi.
Oh, Mitsubishi.
So I'm also wondering why.
Okay.
Okay. So just now we see the configuration. Okay. For CPU 1200 lah, right? Okay, you can close this one. So So now you know, right, how to add the IOs, everything, yeah? Okay.
Right.
Now we go to add new device. We add 1005. 1005, okay, CPU. Okay, 1005 you see, yeah? Only this model have C. Right?
Yes.
C means it's a compact, come with the IO, input output. Okay?
Okay. Okay.
Other than that, only CPU. You can just click here and can see also. Just click 1211C. Just click one of the part number. Okay, you can see it got IO, right?
Yes.
Okay, you click on this one. Just click on this. Just a CPU.
Okay. Okay.
Normally there's this one, right? They print the IO address there.
Okay.
Have you seen before?
You mean the paper?
The paper they print. Or
Yeah.
sometimes they will put a sticker.
Yeah. I think I see it. Slot in, they slot in the paper here.
Yes, yes. Okay, good. So now we use this one. Okay, our part number is what? Can you see? I think 1CK01. And the side also can see.
1CK01. This is, yeah.
No, second one. Okay. Now this one. Okay, the version actually need to power up that. Okay, let me power up that.
This power supply,
It's a 230 to 24.
you can buy from the internet.
Yeah, of course. Now, just search 230 AC to 24 volt power supply.
Or 230 AC to 24 BTC.
Input is 100 to 240. Output is 24.
Oh.
But need to choose how many amps you want.
Okay.
So how many amps is depend on how many modules want to use this supply. So you just plus all the amp.
So let's say if the programmer expect to use one PLC plus
The IO card, everything.
and IM, then calculate in total how many amp is that, and then you choose this one.
Yes. So normally PLC in the panel they will have like two type of power supply. One power supply is for the PLCs. PLC, the IO card, everything. Another power supply for the relays, for your devices, for your field device.
But a question.
Yes.
If you say like that, normally the PLC come in, it go to the C-top, right?
Yeah. Actually, same thing.
Yeah, but the C-top, the power coming out, isn't it supplied to all power to the devices already? Also,
Not necessarily.
the devices is not taking power from the C-top.
Depend, because the setup need to know with how many amps. So this one is the output. It's just a 5 amp only.
2 liter to support all the
IO devices, my field devices.
field devices.
Not 2 liter. Depend lah. Because how many relays you want to use. Not power up your instrument.
Oh, you mean the device like what? Power, like.
Yeah. Okay. This like this. You have a PLC. From the PLC, go to a relay, for example lah. Okay. From the relay, then only go to your. Or let's say like from the PLC, go to contactor. From the contactor, go to the motor. For example, okay. So to power up the PLC, I need 24 DC. Correct.
Yes.
To power up the contactor also, sometimes it's AC or DC. Okay. Let's say the contactor is a DC contactor.
Okay.
Okay. So I need to know. I want to buy a power supply. Let's say I want to use this power supply for both PLC, the whole PLC, and all my contactors. So I need to calculate all the contactors, how much. Then only I buy. Or I use one power supply for PLC, one power supply for my contactors.
You say the contactor, it needs
Amps. You need a load also.
it needs a load also.
Yeah, because it's a coil, right? Inside there, a coil, similar to a lamp. But normally.
Or this
usually-
EIDO alone will not able to power the
No.
connector.
Yes, I need the power supply.
You need an additional power supply.
Additional power supply to
Which normally people take the power from where? Think of it this way lah. Let's say I have a PLC panel here, right?
Yes, okay.
I have it control multiple pumps. I just assume lah.
Okay, pumps, we don't talk about the pumps because the pumps are because it's a three-phase.
Yeah.
It's directly going line, okay? Let's say we talk about valve.
But let's say pump lah.
Okay, pump.
It has an MCC.
Okay.
Every pump has an MCC.
Yes.
Contactor is inside there.
Okay.
Here, go to the
Okay.
Because it keeps a signal,
okay,
signal,
okay,
right? If
okay.
you go to that.
The output is going there.
Yeah, go to the MCC. This MCC or the contactor, you need a power
Power,
source.
yes. To
Normally it
energize.
takes from one of the phase to power the coil.
Yes, yes.
Or normally it's do like that lah.
Yes.
But you say other than this, let's say the contactor have their own power source already. What kind of source is consider probably big? It's not going to take from a C-top itself. Actuator.
Actuator, the valve, everything, right? The solenoid valve, the pneumatic valve.
Let's say the solenoid valve lah, but solenoid is powered by the pneumatic already lah. Solenoid.
Yes.
Solenoid is powered by solenoid itself.
Yes. So who need to power
Yeah,
up the solenoid? The PLC. So the output go here.
Okay.
Then output is positive, example lah. So you need to give a negative one. So from the same power supply, you use that output.
The solenoid normally has a 3-wire.
Solenoid only 2 wire.
2-wire.
Yeah.
Then the power is,
One is the output, one is from the power supply.
and the power supply is not probably.
You can use this also can. Different power supply also can for that.
Oh, okay.
It depends. Later when you do wiring, I can show you.
Okay, got
I
it.
have a contactor, I have a relay, I can show you.
Okay, got it. Yeah.
So I can show if I use one power supply how to do wiring. If I use two power supply how to do wiring.
Okay, got it. Yeah.
Now let me power up this one.
That's power up.
Okay. So sorry, use this one also can, use this one also can, no problem. This is a cheap one lah, this is this one, that's the difference. Okay, so this one also can work, so no problem. Yeah, just now you asked about the fuse, I forget to mention about the fuse, okay. Yeah. So after I this is positive. Yes, we color right, that's not.
Okay, the red actually is about.
Positive.
You always know that because you read the manual lah.
Yeah, read the manual.
Why there is a two positive and
So
negative? It's like two different power sources.
no, only all these two is looped already. These two is looped. So if you want to take from here to
Go to
use
another one.
yes, can.
Okay.
Because if you're using terminal type, it means that sometime I need to go from here to, because normally, let's say I have this one, there's some IO cards, right? So from here I connect, then I need to jump, right? So if you're using a terminals like this, you can connect two cable, or two cable you join into one for loop like this. Okay, like this, one for loop. You can connect two cable.
Okay.
So
Also possible.
possible. So if the space is too small, so I use one here, then from here also I can tap to others.
Got it. Yeah.
This is so expensive, one itself is 18 cents. Okay, done. Power.
Always plus is equal to the red and
Yeah,
is equal to the blue.
yeah. If I wrongly connect, what happens?
What happened?
So it will power up. That's all.
Okay.
Okay. So it's on. Can you see? Automatically
Automatically
running.
run.
Yes. Okay. So this one is an overview. I click overview. It show the IP address. Can you see the version and the part number?
Yes.
So version 2.9. So I can must choose version 2.9.
Also, you say that's the reason you say that it must power up to see it.
Yes. For this guy, I need to power up. You remember we do the
Go
online
inside.
access.
Yeah.
And online access, we check the IP address and the version. For this guy, I don't need to go online also. I can see here.
Okay. What do you call it?
Okay. This is overview. Then the PLC. You go inside the PLC. The project name I can see. And I can see what TI portal version the programmer used before me. Okay. All that I can see. So new pages. Page 2 is the module name, module type, run designation. If the programmer did lah, give the names and everything. Local identifier. All this. Hardware version, bootloader version, firmware 2.09. Configuration 2.09. I mean 2.9 lah. Okay.
In the past, so big, now the small size.
Yes.
Equivalent of.
Equivalent to that, even more advanced.
Even more.
Yeah. So diagnostic, this one got error. If you want to know what error, go online. Here, just click here, it will show what is the error. Alarm, what is the alarm? You remember diagnostic buffer, just now we enter here. No, just now we online, we click diagnostic buffer, it shows there's a IO not there, that's why I got error.
Oh, yeah.
Something like that. Okay. All you can see here. Watch tables. Okay. So there's no watch table. Watch table means you can create a watch table. Some of the values, what memory value, input values, everything you can create. Then you can load here. So from here itself, you can change what is the value, all that you can see. Not changing, you can see the values of your temperature, all that.
Oh, you mean from outside here?
Yeah, from here itself you can change.
Oh.
Okay, okay.
Oh.
Now no watch table.
Okay, okay.
Then cycle time.
Okay.
Okay, used memory, we can see how many memory used. For this you need to online.
Okay.
So this is diagnostic, this is setting. So the setting here, the address, IP address can change, date and time, run, stop, reset.
Addresses,
Yes.
means you say IP address.
Yes. Protection, if you want to put a password, can put password, backup, log. Can you see firmware update? Even you can update the firmware here. But this is already new 2.9. Let's say another 2 years they release 3.0, you can update. But for that I need to use the memory card. Load the firmware inside the memory card. From the memory card I can update. And what else we have? Modules. So just add the local module. If I add some modules, I can see all the modules here. So just one module only. Sort one. So X1 means these ports. See the names. X1, X2. Only X1 means the what? Here you can see. Can you see? X1 is a profit and port, right?
Okay, so S1 and S2.
So can you see X1, IE or PN? So port 1, port 2. There are so many settings you can do. All these settings here can do by using software.
Essentially, here is doing configuration actually.
Display. So they transfer for display lah, the language, all that.
Okay, okay.
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 Then,
So this is a cover up already. If I want to program or configure or whatever, it's I don't know, should turn off this one first then only unplug.
no, can
Direct unplug,
can.
plug it, scan it, then
Want to upload, can upload. Want to do new project, do the project and transfer it.
okay, got it, yeah. Okay,
Okay, so
Yeah.
we will be using both these two.
okay, got
These
it, got
3
it.
days. So I think I will more focus on the hardware side lah for you. Hardware, how to configure the hardware, change the IP address, do setting in the hardware, all that. Programming maybe will be less.
Right, I think, yeah.
Yeah,
I think-
programming I will teach you, of course. I will teach you the basic programming and everything. Maybe I don't do projects. Normally I do projects, so make sure they understand the programming and everything. I do projects, but I do small
Can we
projects.
do just a small project?
Yeah, of course,
Just
like one project.
give me enough confidence oh, I can at least program something
Yeah,
working.
Yes.
The rest I can like go to try
Actually,
to like,
you can buy one PLC like this. Very cheap, this one. This one around 1,000, 2,000. Not this one. This one 1,214. This one 1,212 can get 1,002.
oh, okay.
If you want to, involve in the programming,
Programming, just try
do small
and-
changes, all that, and buy one.
But let's say it's simulation on the TIA software.
Can also.
Can also.
Can also.
Or without the hardware.
Yeah, I can show you how to do the simulation.
Okay, yeah, got it.
Yes. But if you want to buy, you need to buy this one. This one, because this one is, I think, the cheapest one with the IO.
Okay.
Only the CPU they have is 4,800 something. Then you need to buy IO caps. This
Okay.
all costs around 7,000. This one I think I buy around 6,200 something only. All together. So got 16 input, 16 output, 5 and input, 5 and output. This is very new. I think when we got around 1 month ago. I hope. So if I not all the training, I do some training only. I just show them and finish because I use that one.
Okay, got it.
One another thing is one not user friendly is the IO terminals.
Very,
It's not a
very
screw
key,
type.
Oh, not screw type.
It's like a slot-in type.
But this is isn't it is a good better because easier to plug in and
Plug out. Easy to plug in, plug out.
yeah.
But you want to, but if you, let's say if this one spoil, right? But of course, like this one spoil, you cannot do anything. Okay, you need to change the whole module. Let's say you buy another one, right? Which is this type. Let's say this one is the spoil one. So you want to change that module. But you can, one by one, you take out the cable and connect back one. Right?
What?
Let's say I have, this one was 16 input, 16 output, right? So input, output, plus the power supplies are all together around 40 cables. Let's say this one spoil. This modular. Let's say this is a modular, not together. Example, modular. This one spoiled already. So you will replace this module, right? But the wiring, how you do? You take out one by one, connect back, correct?
Yes.
Actually, no.
Oh.
Just take out like this, you can remove.
Oh,
So because this one is just a connector only. Normally spoil means this is the module will spoil. So just take out, change the module, just connect that.
Oh. Only for the newest 1005.
1,500, 1,200 don't have, because 1,200 is very small. So we don't have.
Okay.
Because this one is also very less
I
IO.
was still thinking actually what is this? Oh, actually it's to pull it
This
out.
one is the same. This one also, if this one is spoiled, right?
Yeah.
So this one is spoiled, just take out this one. But that one is together, and try to take out. You also need to buy the base and do some training key. So just take out of this. This one is from okay lah. This is the connector to this. So if this one is spoiled, just press this one, take out. So all the cables will be here. So I change this is a new module. Then I just connect. So you just need to press here. Screws or
The old version is using the screw type lah.
screw type. Actually screw type also good. So this type also good. Slotting type also.
Slotting type also.
This one must keep up. If this one, they have a screw in the middle. So you unscrew this one. If you unscrew it, will slowly come out. Then take out.
Got it.
Yeah. This also same. This one is spoiled. Just get out this module. Change program.
Okay, got it. Yeah. Alright.
Okay. So now we see how to do configuration for this. Okay. This is power download this anything here.
Okay.
Later, because now we're going to add some module. After I download that module, will be error.
It's a
Okay.
very okay.
Okay, now this one is a security feature. Okay, this one only enable in newer versions. It's now version 2.9, right? So that's why they have these security functions. Okay, for this module, this one is 4.2, right? After 4.4, you have this. Okay, security. Okay, so the first one is protect the configuration from TI. So means if already the configuration already done, means if anyone go and download new configuration cannot. So I protect. Okay, so with the password only they will can do the configuration.
So you say this feature, let's say we use this 4.9, right?
Yeah, this one is 2.9.
Or 2.9.
Yes.
And then there is a security function inside.
Yes, yes.
So nobody can simply download and change anything.
Yes. With the password, the guy with the password only can do that.
If there is no security function, whoever plug in, he can simply
download.
change anything.
Yes.
Nobody can lock him out.
Yes.
Okay.
Unless you need to additional. Actually, without this, okay, what happened is actually this one all is already in the hardware you can do. But you need to before version 4 for this lah. Before version 4.4, but for this I'm not sure what version, before what version. Before that, you can do this one, but you need to do manually. This one is, since this is a new firmware what happened, once you choose the hardware, it will straight bring to this window. That's the difference.
It's not that they cannot do, but
Can do, but need to do manually. This one straight bring to this first.
okay.
That's
okay.
the difference. Okay,
Okay,
you
got
just
it, got it.
uncheck. Okay, next.
Next.
This is the secure, right? Remember just now when we do this one, we choose 4.2, right?
Yes.
Then later on we choose 4.6. It shows secure communication. So this is the one. It means only secure communication means only HMI and the PG Siemens PC only sometimes can communicate to PLC.
Siemens.
Yeah, they have Siemens. They have their own laptop.
Oh. Okay.
Ah.
So this one cannot lah.
Cannot.
Oh.
So what I do, I uncheck this one.
Okay.
So means legacy communication means any communication.
Okay, got it. Got it.
Okay, next. Last one is the password protection. This one is normal. All the this one complete protection. You put no protection.
Okay.
Next. Finish. So can you see? So this one, there's no like position to add I/O cards. Anywhere you can add the cards. Okay. So normally at 0 you add power supply.
Oh, power supply. Just
Yeah,
now,
that's
this one has
power
no power
supply.
supply.
That one don't have power supply. Power supply slot they don't have.
So meaning to say this one, normally people use it do not need a C-top. That one always need a C-top.
Okay, yes, good question. Why? Because like I said, this one the power input right can be AC also can, DC also can. Right? This is the main. Because this one is a DC right. There's another one AC. So the main power can be AC also, direct 230 also can, or using power supply also can.
Oh.
So that's why for that model no need this one.
Okay.
For this model, actually you can use this one also can, use this one also can.
Okay.
What?
Okay.
But normally the Siemens, of course they use Siemens one.
Okay. Got it. So this is a have a power supply.
But no need to add also can, but just we add lah, I show you how to add.
Okay.
Okay? So can add anywhere, no problem. Can you see?
Oh. Okay. You can plug. You can pull.
Yes.
Okay.
Anywhere, so not an issue.
Okay.
Okay, but normally before. Yes. For this model, 300 and 400 always before PLC only. Power supply. Only for this model only they just randomly put anywhere can. Okay? Click here, then of course DIDO, just add some DIDO. This one can go up to 64 DIDO.
Okay.
Can you see? 64 you see, 16 means just one row enough, because at one row is 20 IO, 20 terminals, right? So if let's say 32 means okay lah, or 2 lah, 2 terminal 32. 64 means how? Right, click the 64. Just click, go down.
Oh, so big.
Go down here. I don't think so, it's a screw, right? Go down. No, I want to see this. It's a syncing sourcing input type 3. If not mistaken, this one is like a ribbon cable there. That is.
Oh, you mean how it connects to the PLC is through the ribbon cable?
Yes. Like a ribbon cable.
Or it's not from the communicate from the back of the.
No, it's still communicating from the back. I mean the I/O modules, I/O input.
Oh, it's not for one
One by one like this. No. Because
Okay.
64,
Okay.
32 maximum.
Okay.
Okay. So, okay, never mind. Then you go to DO. Like the same lah, similar thing lah. Okay, equal to AI.
Okay.
Okay. This one you see, this one is a normal lah. Normal. Okay, you click here, just click. Can go down. I think this one only for carbon if I'm mistaken. Common mode voltage configurable and I. Not sure why I. Okay, you go to U. U is what? Universal. Oh, maybe check this one. But this one is, I think, is configurable. Whether you want to use RTD or thermocouple.
Okay.
Just now is RTD one module, thermocouple one module, right? But this one in the here in the property later you can change what you want. Maybe you select one and not input. Yeah. Later we see. You double click property. You click here, properties. Go to general. The input 0 to 50. Yeah. Inputs channel 0. It's a current. Second one, go to second one. I think all current. All 0 to 20 milliamp only.
When you select, let's say now we have a 0 to 10 volt.
Then I think must use this one.
Or then you have to use a different
Yeah, you double click. Okay. Can you see? It's already there. Properties. So voltage.
Okay, got it.
If you this one all also very simple lah. I means current, U means voltage. So this one all is a selectable. Can use current, can use voltage, can use RTD, can use DC or that. But it's only 4 lah.
Okay.
Why 4 only? Because they will have different type of wiring. If current, maybe number 1 and number 3 connect. If voltage, number 1 and 2.
Okay.
If RTD, you must connect 1, 2, 3. Like that.
Okay. Okay.
Different wiring connections. Okay. Then you can close the AI.
Okay.
Okay, go to special. Special is what? Slot power or just a slot power. You click the slot power, I think the last power. Go down. Active backplane, ESD protection. This one, I think, if you use the like that rack, it's a slot power. Like this cover. This one will cover this.
Oh, normally says all the this one is how you say installed on the rack itself.
Yes,
It's just a normal rack, right?
The DIN rail.
Which one is the DIN rail?
This one DIN rail.
This one is the DIN rail. So both also can install on the DIN rail.
No, only that can be installed in rail. This one is they must use this rail.
What you call that, right?
This one is Siemens right lah, because
Oh.
only can connect Siemens only.
Oh, okay.
That DIN rail is a universal,
Okay.
can connect anything.
Okay, DIN is a normal electrical panel.
Yes,
rail
electric
lah.
panel, yes.
This one only
Must
can
use
go
the
to-
Siemens rack.
Siemens.
They call rack lah.
Okay, Siemens rack. Okay, okay.
Then go to communication modules. So can you see Profinet? Same like that just now we see, right? Profinet, Profibus, point to point, IO link,
Yes.
same thing. Like the example Profinet, you take all one port. The Profinet CP. Yeah, I don't know how many ports you see. Only one port. But what supports? We go down, you must see what support. It support industrial Ethernet, TCP/IP, UDP, SL communication, VPN, firewall, SNMP, email, time synchronization, or RJ45 or the RJ45 cloud system, or MQTT, or can use MQTT also. MQTT is like it's a protocol to send your data to cloud.
Okay.
It's a protocol. To your cloud also can, to your phone also can. MQTT is a message queuing telemetry transfer.
Directly, I mean, it's a,
Yes.
from like a wireless or.
They must connect the cable because the MQTT is the software. So you need to connect to your laptop, need to use the software. Or you know Raspberry Pi?
Sorry.
Raspberry Pi.
Oh, okay.
You have heard about Raspberry Pi?
I heard about it. Yeah.
Yes,
that's
it's like a computer.
right.
So that computer can use MQTT. So from here I take the internet, connect the Raspberry Pi. From the Raspberry Pi I want to connect the cloud, everything can. Actually PLC can do a lot of things. Even if you have an alarm you can get a message. All that can do. Only thing is you need the devices.
Then SMS.
Last time SS using SMS.
Actually, this one is coming from what?
SMS.
Yeah.
Normally SMS what they do, they use a modem, GSM modem.
So I have a GSM modem.
Modem, you put a SIM card there.
Okay.
The GSM modem, they will have like some IO everything. So you program the GSM modem. Okay, if this input is on, you send this message to this number. That's the concept.
And the communication to give what information to the modem is
Yeah.
through MQTT.
No, the MQTT is not there.
Oh, it's
Ah.
using what? That
No,
GSM.
it's just GSM modem. They have Ethernet port everything.
Also, it's a Profinet also.
Not Profinet. They just use no, but I'm not very familiar with that one. But I know because last time my friend did a project in university time. So it's just Ethernet communication, but I'm not sure. It's not a Profinet.
Normally, people don't directly hook it up to the PLC lah. Go through a switch and then
Yes.
get a high level IT team already lah.
Yes. Last time they used GSM. Now no need GSM because GSM need what?
A SIM card.
SIM card.
Ah,
Send a message.
right.
Nowadays, that's where we use the MQTT.
Oh, that one not even need a
So
GSM.
MQTT, they will have not MQTT. They will have IoT device, IoT module lah. Okay. So this IoT module can support MQTT.
IoT module.
IoT module. Can call IoT, IoT module. So it's just a module lah, similar like this IO card lah. Okay.
Like
But
a module like this.
but no need to add together. At anywhere you also can add. It's just a separate module. Okay, it's there for Siemens or even Advantech, so many brands there. Okay. From the PLC connect here. No need to PLC, no need to do anything. Inside here, you do the settings. So you need to know what data you want to take from the PLC to here. Then, so this one now become like a wireless. Can share your data using wireless.
Wireless, you mean really popular wireless?
Yeah, wireless, no need Ethernet. So now your laptop you open the MQTT software, must have a software now. I think one of the software called Mosquito. You open up software, you configure that particular module. So then you need to do, okay, this data coming, what are the message I need to send?
But you mean this one is within the wireless range lah?
Yeah, of course.
It cannot be because GSM is the one you at home, you at everywhere.
Yes, if
also
you want,
receive
that one
it.
you want to use, you need to use cloud system. Cloud. So,
Do
same
you mean the
that-
GSM has to go through the cloud?
No, GSM will go through the
Oh, okay.
GPRS.
Yeah.
GPRS system.
Yeah.
But even the MQTT can connect to your cloud. So, but the MQTT must be that near, I mean the what?
Near to your router.
The IoT and the IoT controller must be near to the PLC. Of course, need to do wiring line. Okay. I mean the LAN cable lah. Okay. Then from here, I connect. I must have one PLC then. I must have one laptop then, because the laptop need to use the MQTT to scan the data, send to your cloud. Then from anywhere you just log into your cloud, you can see the data. There's many ways to communicate.
Yeah, but normally, yeah, I get what you're saying. But of course, if people want to use cloud, then typically they from the PLC, they go to the core switch and go to your cloud server.
Yes, of course, must have the Wi-Fi there.
But you mean the option is if they don't have this, then you have the MQTT, you also can.
Directly to your cloud system. No need to go to server and thing.
Okay.
There's a software called. So now for this one, right? If I add this one, then I don't need the IoT module I say. Okay? I just add this one. I just connection to cloud system over MQTT. So directly use a laptop to connect to the cloud system. No need third party software or anything.
Okay. Of course, I never seen.
No.
Yeah, so
I just give you like
yeah.
imaging.
Yeah.
Give you
Okay,
idea that
okay.
what the PLCs can do.
Okay. Understand. Yeah. Okay.
Okay. I've got so many things on this one. So this one also you can see the I/O here. Open. So you see the analog input come with the 0 first. Can you see? So not digital. So if you want to change, can change. So for this IW0 until IW8 got 10 analog input. Then start with 10 only your digital input. 10 and 11 like this 10.0 until 10.7, 11.0 until 11.7. Then same thing high speed counter, all that. Then start, because if the 1002, the high speed counter they already like go to 1000 address, like 1000, 1002, right? But this one is just continue only. That's why when you add additional DI, it's become 124. So what you will do, all these can change to like normal, start with 0.0, 0.1, all that.
Okay, do the same thing like just now.
Yes.
Okay.
Okay?
Yeah. Okay.
Any question until here?
So we didn't talk about the mapping. Mapping actually, is this a mapping activity or no?
Mapping means, okay, what do you mean mapping? The IO mapping?
Yeah, the IO mapping.
Okay, how? So let's say I have push button.
Right. Let's say when we say start a project, we have instrument list,
Yes.
and then we have instrument list, then we have a cable schedule,
Okay.
then we define originally this is an instrument, this spec, this is a 4 to 20, and this is a like 0 to 16 bar, whatever.
Okay.
And then you have all the cable schedule, it's just supposed to be, and then go to from the cable schedule, I don't know which one first, wiring diagram first or cable schedule first, normally from the engineering.
Okay.
Okay, yeah, so
Not sure.
yeah, so it's come to the site, install already.
Okay.
They will have a lot of problem like the termination is wrong, the instrument and the PLC original program is wrong and so on. The interfacing is wrong. Yeah, I mean, can think of it if there is a few thousand of instruments,
Yeah.
then definitely there will be mistake there.
Of course.
Yeah.
If one wrong means finish.
Yeah, so it will be have a lot of time. how to check, where to check the mapping and so on to see, this is a field is installed, this model 0 to 16 file. Here, where to check this is the configuration and so on. Actually, this activity is done at which stage here?
Okay, so if you want to do that, you cannot check the instruments because the instrument is not connected here. It is using hardwire only. Correct? For the 20 or even the sensors, all that is just a hardwire.
Right.
Yeah, so what you can see is, the address here, they connected, like this for example, DI16 start with 10.0, right? Okay, 10.0 until 10.7. So you can go to property here, go to IoTech.
Okay, yeah.
No, okay, not this one. You close, you select the CPU. Okay, then just open. Okay, so from here you can see, the first input is what, second input is what here.
Right.
But this one is the programmer already done in the PLC tag or here itself, the programmer already had.
Yeah, so just like I said, this
So
is
no
a
need-
push button
Yes.
one, push
So you
button
don't need to
two.
go to the PLC tag to check. You check in the hardware here one by one, IO tags. So you can check, okay. So let's say I have a 5 analog input, right? So you check, okay. So they say according to wiring diagram, this 5 analog input go to the PLC, mean the CPU AI, not the additional AI. Right? The CPU AI, I got 5 AI. Then I check one by one. Okay. So TT1, is it in the wiring diagram TT1, TT2? Then we check. Okay. So this is where they do the IO mapping.
Okay, says for instance, this is a TT101.
No, TT1 must be analog.
Analog. Okay, this is a TT101.
Yes.
Then your tag table is
They depend whether they use a default tag table or for analog is one table, for digital is one table.
this is what you say lah. Either you want one master table,
Everything is there,
or you want to split so
yes.
whatever table you want, up to you.
Yes.
You can combine or you want to. This is a function by function.
Yes.
Up to you.
Mm.
Where we do the scaling is in the function block.
Where we do the
Scaling.
scaling of your analog input,
Yes.
converting the
Signal 4 to 20 to maybe temperature.
Okay.
Maybe it's
Okay, good question. Number 1, if 4 to 20, when you go to the PLC, it becomes some value. It no more 4 to 20. When you go to PLC, it becomes 0 to 27,000.
Okay.
Okay, so the analog will be done but I think next week, next weekend. Okay, so it becomes 27,000. Now the 27,000, I do program, I do scale into temperature.
Right.
That one we will be doing in the program blocks.
In the program block.
Yes.
Okay.
But if your direct temperature, then you go to, okay, you close this one first.
If it's a direct RTD,
Yes, direct RTD, good question. You can close that. Close. You select, no, okay, you take one of the analog input, go up. Analog input, you take, okay, go to AI. You select the which one can select double, okay. The 4i, yes. Okay, double click. Okay, you select this one, okay, properties.
okay.
Okay, go to general, go to channel 0. Okay, so you check here. Go to general. Wait, I want to see where I want to change. Okay, go to module parameter. Yeah, AI configuration. Here configuration. Okay, can you change this one? Can change. Automatic setting, manual, then select here. So it's what? resistor means RTD, right?
Yes.
This is a thermocouple. Let's say the resistor 3 wire.
Oh, all using the same module.
Mm.
Choose different.
Yeah, because this is the one module with all. Okay. Resistor 3 wire. Then here. Okay. Go to channel 0 here. No, channel 0. Resistor 3 wire. Okay. Go up. No, change the other one. Thermal resistor, I think so. Ah, okay. So you choose PT, right?
Yes.
So this one is indirect. RTD, direct, okay. Then the value straight away in Celsius. So this one no need to do scaling.
Yes, no need to do scaling.
If 4 to 20, then only I need to do scaling.
Yes.
Because if this one at the address at the channel 0 there, you go up. What is the channel 0? Go up.
But when you say no need to do scaling, this is a coefficient it give you select lah.
Yeah.
Then it will automatically show the temperature here, right?
Yes.
Which is correct.
Yes.
And of course, I mean, to be fussy about it, then how about the ETA? This what you call this pull plug, then pull wire. Let's say normally if you 4 to 20, if you read 0, then you can immediately display a alarm, right?
Yeah.
In this kind of situation, it also
This one I don't think so. We'll have that because this one is straight away 0 to
yeah.
Yeah.
You don't see the 0
yeah. But
already.
normally what happens this time, but need to check the manual. Normally what happens, if the cable is unplugged, okay, connect the cable, you will get a temperature. If the cable is unplugged, normally the value overshoot, go to the maximum number.
Right.
So maximum is 100, right? So it will overshoot maximum to 110 or something.
Right.
So what happen? You can use the 110 value, do some programming to show that cable loose or something.
Okay, I got it. I have to do another type of programming.
Yeah, of course.
Yeah. Okay.
Even 420 also need to do programming. Okay, you go here.
Okay.
Okay, channel 0, right? You go to IO address. Channel 0 is what? Start with 190 lah, for example lah. Okay, I just give you this one, last one. Okay, so they tell you is 100, but this is what we will learn next week. No worries. Okay, I just give you some introduction, just one idea lah how it works. Okay, means IW 190, right? Okay. If let's say you use the RTD directly, just now we do the settings, right? Okay, so what happens? Here itself straight away you will get 0 to 100 degrees Celsius. Depend on your PT type, what the PT type you are using. Okay, and also the if you choose M at IW under 90 because M is 4 to 20 million, right? So I need to choose here 4 to 20 or 0 to 20. Okay, you go to
Another
no, same. The same one you can choose because I can select one. Go to the channel 0. Go to manual. Okay, here. Choose 2 wire or 4 wire current. Okay, 4 to 20, right? I can choose also. You click here.
Oh, so you go back to a normal
Analog.
already.
So this one won't get the temperature thing. Okay, you click here.
So
Yeah. Only 4 to 20. So what happens here? You won't get temperature. You will get 0 to 27.64.
So this is the IO190 reading.
IO190 reading.
Something between 0 to 2760.
Yes. So 20 million means it's 100 degree. So in the PLC you will get this number. So this is the number we will be doing scaling to 0 to 100 degree.
if I here I choose the RTD function,
Yeah, this one, yes.
then my
Reading.
IW190 is something like 50
Yes, straight away the temperature.
straight away the temperature.
Yes.
Then 50 go to the PID or go to whatever.
Yeah, whatever you want to do PID, want to do some calculation, everything, straight away use this number. In this case, I need to convert from this to this, then only I can use. This is what they do, they call scaling.
I got the point.
Ah.
Do you think in the end of this project we can do some simple program like one PID loop and then
Can.
yeah.
No problem, can. I have an oven there. You can see down there. I have an oven.
Oh,
So there's a heater there. There's a heating coil. Then we have a temperature sensor. So I have a temperature controller with a 4 to 20 milliamp. We connect to the PLC, take the milliamp value, convert into temperature, then use the temperature to maintain the temperature inside the oven. Can, no problem.
okay. That is really something very, very
Okay.
strong enough. Yeah.
Can, no problem. So I just give you ideas, all that, how to do that, okay? If let's say you forget also, you know it's there. So you can use YouTube or use the manual, everything.
Yeah.
Can, no
Yeah.
problem.
Okay. Okay.
But just remind me, because I need to take note. Because in middle I have 5 days training, right? Of course I forget. That's why I need to wait, know something. Later I take picture.
Oh, okay.
Mm.
Because
Straight 5 days is okay. In between that 5 days training, I always I forget.
I mean, just like alignment is like, I mean, to be honest, just like you say, if I go to every single detail of the programming function,
Hmm.
I don't think I need it. But I need something more high level, right?
Can.
But also, I need to know is at least I can build a function or build a program that is working
Yes.
from the hardware configuration,
Mm.
how to terminate, how to wire, how to configure everything, until the programming, how to build a standard push button plus the VFD control,
Yes.
plus the PID control.
Mm.
Then if I can know all this, I think I roughly can tell the whole plan how to do the programming with further study.
Yeah, of course.
Yeah.
Of course. Because the main thing you have to understand the concept, everything.
Right.
Then later
right.
on, if you have anything new, so you know what to search. That's the most important.
Right, know what to search, know
Yes.
where is it,
Yes,
how to
because
find
even
it.
I
yeah.
also PID I learned from YouTube.
Okay, okay.
This VFD control, what happened? When my boss buy, so I sent to his house. He do something, then he also go to YouTube and see everything. He give me one manual. So I use the manual, but still I go to YouTube and see how the control to understand the basic concept.
Right.
Once I understand, then I know how to do.
Yeah, then
But the main thing is you need to know what to search. That's the problem.
yes, know what to search. If I do this, then the next time, different thing, I
You
know
know
what
already.
is
Yes.
what I have to do already.
Very simple. PLC, you want to control any device. First, you must understand the PLC first. Okay,
Right.
what the PLC need?
Right.
Digital input, analog input, communication. So communication, what type of communication? Profibus, Modbus, Profinet. So these are the type. The PLC can accept this type of data protocols. Okay.
Yes.
Now your device. Now the device, what the device can give you?
Yes. Yes.
Digital, analog, Profinet, Profibus, Modbus, or
Yes.
IO link,
Yes.
MQTT, OPC, whatever.
Yes. Yes.
Then
So all
just
this
go to
how to
Google or
configure.
just go to the hardware and learn.
Yeah, at least know already, just like you say. Next time, then I know where to look for what information. I
Yes,
look
yeah.
for the manual. I
Yes.
look for look in the device list. or
Yes,
whatever.
even if you know how to program this Siemens drive, later on when you do another brand of drive, so you get the idea how this one works.
Right.
That's how
right.
I go troubleshooting actually. I work with these two drives. This one using communication, that one using analog.
Okay.
Okay. So when I do training on these two, so whenever I go to company troubleshoot any drive also, I know how the drive works. So I know what are the data I need to search.
I got your point. And the last thing is, if
Yes.
we can complete everything here,
Yes.
and I have actually a very big focus is on the site commissioning.
Yes.
Look check.
Yes,
function
yes.
test,
Tomorrow we will do
troubleshooting.
wiring.
Okay.
Tomorrow I will be using this one.
Okay.
Like the spot
Okay.
and down there we have. I will do wiring.
Okay.
Then I will tell you, tomorrow I will teach you how to use the power supply, which power supply to use, everything.
Okay. Okay. Yeah.
Okay, no problem.
Okay. Thanks a lot. Thanks a lot. Okay. Yeah. So today is
So once you've done, once this 5 days done, okay, later on you want to, focus on, like say, Modbus programming.
okay.
Teach me Modbus programming or teach me data logging.
Okay.
Then you can come for like 1 day training.
For
Only for
special
specific.
advanced.
So your workers already know the basics, everything you know. So just need to know okay how to. So you have a device, no problem you can bring. Normally I have my participant after the training, like sometimes they want to, sometimes they ask me, I send some videos and they say no, I don't understand, you teach me. So I said okay, I'm gonna come for 1 day training. So sometimes they will bring the device. Sometimes they have a project. Try cannot. What they do, they will bring both the PLC and let's say and one instrument. Want to use a Modbus, cannot communicate. They try cannot. They will bring here. You know what? They actually can do, but some of the terms they don't understand. So they cannot crack that. Why this one? Why I need to do these values, everything. So once they come, when two brain work together to do something right, then it can work. That's why I do a lot of things. My participant. Sometimes
It's a very good thing that you really know how to customize all the.
Yeah, because the thing is, I also learn something. Because that one help for me when I do projects also.
Okay.
Yeah.
Yeah. Alright.
Alright.
Okay. It's a very good day. Okay.
Yeah, a lot of things. I think these 5 days will be a lot of information.
Right.
Luckily, you want to write, architecture, everything can keep.
Okay. So should I turn off this? Laptop?
Yeah, can power off.
By the way, the tomorrow I get from you the software can.
Can. You
Okay.
just give me the pen drive.
Okay.
I will forward to you, and I will forward to you the additional software.
Oh, I give you now so you can copy or something tomorrow morning when I come in.
In the morning also can give you.
Okay lah. Yeah.
Just remember. I will give you what version you want. 80 or 18?
You suggest have to
18 okay lah.
18
18 is still stable.
Oh.
20 I haven't tried. I have to.
Oh, you also haven't tried.
I haven't
Okay.
tried.
I think it's good for you.
I'll give you 18. But if you face any issue, I give you another software also.
Okay, sure.
If you face any issue, you can install that software.
Okay, boss.
Okay, very good. Okay. Alright.
The balance payment once you transfer, you send me the receipt.
How is that has to be done? You give me the invoice or what is it?
No, I think in the invoice I give you, right?
Oh, okay.
The total.
Oh, the balance payment normally is today you want the balance payment or?
Yeah.
Normally today lah, yeah.
The first
Okay.
day. No problem. Tomorrow also can.
Tomorrow also can, yeah.
Okay. Let me do this by today.
Yeah.
Okay, sure.
Okay, alright.
No problem.
Thank you.
Okay.